All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Welcome to Unacademy NEET English. Guys, let me know in the chats if I'm perfectly audible, visible to each and every single student. Okay, and make sure everybody of you, okay, make sure everybody of you smashes the like button because liking the session means marking the attendance. Okay. And my dear NEET aspirants, listen to me very carefully. In this is going to be the most important session among all the four sessions. Part 1 11th, part 2 11th, part 2 12th. This one is the part 1st of 12th. Extremely important. Why? Because it has electrostatics from which you can expect 5 questions. Extremely high weightage chapter. You have current from which you can expect 5 questions. Extremely high weightage chapter. And then, my dear NEET aspirants, you have, we say magnetism, you can expect 4 questions. And then EMI AC, you can expect 3 questions. So approximately this session will cover, I would say, 70 marks of yours when it comes to your NEET physics. So that's why I'm saying this is extremely important. Make sure you watch till the end because I'll be teaching you every single thing from the scratch. And my dear NEET aspirants, we will be talking about all the problem patterns. Okay, just the concept, then we will move on to the problems. The concept, then we will move on to the problems. That's why I'm saying this is extremely important. I don't want you guys to miss any of the topics over here. Okay, this is a request to each and every single student out there. My dear NEET aspirants, when it comes to the topics that I'll be covering, electrostatics, capacitors, you have current electricity, you have magnetic effects of current, and I am not going to leave any of the topics out there. You have magnetism and matter, you have EMI, and you have AC. So this session is going to cover your, I would say, 70 marks. I would say 70 marks. Okay, 70 marks approximately. So I don't want you guys to lose these 70 marks. Please stay till the end. Call up your friends, okay? Tell them this session is extremely important. Okay, that's why I'm telling you in this particular case. Okay, so shall we begin? Please let me know in the chats with the fire emojis if everything is perfectly fine. And most importantly, do smash the like button because liking the session is extremely mandatory. Like this session means mark the attendance. Quick, quick, quick. Do it. Okay. Yes, yes. Yeah, there are some, like, see, there are only 2-3 chapters in the portion class 11th. Don't worry about that. I'll complete those also. Take a chill pill. Okay, let's complete this 11th, 12th part 1, 12th part 2. Then I'll cover those 2-3 chapters also. You don't have to worry. So, my dear NEET aspirants, let's first start with the chapter 1, that is electrostatics. Okay, and when it comes to the electrostatics, the first thing you need to understand the charge. I am going to start from the scratch and I'll show you all the problem patterns. So do not worry about anything. Okay. Yes. So my dear NEET aspirants, let's first talk about charge. What does charge actually mean? See, let me give you the simple example. Let's suppose you have a comb over here. You have a comb over here. Okay. Let's suppose you have a comb over here. You have a comb over here. Just a second. Yes. So my dear NEET aspirants, let's suppose this is a comb you have. Now you are rubbing this comb with your hair, something like this. Okay. And you have some piece of papers placed over here, small piece of papers. Sir, you have a comb and you are rubbing this comb with your hair. And there are some piece of paper, small piece of papers placed over here. Could you please tell me if you take this comb near to these piece of papers, what is going to happen? Sir, obviously we have done this experiment in our school. So this comb is going to attract these piece of papers. It is going to attract these piece of papers. Okay. Attraction will be there. Attraction will be there. Okay. Yes. Now, if I say, my dear NEET aspirants, if you do not rub this comb with your hair, if I don't rub the comb with my hair, then if I take this comb near to the piece of papers, will it attract these? Will it attract these small piece of papers? Obviously not, sir. Why? Because you have not rubbed the comb with your hair. So when you rub the comb with your hair, my dear NEET aspirants, we say something gets occupied on this, something comes onto this. So this something is what we call charge. So because of this charge only, it is able to attract this piece of paper. So when you rub the comb with your hair, what happens is that we say charge is occupied onto this comb. Or you can take the example of the pen also. And then because of that charge, my dear NEET aspirants, you can attract these small, tiny piece of papers. So can I define charge? It is something due to which a body attracts or repels another body, or due to which a body shows electrical and magnetic effects. I would say a property due to which a body attracts or repels another body. As simple as that. This is how we define charge. So if I say charge is occupied onto this comb, it is going to attract the piece of paper. So it's because of charge only. Now, my dear NEET aspirants, if I say, sir, what is the symbol of charge? How do you say symbol? Symbol of charge simply is Q. Like you say, what is the symbol of mass? M. Sir, M is equal to 2 kg. M is equal to 4 kg. M is equal to 7 kg. That is how you define the mass. That is how you say the symbol of mass. Okay. And when it comes to the SI unit, my dear NEET aspirants, you simply say SI unit is Coulomb. Sir, let's suppose if I say this is the comb over here. Sir, you rub the comb with your hair. How much charge is onto this comb? We say, sir, 2 Coulomb charge. Q is equal to 2 Coulomb charge. Q is equal to 5 Coulomb charge. Okay. Like you say, if you have a body over here, if you have a brick over here, you say, sir, mass of this brick is 2 kg. What is the SI unit over here? Kg. What is the symbol over here? That is M. M means mass. M means mass. Now, if I say how many types of charge are there, we say, sir, there are 2 types of charge. We say positive and negative. Positive and negative. Now, my dear NEET aspirants, if we place a positive charge near to a positive charge, like if I have a rod, okay? And my dear NEET aspirants, if I have another rod, if I'm placing charge on this rod is positive, charge on this rod is positive. If I'm placing these 2 charges near to each other, positive, they will repel. So positive and positive basically repels. This is how we show repulsion. And then we say negative and negative, my dear NEET aspirants, they will also repel. They will also repel each other. Why? Because like charges repel and unlike charges attract. And if I place a positive charge over here, if I place a negative charge over here, my dear NEET aspirants, these are going to attract. This is repulsion. This is repulsion and this is attraction. So we say similar charges, I would say repel, and unlike charges or like charges repel, unlike charges attract. Okay, please tell me in the chats if this is crystalline clear till over here. This is the definition of charge, how we define the charge. Okay, charge is something due to which a body attracts or repels another body, due to which a body shows electrical or magnetic effects. Please let me know in the chats quickly guys. Let me know in the chats if everything is crystalline clear till over here. Okay. Yes, absolutely. Let's move on to the concept. This is what we call, my dear NEET aspirants, Coulomb's law. This is what we call Coulomb's law. I would want you guys to understand this very carefully. I would want you guys to understand. I'll be showing you all the problem patterns. You don't have to worry about anything. Okay. Listen. Let's suppose, my dear NEET aspirants, you have a charge Q1 over here. This is a positive charge. And you have a charge Q2 over here. This is also positive. Okay. You have got 2 positive charges over here. Okay. Now, if I say, sir, will these 2 positive charges, which are placed at certain distance, let's suppose R, will they attract or will they repel each other? Listen carefully. We said this positive is going to repel this positive, something like this, and it will apply the force F. This positive charge will apply force on this positive charge in this direction because both are positive. Push-based force. Okay, in this direction. And when I say this force is what we call the electrostatic force. This force is what we call electrostatic force. Electrostatic force. Electrostatic force. So means, my dear NEET aspirants, whenever you have two charges, they apply force on each other. What do we call that force? That force is electrostatic force. Like you have two masses. I told you in the last class, you have two masses. The two masses attract each other with what force? Gravitational force. So here they are repelling with electrostatic force. Now we say this electrostatic force is directly proportional to Q1, Q2. My dear NEET aspirants, it is obvious. If you keep small charges over here, 1 coulomb, they will no doubt apply force on each other. Okay, repulsive or attractive. But if you place 100 coulomb, they will apply large force. So bigger is the value of magnitude, bigger is the force. So F is proportional to Q1, Q2. And my dear NEET aspirants, we say F is inversely proportional to R square. So if you keep the two charges far from each other, we say force is going to be less. If you keep the two charges close to each other, we say force is going to be more. So can I not say, my dear NEET aspirants, force is inversely proportional to R square? Distance between the charges is large. We say force is going to be less. Okay. And one more important thing, my dear NEET aspirants. Okay. I would want you guys to join my Telegram channel. That is because I'll be sharing all the updates, all the PDFs over here only. So that is t.me/YAWARMANZOOR. t.me/Yawar Manzoor. You can search it in the Google and you will land onto this one. Okay. 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 Because I share all the updates, whatever we have in this Telegram channel only, Okay. Now, my dear NEET aspirants, we say this force is proportional to Q1, Q2. This force is inversely proportional to R square. So we can say in this particular case, combining the two equations, I can say force is proportional to Q1, Q2 divided by R square. We can write it all together. Now I can replace this with a constant. So that constant is actually K. So I would say this is Q1, this is Q2 and divided by, I would say, R square. So what is this K? K is what we call Coulomb's constant and its value is 1 by 4 pi epsilon naught. And this epsilon naught, my dear NEET aspirants, this is called permittivity of free space. Permittivity of free space. Of free space. As of now, please remember it directly because after some time I'll be explaining what is permittivity of free space, relative permittivity, permittivity of the medium. Okay, yes. So in this particular case, my dear NEET aspirants, we say force between the two charges K, Q1, Q2 by R square. And K is what we call 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. And the value of this epsilon naught is, I would say, 8.85 into 10 raised power minus 12. Then we say Coulomb square upon Newton meter square. This is the value of epsilon naught. And one more important thing, guys. See, 1 by 4. What is the value of pi? 3.14. What is the value of epsilon naught? 8.85 into 10 raised power minus 12. If you put it over here, 1 by 4 pi is 3.14, put the value of epsilon naught. And then when you solve, value of K comes out to be 9 into 10 raised power 9. Okay, Newton meter square upon Coulomb square. So my dear NEET aspirants, you will be directly remembering from now onwards, this is the value of, I would say, K, and this is the force between any two charges. This is the force between any two charges. This is the force between any two charges, and this is the value of K, this is the value of epsilon naught. These are the two things that you are going to remember in this particular case. I believe everything is crystalline clear. Okay. And this force can be attractive as well as repulsive. If this charge is positive, this is negative, then force will be attractive towards each other. Okay. Now, my dear NEET aspirants, one more important thing I just want to mention over here. Okay, this is basics. This is basics. Basics. Okay, class 11th. Vectors. See, guys, what I'm trying to say in this particular case is, let's suppose you have two vectors over here. First one is called F1. And let's suppose you have another force or vector that is F2. Angle between the two vectors is, I would say, theta. This is the theta angle between the two vectors. If somebody asks you, what is the resultant of the two vectors? What is the net force of the two vectors? From now onwards, you'll be remembering, if you have two vectors, you have to find the resultant. You'll be simply saying, sir, resultant is going to be under root of, that is F1 square, plus I would say F2 square, plus 2 times of F1, then we say F2, then we say cos of theta. This is going to be the resultant of two vectors. This is going to be the resultant of two vectors. Okay. Now, my dear NEET aspirants, if let's suppose you have, if theta is equal to 0 degrees. What does that mean? That means you have a block. On this block, forces acting in this direction, forces acting in this direction. When the two vectors are parallel, then we say angle is 0 between the two. So whenever angle between the two is 0, and this F1 is F, and this F2 is F, similar. We say in this particular case, I would say net force is going to be 2F. So shall we directly remember this? Absolutely, because you don't have time to do it again and again. Okay, so that is 2F. Sir, what if this is 2F and this is 3F? Then in that case, what is going to be the answer? Then you will be putting up this formula. F1 square plus F2 square plus. Sir, if both are similar, then only we can say yes. If this is X, resultant will be 2X. If this is Y, resultant will be 2Y. That's what I am trying to say. Next, my dear NEET aspirants. Next, we say if theta is equal to 180 degrees. If theta is equal to 180 degrees, what does that mean? This is a block over here. On this block, force acting in this direction is F. Force acting in this direction is F. Guys, this is 0 between the two. This is 90 between the two. This is 180 between the two. This is 270 between the two. And this is 360 between the two. So we say in this particular case, always remember net force is 0. Sir, this is only true when both the forces are equal, F and F. Then only we can say it something like this. Then, my dear NEET aspirants, we say if theta is equal to 60 degrees, this is the block over here. On this block, a force is acting in this direction, F. Force is acting in this direction and angle between the two is 60. So you can directly say over here, resultant will be net force is going to be root 3 of F. Because this will help you to solve a lot of problems in this electrostatics. Okay. Then, my dear NEET aspirants will be directly remembering if theta is equal to, this is 60. If theta is equal to, I would say 90 degrees. Okay. Like this is the block. On this block, forces acting in this direction. On this block, forces acting in this direction. Angle is 90. In this particular case, you will be directly resultant is going to be, that is a root 2 of F. Root 2 of F. And then, my dear NEET aspirants, if I say if theta is 120, degrees, like this is the block. On this block, forces acting in this direction, forces acting in this direction. Angle between the two is 120 degrees. In this particular case, my dear NEET aspirants, you will be saying resultant is going to be F. Resultant will be F when, my dear NEET aspirants, angle between the two vectors is 120 here. Net force is going to be F. So you'll have to directly remember when theta is 0, resultant is 2F. When theta is 180, resultant is 0. When theta is 60, resultant is a root 3 of F. And when theta is 90, resultant is root 2 of F. When theta is 120, resultant is F. And it is only true when both the forces are similar. If not similar, then you can use this formula. I have told you both. Now, guys, let's move on to the question number first. This is a very important pattern in this particular case. This is a very, very important pattern in this particular case. I would want you guys to focus exactly over here. Okay. Listen carefully, my dear NEET aspirants. See. Electrical force between 2-point charges is 200 Newton. Okay. See guys, it says that you have got a charge over here Q. You have got a charge over here Q. Distance between them is, let's suppose, R. It says force between the two is 200 Newton. Sir, force between the two will be how much? K. Q into Q means Q square divided by R square. This is the force between the two. And this is given as 200 Newton. Absolutely, sir. Then it says if we increase 10% charge on one of the charges, we are increasing 10% charge on one of the charges. See, finally what is happening? Listen carefully. This is QA. Guys, if I say initially how much, if I say this is the pen, how much pen is this? 50%, 70%, 100%. 100%, sir, complete pen. 50% pen, it is not 50%. Then you would have said it is 50% pen. Okay, like if this is a box, this 100% box, complete box. Similarly, my dear NEET aspirants, if I say this is charge Q, how much Q? 50%, 20%, 100% Q. Now listen carefully. You are increasing 10% charge on one of the charges. Increase 10% on this. If it was 100%, you are increasing 10%. How much is going to be now? 110% of Q. Absolutely, sir. Sir, what if I would have increased 30%? Then it would have been 130% of Q. And how can we write this? See, we can write it like this. 110 divided by 100 of Q. 110 divided by 100 of Q. This is a very important pattern. Frequently questions have been asked from this pattern. Okay, 110 divided by 100. Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. We say this and this will be cancelled, so it will become 11 divided by 10Q. See guys, if I say 30%, we can write it like this. That means 30 divided by 100. Sir, 40 means 40 by 100. 60 means 60 by 100. So 110% Q means 110 divided by 100 of Q. So 11 by 10Q. So if you increase 10% charge on this one, so how much it is going to be? It is going to be 11 by 10Q. Okay. Then, my dear NEET aspirants, we say this QB. We say this QB. Now it says, if we increase 10% charge on one of the charges and decrease 10% charge on other, we are decreasing 10% on this one. It was 100% already. Now, if you are decreasing 10%, so how much it will be? 90%. So you will be saying over here, this is 90%, 90% of Q. So can I write that? That will be 90 divided by 100Q. Absolutely, sir. This and this will cancel. So it will be 9 divided by 10Q. Yes, this is the detail till now. Then it says, then electrical force between them for the same distance will be. Now, if you did this, increase 10% here, decrease 10% here, what is going to be the new electrical force between the two? Listen guys carefully. Can I write it like this? Can I write it like this? I can say this is 11Q divided by 10. I'll put it over here. Okay. And second is 9 divided by 10Q. I'll put it over here. And distance between the two is, I would say, R. Now, my dear NEET aspirants, what is going to be the new force? F dash is K. Q1, Q2 by R square. Q1 is 11Q by 10. Okay. Q2 is 9Q by 10. 9Q divided by 10 divided by R square, because they are placing at the same distance. So can I say over here F dash is going to be, see, 9 into 11 is how much? 99. Okay. And in this particular case, 10 into 10 is how much? We say 100. Okay. And then, my dear NEET aspirants, we can say you have K Q square divided by R square. This K, Q into Q becomes Q square divided by R square. Now, what is the value of, my dear NEET aspirants, K Q square by R square? K Q square by R square is 200. So you can write it like this also. 99 divided by 100 into, I would say, 200. So so 2 into 99, that is 198 Newton. So new force between the two is 198 Newton. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Everyone means everyone. And do smash the like button, because liking the session is mandatory. Liking the session is mandatory. Tell me guys if this pattern is crystal and clear to each and every single student. Quick. Then you have a similar pattern on this one which was asked in NEET 2019. Similar pattern on this one which was asked in NEET 2019. Listen carefully, my dear NEET aspirants. Listen carefully. Come on, guys. That's great. Okay. Now, what does the question say? 2-point charges A and B having charge plus Q and minus Q. Right now, you have 2-point charges plus Q and you have minus Q. Respectively, are placed at certain distance apart. They are placed at certain distance apart. Force acting between them is F. Between these two, force acting is F. Between this and this, force acting is F. And how much is that force? F is equal to K Q1 Q2. Ignore the negative sign, just directly remember Q1 Q2, that is Q square, divided by, I would say, R square, divided by R square. Okay. And then it says this force is F. If 25% charge of A, guys see, if 25% charge of A is transferred to B, 25% charge of A is transferred to B, 25% of this is transferred to B. Okay, so 25% of positive 25% is transferred to B. Okay, yes. Now guys, if I say this is happening, what is going to be the remaining charge on A? 100% it was already, my dear NEET aspirants. If you transfer 25%, how much it is going to be? 75%. Okay, 75% of Q. 75% means how much? That is 75 divided by 100 Q. So we can write it 25 3s are, 25 4s are. This will be 3Q divided by 4. So final charge in this case is going to be 3Q by 4. And if I say, my dear NEET aspirants, QB, listen to me very carefully. Listen to me very carefully. This is important. It was 100% positive. Sorry, it was negative 100%. Negative 100% already. Guys, if I say it is minus Q, how much? 50%, 70%, 100%, 100% negative charge. Then you are adding plus 25%. Plus 25% of Q. This is important. Listen carefully. Now guys, if I say charge here is minus 4 Coulomb plus 2 Coulomb. What is the net charge over here? You say minus 4 plus 2. That will be minus 2 Coulomb is the net charge. Minus 2 Coulomb is the net charge. Similarly here, minus 100% plus 25%, minus 100 plus 25, it is going to be minus 75%. Minus 75% of Q. So what you will be writing over here, minus 75% means minus 75 divided by 100 Q. So 25 3s are, 25 4s are. This will come out to be minus 3Q by 4. Minus 3Q by 4. Now, then it says, then the force between the two charges becomes, what is going to be the force between these two charges? So my dear NEET aspirants, can I say finally these two charges will look something like this? Finally, these two charges will look something like this. So this is going to be, that is 3Q divided by 4, first one. And this is going to be 3Q divided by 4, second one, minus 3Q by 4 now. Okay. And distance here is R. Now, what is the new force? New force is F dash is equal to K. Q1, Q2. That is 3Q by 4. Okay. That is 3Q by 4 divided by, I would say, R square. So F dash in this particular case will be K. 3 into 3 is, my dear friends, 9. Q into Q becomes Q square divided by 4 into 4 is 16. And then we say R square. Now tell me KQ square by R square. KQ square by R square is F. So this will come out to be 9 divided by 16F. This is 9 divided by 16F. I hope this is crystal and clear. Guys, give me the signal in the chats if this is clear. Give me the signal in the chats if this is clear. Come on, quick. Tell me guys, quickly in the chats if this is crystal and clear to each and every single student. Quick. Okay, that's great. That's great. Let's move on to the next one. This is also an important question. I would want you guys to understand this very carefully. See, guys, I would want you guys to understand very carefully. You have got a square over here, and in this square, negative, see. Whenever you find the magnitude of force, whenever you find the magnitude of force, ignore the negative sign. But here, when you calculate the net charge, don't ignore the negative sign. See. When you find net charge, don't ignore negative sign. Minus you include over here. But when you find force, ignore the negative sign. This negative is not required when you find the force. That's what I'm trying to say. Okay, when you find the magnitude of force, just charge first, charge second, divided by r square. Is that clear? Yes. Now take a look, guys. Take a look. You have got a square over here. On the square, you have charge minus 2 Coulomb, plus 4 Coulomb, minus 2 Coulomb, and this is 2 Coulomb. And in this particular case, you have to tell me what is the net force on 2 Coulomb charge. 2 Coulomb is this corner charge. See. On this corner charge, how many charges are applying force? 1, 2, and 3. This minus 2 Coulomb will attract this minus plus 2 Coulomb towards itself with a force. Let's call this as F1. Yes, sir. Let's find the value of this F1. F1 is actually K Q1 Q2 divided by R square. Now guys, K means K. What is the value of Q? Q is the first charge. Q2 is the second charge. Q1, Q2. Consider this 2. And this minus 2, consider this plus 2. Why? Because I said, when you find the magnitude of force, consider negative also as positive. Because you are finding the magnitude of force. Do it, I am telling you. Divided by R square. If this is a square, this is 2 meter distance. This will be also 2 meter distance. That is 2 square. Yes, sir. So can I say this 2 into 2 is 4, 2 into 2 is 4. So F1 will come out to be K. Cool. Then find the net force between this minus 2 and this 2. See, this minus 2 is basically attracting it towards itself because minus 2 attracts the positive charge. So this will be F2. So I can say in this particular case, F2 is K. Q1. Consider this Q1 as 2. Consider this Q2 as 2 also. Divided by R square. This side is also 2 square. This will cancel. 2 into 2 is 4. 2 square is 4. This will be also K. Absolutely, sir. Then take a look, guys. This 4 Coulomb is going to repel this 2 Coulomb. Why? Because this is positive and this is also positive. So it is going to repel it with a force. I would say which force? Consider this as F3. Consider this as F3. So what I can say over here, sir, F3 will come out to be K. Q1, Q2. Guys. If side is 2, always remember square of the diagonal. Diagonal of the square is 2 root 2. So K, Q1 is 2. This is Q1. Q2 is 4. Okay. Divided by distance between the two. That is 2 root 2. So it is going to be 2 root 2 whole square. K, Q1, Q2 by R square. Now what can I write in this particular case, guys? 2 into 4 is 8. 8K upon. Now see, 2 square is 4 into root 2 whole square is 2 because square and root will cancel, so it is 2. 4 into 2 is also 8, this 8, so this will also come out to be K. Now if you check on this charge, we say F1 is K, F2 is K, F3 is K. So I can show it like this. On this charge, F1 is in this direction, that is K. F2 is in this direction, that is K. And F3 is in this direction, this is also K. F3, F1, F2. Now if you check this and this, angle between the two is 90. Now come over here. I told you, if the angle between the two vectors is 90, F, angle is 90, resultant is root 2F. If this is X, resultant is root 2X. If this is Y, resultant is root 2Y. Now, in this question, We say this is K, this is K, angle is 90. This is going to be root 2K. Absolutely, sir, without a shadow of doubt. So net. Now, my dear NEET aspirants, listen carefully. So we say in this particular case, we say now ignore these two because you have already mentioned their resultant. On this charge in this direction, we say it is root 2K. Okay. And in this direction, I would say it is K. It is K. Root 2K and it is K. Now, my dear NEET aspirants, we can say here, I would say when it comes to the net force in this case is going to be, that is this force minus this force. Guys, see. If I say this was K, this was K, then I would have said that resultant is 0 because they would cancel out each other. But since this is root 2 times of K, this is K. In this particular case, we say bigger force minus smaller force. So this is going to be a root 2K minus K. So this is going to be, take this K common. So it will be root 2 minus 1. Sir, what if both the two forces were in the same direction? Then I would have said a root 2K plus K. So here it is root 2K minus K. Please tell me in the chats if this is clear. Come on, guys. Quick. Tell me, is this clear? Quick. Give me the signal in the chats, guys. Is this clear? Is this clear? Come on, guys. Yes. One more question which is important from this pattern. I need the signal from every single student, guys. Whosoever is watching, let me know in the chats if this is crystal and clear to each and every single student. Come on. Okay. Now take a look over here. A particle of mass m carrying a charge minus q1, okay, is moving around plus q2. See, guys, what does it say? It says that there is a charge over here. This is plus q2. And there is another charge over here that is minus q1. And its mass is m. It is moving around this charge. Let's suppose this distance is r. Then it says in a circular path, find the time period of this charge particle. See, what does time period mean? Let's suppose this is the center. This charge is moving in a circular path, something like this. So if this charge started from this point, so it goes in a circle and reaches the same point again. So how much time it is going to take in completing one cycle? That is what we call the time period. How much time it is going to take in completing one cycle from where it started? That is what we call the time period of the charge. Now, guys, in this particular question, I would want you guys to remember one thing. We say here, if you have two charges, first is electrostatic force that will act for sure. Because you have two charges at r distance, electrostatic force will act. Okay. Okay. Then we say, if the charge or the particle is moving in circle, okay, if it is moving in circle, it will have the centripetal force also. Because whenever the body moves in circle, we say centripetal force acts. So here, centripetal force also acts. And that centripetal force will be equals to the electrostatic force. Please directly remember this. Whenever you find a charge is revolving any other charge, we say over there, two forces act, electrostatic and centripetal. Both will be equal. So when I write electrostatic force, that is K, Q1, Q2 divided by R square. Okay. When I write centripetal force, you can say M, mass of this charged particle which is revolving, R is the radius, and then we say omega square. Omega is the angular speed. With what angular speed it is revolving? Okay, two speeds. See, guys, an object is moving. Sir, how fast it is moving. An object is revolving. Okay. How fast it is revolving, that is angular speed. mr omega square. So in this particular case, my dear NEET aspirants, what you are going to do is that take this over here. So omega square will come out to be k q1 q2 divided by m into r becomes r cube. And one thing I just want you to remember over here, this omega, we say it is 2 pi divided by t. Omega is 2 pi divided by time period. And what is time period? How much time it is going to take in completing one cycle. Now you can write over here 2 pi, or take the square over here. Omega will come out to be k q1 q2 divided by m into r cube under root. Because if you take the square over there, it will become whole root. Now omega you can write 2 pi divided by t. It is under root of, that is k q1 q2 divided by m into r cube. Now do the reciprocal. So t divided by 2 pi will come out to be under root of m into r cube divided by k q1 q2. Okay. Then my dear NEET aspirants, what you can further say, take this 2 pi over here. So t will come out to be 2 pi under root of, then we say m into r cube divided by k q1 q2. k q1 q2. This is going to be the time period in this particular case. This is going to be the time period in this particular case. In how much time it will complete one cycle. Okay. So I would say 2 pi under root of m into r cube divided by k, q1 and q2. Please give me the signal in the chats if this is clear. Come on guys. Clear. This is important. This, whatever the questions I am showing you, all are important. All are important. Okay. Okay. Like this pattern, everything is important. Okay. One more question. This is also important. This is also important. Find the value of Q so that the system is in the equilibrium. You have to tell me the value of charge Q so that the system is in the equilibrium. See guys, system is in the equilibrium means net force on the system is 0. Okay. Net force on the system is 0. Now my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. Find the value of charge Q so that the system is in the equilibrium. Let's suppose if I say this block is in the equilibrium. What does that mean? That means the force acting from this side will be equals to force acting from this side. And then we say in this case, net force is 0. So if the block is at rest, it will remain in the rest for sure. Forever. It will not move forward. It will not move backward. That's how we define the equilibrium. Now take a look guys here. It says find the value of this charge minus Q so that the entire system is in the equilibrium. Listen carefully. So that the entire system is in the equilibrium. Guys, whenever you have a question of this sort, do one thing. Make the charge in the equilibrium. Make any charge in the equilibrium. Corner charge. Corner charge. Okay. Balance the forces on any corner charge. Corner charge. Please remember the approach over here. Balance the forces on any corner charge. What does that mean? Listen carefully. Tell me on this corner charge, let's suppose side is A. On this corner charge, how many charges are applying force? 1, 2, 3 and 4. See guys, I would say this distance would be A divided by under root of 2. Because if side is A, half of the diagonal is considered as A divided by under root of 2. Yes. Now boys and girls, this plus Q charge is going to repel this plus Q charge in this direction with force F1. And how much is this force? That is K Q1 Q2 Q square divided by A square. Because this side is A. This plus Q charge is going to repel this plus Q charge with, let's suppose, F2. And how much is this force? That is K. Q into Q becomes Q square divided by a square, because this side is also a. This charge is going to apply force on this charge in this direction. Let's call this as F3. This will be K. Q into Q becomes Q square divided by, what is the distance between the two? Guys, please, if I say this is a square, side is A, complete diagonal is A root 2. Half of the diagonal is A divided by root 2. Half of the diagonal. So what I can say in this particular case, this will be A root 2 whole square. Okay, yes. Then on this charge, this negative charge, center one is negative. Find the value of minus. This has to be negative. Then only the system will be in the equilibrium. So it will apply attractive force. So this will be, let's suppose, F4. And this will be K, Q1, Q2, Q into small q. Capital Q, small q, capital Q, divided by A divided by root 2 whole square. So basically you are trying to say, sir, if you need to find the value of this force, this charge, you take any corner charge and balance the forces on that. What does that mean? Balancing the forces, I'll tell you. First, you draw the forces on this charge. First, you draw the force on this charge. Now see. When you talk about this minus plus Q charge, how many forces are acting, sir? This, and this. Now, guys, listen to me very carefully. Sir, this is KQ square by A square. KQ square by A square. And they are at an angle of 90 degrees. Absolutely, sir. So can I not say, sir, this one and this one, they will have a resultant of. Whenever you have the similar forces, their resultant is always, guys, a root 2 of KQ square divided by A square. Sir, 100% correct. Why? Because this and this are similar. They are at an angle of 90. So their resultant will be root 2 of. Guys. If this is F, this is F. Resultant is root 2F. If this is X, this is X. Resultant is root 2X. If this is KQ square by A square, KQ square by A square, the resultant is under root 2 of KQ square by A square. Now come here. This is the charge Q. What is the force acting from this side? So that is K, capital Q, small q divided by A by root 2 whole square. That will become A square divided by 2. Because square and root will cancel. Take this 2 in the numerator. It will become 2KQ divided by A square. Yes. And what is the force acting on this charge in the downward direction? Ignore this and this now because you have already mentioned their resultant. So that is going to be, I would say, this force plus this force, because they are in the same direction. So this will be root 2 KQ square divided by A square. Plus this KQ square divided by 2A square. Absolutely, sir. 100%, sir. Without a shadow of doubt, sir. So what did I say? Take any corner charge. Draw forces on that corner charge. Okay. 1, 2, 3, 4. Then we say resultant of this and this is root 2 times of KQ square by A square. Now how many forces are acting? 1, 2, and 3. This is 1, 2, and 3. Now balance the two. That's what we call the balance the force. Okay. Now balance this one, because if this is in the equilibrium, this is plus Q. Guys, what does equilibrium mean? Equilibrium means downward force will be equal to upward force. Net force is 0. So upward force is how much? A 2KQQ divided by A square. It will be equals to root 2 KQ square divided by A square. Plus I would say KQ square divided by 2A square. Yes. So what you can take common in this one? I think what you can cancel, first cancel. A square, A square, A square. K. So what else? Q square. So here it remains 2Q is equal to, here it remains a root 2 of Q. Here it remains Q divided by 2. Now you have to find the value of this now. You have to find the value of this Q. Now take it over there. So this is going to be, this is 2Q is equal to a root 2. Do one thing, take this Q common. Okay, so then it is going to be a root 2 plus 1 by 2. Take this Q common, root 2 plus 1 by 2. So then, my dear NEET aspirants, you can further say this Q will come out to be Q divided by 2. Then inside it is a root 2 plus 1 by 2. This is going to be the value of Q. Please tell me in the chats if this is clear. Come on guys, quick. Come on guys, quick. I need the signal in the chats. And do smash the like button, because liking the session is extremely mandatory. Liking the session is extremely mandatory. This is a good level question, okay? It has a very good level actually. So my dear NEET aspirants, whenever they say find the value of charge Q so that the entire system is in the equilibrium, take any corner charge, draw the force on that corner charge, and then balance the force. This force is equal to this force. That's it. This is the simple explanation that you guys are supposed to do. Okay. Even I can give you one homework in this one. But this will be doing from your end. This is Q, this is Q, this is A, this is Q, and here it is minus Q. You have to tell me the value of minus Q. Fine. Q, so that system is in equilibrium. This is simple. This is simple. I have shown you the toughest one. This is simple. This is simple. Okay. So take any corner charge, balance the force. Now guys, let's come on to the equilibrium position. Let's come on to the equilibrium position. This is the equilibrium position. Take a look. See guys. You have a charge Q. You have a charge N times of Q. I am saying you have two charges. Where should I place the third charge? See the question. Where should we place the third charge? So that net force on the third charge is 0. See. If you have already two charges, Q and NQ, I'm saying where should I place the third charge so that the net force on it is 0? Sir, let's place it over here. This is Q naught. A distance is A. Distance is A. Just a is given. A. And this also I'll be telling you. From center to the corner, my dear NEET aspirants, we say this distance is A divided by root 3 in case of an equilateral triangle. Now I am placing the charge over here. Let's check on this charge if the net force is 0 or not. This charge is going to repel it in this direction. Okay, with a force, let's suppose F2. This charge is going to repel it in this direction with a force F1. Do you think that these two forces can cancel out with each other? No. Why? Because they are in the same direction. If they are in the same direction, they cannot cancel out each other. So net force is not equal to 0 here. Let's place the third charge at this point. This charge is going to repel it in this direction with a force F1. This charge is going to repel it in this direction with a force F2. So we say here also the two forces are in the same direction. So net force cannot be equal to 0. Then place the charge at this point, not exactly at the center, towards the near charge. Towards the near charge. At this point, this Q, NQ is going to repel it with F2. This Q is going to repel it with F1. We say the two forces are in the equal opposite direction. We say net force here will be 0. Sir, is it exactly at the center? No, center is here. It is not exactly at the center. It is towards the smaller charge. Towards the smaller charge. And at what distance? X. And if somebody say, what is the value of X? X is R upon under root of N plus 1. X is R upon under root of N plus 1. Let me show you the question on this one. See, you have 25Q, you have 36Q. I say find X. Means where should you place the third charge so that net force on it is 0? Sir, I'll place it over here because you have already shown outside if we place net force cannot be 0. At what distance? At x distance. At x distance from which charge? Smaller charge. From smaller charge. And if you say what is the value of this x? X is r upon under root of n plus 1. As simple as that. Now, sir, how do we find n? N will be, see guys, bigger charge 36q divided by smaller charge 25q. As simple as that. So that will be 36 divided by 25. Directly remember it. Bigger divided by smaller. It is basically how many times this charge is bigger than this charge. So it will be like over here, x will be, what is the value of r? That is 11 upon root of n. That is going to be root of 36 divided by 25 plus I would say 1. So this is going to be x is equal to 11 upon root 36, my dear friends, is 6. Root 25 is, my dear friends, 5 plus I would say 1. So this will come out to be 11 upon 5 into 1 is 5. 5 into 6 is 5 plus 6 is 11 divided by 5. This and this will cancel. So 5 will go in the numerator. It will come out to be 5 meters. So from smaller charge, you have to place it at 5 meters from the smaller charge. Always remember, we measure this from smaller charge. Okay, if somebody says from the bigger charge, we say from the bigger charge. From the bigger charge. Guys, so from the bigger charge, this is going to be the distance. If this is r, entire distance is r, this is x. How much is going to be this? R minus x. So from the bigger charge, it is going to be 11, r is 11, minus x is 5. So it will come out to be 6 meters. So from the bigger charge, if they say, then I would say 6 meters. From the smaller I would say that is 5 meters. Okay. Absolutely, sir. Absolutely, sir. Now see, if the two charges are opposite nature, okay, two charges of opposite nature. If the two charges are of opposite nature, in that, like q minus n times of q, in that particular case, my dear NEET aspirants, you will be placing the third charge from the outer side. If the two charges are of similar nature, similar means this can be minus, this can be minus, this can be plus, this can be plus. In that case, in between the two charges, towards the smaller charge. And we say here, if the two charges are of opposite nature, we say place the charge from the outer side. At what distance? X. X will be r upon under root of n minus 1. So here, what was the value of x? R upon under root of n plus 1. Here it is under root of n minus 1. When the two charges are of opposite nature. Okay. Third thing. Now, my dear NEET aspirants, I want you to understand this very carefully. See. In this particular case, what I am trying to tell you is, see, what should be the value of Q naught? You have two charges, Q, n times of Q. Third charge is Q naught. Till now, I was saying, where should I place the third charge? On the third charge, so that net force is 0. Here, when the two charges are of opposite sign, we say here net forces will be equal to 0 from the outer side at x distance. But when it comes to this particular case, here in this case, what I am saying is that if you have Q, this is plus n times of Q. What should be the value of Q naught? What is the value of this Q naught? Magnitude of Q naught. If all the three charges are in equilibrium. In this particular question, you are supposed to tell me what is the magnitude of Q naught. So if somebody says magnitude of Q naught, you simply say minus n times of Q upon under root of n plus 1 whole square. Minus n times of Q upon under root of n plus 1 whole square. This is the value of Q naught. This is the magnitude of Q naught. If somebody asks you what is the magnitude value of Q naught, then this is the value of Q naught, magnitude of Q naught. See the question, NEET 2013. You have charge Q, you have charge Q, and you are supposed to find the value of this third charge Q, small q. If they ask you to find the magnitude of third charge small q, what will you say? Sir, third charge will be minus n times of q upon under root of n plus 1 whole square. Directly remember this. So q will be minus n. Guys, how do we find n? N means bigger charge by smaller charge. Here both are similar. So q divided by q, it is 1. So n is 1 because q divided by q is 1. Then we say this q upon under root of n, that is root 1 plus 1 whole square. Then minus this is q upon root 1 is 1, 1 plus 1 is 2, 2 square is 4, minus q by 4. So the value of third charge, this is basically minus q divided by 4. Minus q by 4. Come on, give me the signal in the chats. Then we can move on to the equilibrium of suspended charges. Come on, guys. Quick. Let me know in the chats if this is clear. And do smash the like button because liking the session is mandatory. Everybody out there. Is this clear? I need a signal in the chats. Everyone. Whosoever is watching. Oh, signal, oh, tell me in the chat, sir. Or I'll slap you in the camera itself. Okay. Now, guys, equilibrium of suspended charges. Very important. Very important. I would want you guys to give me 100% attention over here. See, equilibrium of suspended charges means you have a ceiling. You are attaching a charge to this. There is a rope, okay? There's a rope. You're attaching a charge to the rope. This is a rope, string. And there is a charge, ball is connected to this, in which charge is Q. There is another rope. And we say there is this charge which is attached to this rope, attached to this string. This ball also has the charge Q. Now tell me, if you have two spheres attached to a string which is connected to the ceiling, what is going to happen? Sir, if this is having charge Q, this is having charge Q, they will repel each other. They will go away from each other. And at certain distance, they will stop. At certain distance, they will stop. Sir, why cannot this charge go further? It is because mg is acting in the downward direction. So mg, gravitational force is pulling it down. That is the reason it cannot go high, further high. Okay. Now, this is what we call the equilibrium position. They will remain at equilibrium in this case, like this. Sir, what if we remove the two charges from this and this? They will come back. Because of the charge only, they are repelling each other. Because of the charge only, they are repelling each other. Now, if you remove the charge from the two, they will come back. They will come back. So, my dear NEET aspirants, it says that if the two charges are in the equilibrium, if the two charges are in the equilibrium, then my dear NEET aspirants, tell me how much is the distance between the two? The two charges will be equilibrium at certain distance. What is the distance between the two? How much is the angle with the vertical? What is the charge? What is the value of charge? Or how much is the tension created in the string? Sir, what is this tension? Tension is the force which is created in a string. If you have a string, we say in that string, force will be tension. Force will be tension. Okay. Whenever you have a questions of this sort, do one thing. Whenever you see the word equilibrium, it means net force is equal to 0. Equilibrium means net force is equal to 0. That means upward force is equal to downward force. Right side force is equal to left side force. Same you'll be doing over here. Now guys, on this mass charge, we say mg is acting in the downward direction. This is applying force on this in this direction, that is electrostatic force, that is k q1 q2 q square divided by x square. K q square by x square. Okay, this one. Then my dear NEET aspirants, see, what you are supposed to take any charge. Draw the forces acting on the charge. This one and this one. And this is tension T. If this is tension T, this is theta. You simply say, guys, this will be also theta. Whenever you have two vectors, please do remember directly. If you have, let's suppose the vector, this is F, it is acting at an angle theta. This vector will have two components. First is F cos theta. So if this is theta from this side, then this will be F cos theta and this will be F sin theta. F cos theta and F sin. Okay. So if this is tension T, this is going to be T cos theta and this is going to be T sin theta. T cos theta and T sin theta. Now, my dear NEET aspirants, what I'm trying to say in this particular case, when you draw all the forces acting on the charge, then balance the forces because it is in the equilibrium. This will be equal to this. So T sine of theta will be equals to k q square divided by x square. Then you set T cos theta. T cos of theta will be equals to, that is m into g. T cos theta will be equals to m into g. Now divide the two equations. I'm dividing the two. So T and T will be cancelled. Sine by cos will be tan theta. So tan of theta will be equals to k q square divided by x square into mg. K q square divided by x square into mg. Absolutely, sir. Absolutely, sir. Tan theta will be k q square by x square into mg. So this is the value of theta. At what angle it will remain in the equilibrium? What is the angle with the vertical? That is this theta. Now we have to find q and x. Listen to me very carefully. I'll be showing you over here. So tan of theta came out to be k q square divided by x square into mg. From this only I'll find q and x. From this equation only. See, in this particular case, if you have to find x, take this x square here, tan theta here. So it will be x square is equal to k q square divided by, I would say, mg tan theta. Because if you are taking this tan here, it will be mg tan theta. So what is the value of x? X will be, my dear friends, under root of, take the root over here, k q square upon, I would say, mg tan theta. This is the value of x. And this was asked in JEE 2021. Let's find the value of q. You are supposed to find the value of this q. Take this x square mg over there. So it will become x square mg tan theta. And from this side it will be kq square. Now take this k in the denominator. So q square will come out to be x square mg tan of theta divided by k. Now take the square over here, it will become root. So q will come out to be under root of x square mg tan of theta divided by k. So this is the value of k in this particular case. And this was also asked in, I would say, JEE 2021. This was asked in one shift, this was asked in another shift. And one more important thing, my dear friends, if q you are supposed to find, then x will be given. If you have to find x, then q will be given in the question. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Come on, guys, tell me in the chats if this is clear. Okay. So this is the value of x and this is the value of q. This is the value of x and this is the value of q. Okay. Yes. Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. Let's find tension. Now, let's find tension. See. Let's find, or let me find tension here only. Let's find tension. See. Let's find tension. Tension is the force which is acting in the string. Consider this charge only. How many forces are acting on this charge? Mg, kq square by x square, and this t. So I'm taking this charge, I'm considering this charge. On this charge in the downward direction, what is the force acting? Mg. And what is the force acting in this direction? That is electrostatic force. And in this direction, it is tension T. Listen, guys. Sir, T cos and T sine, don't mention T cos and T sine because either you mention T or you mention its components. You cannot mention both like all the three forces. No, if you are resolving this in this and this, okay. So I'm not in reality, actually, how many forces are? Tension, this and this. Now, guys, tell me, if you have this force and this force, what is the resultant of these two forces? Guys, see, they are at an angle of 90 degrees. We say resultant of these two forces will be something like this, R. So resultant will be under root of, guys, see, that is, if both are equal, then you can say resultant is root 2. Since they are not equal, how can you find the resultant, sir? That is F1 square, that is Fe square, plus I would say Mg whole square, yes, sir, plus 2 times of F1 square, F2 square, plus 2 times of F1, F2 cos theta, 2 times of Fe, then we say Mg, then we say cos of theta is how much? 90. Now cos 90 is how much? 0. So this term will become 0. So what is going to be the resultant? A resultant is going to be under root of, I would say, Fe square plus I would say Mg whole square. Okay, this is resultant. Now tell me, you have already mentioned the resultant of this force and this force. Okay, that is R. Since this charge is in the equilibrium, so can I not say this force will be equals to this force? So this will be actually tension. This will be actually tension. Sir, why? Because if the object is in the equilibrium, like this object is in the equilibrium, force acting in the downward direction will be equal to force acting in the upward direction. Force acting from this side will be equals to the force acting from this side. That's what I'm saying. Resultant of this one and this one is R. Now this R has to be equal to tension. Why? Because this is in the equilibrium. So tension is under root of Fe square plus Mg whole square. This is what we call tension in this particular case. Now, one more important thing I just want to add over here. Take a look, guys. See, in the previous case, what did I do? I have taken similar charge. Okay. Or let's assume the mass of this is M and mass of this is M. Now, guys, if the mass of two spheres is same, angle created here will be theta. This angle will be also theta. Both the charges are going to create the same angle. Now, my dear NEET aspirants, let's suppose you have got over here two charges, Q1 and Q2. Charge is different. M1 and M2, mass is different. So if mass and charge is different, we say here it will create theta 1, here it will create theta 2. Awesome. Everything crystalline clear. Now, if you find in this particular case value of tan theta 1, tan theta I will be remembering from this one only. Tan theta is this. K Q square. Q square means Q1, Q2 divided by X square. X square is the distance between the two. Then we say M into G. M is the mass of the sphere. If I say mass of this sphere is M1, you'll be writing M1 into G. If I say mass of this sphere is M2, then you'll be writing M2 into G. Now see, if I say in this particular case, consider this as theta 2 and consider this as theta 1. Now, my dear NEET aspirants, don't you think that value of tan theta is this? Tan theta is equal to KQ square X square mg. What is the value of tan theta? K q square divided by x square into mg. Now, if you find the value of tan of theta 1 first, what will you mention? Tan theta 1 is equal to K q1 q2, because right now charge is not same, q1 q2 upon x square. Then we say m1 into g. So this is tan theta 1, m1 into g. Similarly, you can find tan theta 2, K q1 q2 upon x square into m2 into g. Yes, sir. Now divide the two equations. When you divide the two equations, we say q1 q2 k x square g. So what remains? 1 by m1. What remains? 1 by m2. Take this in the numerator, it will become m2 divided by m1. So this is m2 divided by m1. Now what does it mean? What does it mean? It means that in front of tan theta 1, you have m2. So tan theta 1 and m1 has inverse relation. So tan of theta is inversely proportional to mass. What does that mean? That means the one which has got more mass will have less angle. Obviously, if I say I have 10 kg ball, if I say I have 15 kg ball, which has the capability to go more high? So 10 kg will go more high. 10 kg will create more angle. So it is more difficult for 15 kg to go create more angle. So that's why tan theta is inversely proportional to mass. And theta does not depend upon the charge. See, is there charge over here? Charge is cancelled. Theta does not depend upon the charge. Like if you have this question, boys and girls, if you have this question, if Q1 is greater than Q2, M1 is equal to M2. Guys, if mass of first is equal to mass of second, then you say theta 1 is equal to theta 2. Because tan theta does not depend upon the charge. It depends upon the mass only. Okay, what about this one? Sir, M1 is less than M2. You say, sir, tan of theta is inversely proportional to mass. So the one which has less mass will have more angle. So theta 1 will be greater than theta 2. It is simple. We say heavier object will create less angle. Lighter object will create more angle. Give me the signal in the chats if this is crystalline clear. Come on. Everybody out there, give me the signal in the chats if this is crystalline clear. Come on, guys. Quick. Give me the signal in the chats if this is crystalline clear. Is this clear? And do smash the like button, everybody out there. Relative permittivity. See, guys, what does relative permittivity actually say? Listen to me very carefully. Listen to me very carefully. My dear NEET aspirants, let's suppose you have two charges. Let's suppose you have two charges. That is Q1 and this is Q2. Distance between the two is R and they are placed in air. And force in this air, let's consider this as F0. And how do we calculate this force? That is 1 divided by 4 pi epsilon naught Q1 Q2 by R square. As simple as that. Now if I place the same two charges in a medium means let's consider this water. Okay, this is Q1 and this is Q2, same distance R. What is the force in the medium? That will be K. What is the value of K? 1 divided by 4 pi. What should I mention over here? When I say air, vacuum, free space, over there I'll be using the epsilon naught. Epsilon naught gives me the idea how much is the force between the two charges in air, free space, vacuum. And when I say here, I cannot use epsilon naught. I have to use epsilon m. But let me tell you this. I don't know the value of epsilon m. I know the value of epsilon naught, 8.85 into 10 raised to power minus 12. But this I don't know. So if I don't know this, I cannot find the force in this medium. Absolutely, sir. So you can say this will be Q1, Q2 divided by R square. Now, if I say divide the two equations, guys, force in air divided by force in a medium. Divided by force in a medium. So what will you say? Sir, that is 1 divided by 4 pi epsilon naught Q1 Q2 by R square upon that force 1 divided by 4 pi epsilon naught, epsilon of this medium Q1 Q2 by R square. Now Q1 Q2 R square 4 pi. What remains over here? 1 by epsilon naught divided by 1 by epsilon m. Now take this in the numerator, it will become epsilon m divided by epsilon naught. So what I got actually, force in air divided by force in a medium is equal to, I would say, epsilon m divided by epsilon naught. This one I got. Okay. Now, my dear NEET aspirants, see, again I'm telling you, when you have the two charges in air, you can use epsilon naught. Epsilon naught will help you to find the force between the two charges in air. And you know the value of epsilon naught. When you have the two charges in water or any other medium apart from air, free space, you will have to use epsilon m, but you don't know the value of epsilon m. So if you don't know the value of this, you cannot find the force in this. Now, this epsilon m by epsilon naught, we call this as R. This epsilon R is what we call relative permittivity. When you divide permittivity of a medium with permittivity of free space, this is what we call relative permittivity. Now, from this, we got this equation. So can I say, guys, I can write over here, F naught divided by Fm will be equals to epsilon R. Okay, directly this. So take it over there, take it over here. Fm will be equals to F naught divided by epsilon R. Yes. Now, boys and girls, tell me one thing. Can I say this equation tells me force in a medium will be equals to force in a free space divided by epsilon R. 100% clear, sir. So means, let's suppose, example, if I say force between the two charges in air is 100 Newton and the two charges are placed in water and epsilon of water is medium, epsilon R. We say epsilon R for water is 81. Sir, means for different mediums it is given. Yes. So could you please tell me what will be the force between the two charges in water? You say, sir, that will be FO divided by epsilon R. So force in air is given as how much? 100 divided by, in water it will be 100 divided by 81. So it will decrease by 81 times. Like. Let's suppose the example is this. The two charges are placed in air. The two charges are placed in air, Q1, Q2. Force between the two, this is air. Force between the two is 1000 Newton. Okay. Now the same two charges I am placing in a medium. So this medium has relative permittivity of 70. What will be the force between the two charges in this medium? You will be simply saying, sir, just one-liner question. Sir, that is force in the medium will be 1000 divided by 70. Oh my goodness. So this is what we call force in a medium. So can I say this relative permittivity, if you know it, you can find the force in a medium? Yes, sir. So relative permittivity helps you to find the force in a medium. This is the equation. Now consider this portion of the equation. This portion of the equation. Epsilon m by epsilon naught is equal to epsilon R. So epsilon R is epsilon m by epsilon naught. So can I say over here, guys, epsilon m will be equals to epsilon naught into epsilon R? Yes, sir. I can write it this also. See. Let's suppose, example, when it comes to the water, what is the relative permittivity of water? 81. Sir, what is its own permittivity? Permittivity of water, that I don't know. These are three different things. Permittivity of free space, permittivity of medium, and relative permittivity. All three are different. Now, if you have to find permittivity of a medium, that is water here, that will be relative permittivity into relative permittivity into permittivity of free space, this one. Now tell me, for water, what is relative permittivity? 81. And for what is epsilon naught? 8.85 into 10 raised power minus 12. Solve this, you'll get the permittivity of a medium. So two things what I'm trying to say in this particular cases. See. First is, force in a medium will be force in a free space divided by relative permittivity. Second, permittivity of a medium is equal to permittivity of free space into relative permittivity. Sir, permittivity of free space, relative permittivity helps us to find the force in a medium. Sir, relative permittivity helps us to find the force of a particular medium, its own permittivity. Give me the signal in the chat if this is clear. Give me the signal in the chat if this is clear. Come on, quick. I need the signal in the chat if this is crystalline clear. Everyone means everyone, whosoever is watching. Clear? Oh, yes. Now see the question. This was the question asked in NEET 2020. When air is replaced by a dielectric medium of force constant K, sometimes we call relative permittivity also force constant. Okay, relative permittivity, or you call it K, or you call it force constant. Okay. When air is replaced with a dielectric medium of force constant K, listen. It says the two charges were in air. Q1, Q2, distance between the two is R, they are placed in air. Let's suppose force here is F. Now it says that when this air is replaced with a dielectric medium, when this air is replaced with a medium which has force constant, means relative permittivity K. Okay. Now what will be the force between the two charges? Arey, tell me, sir. Force in a medium means force in air divided by epsilon R. So force in air is F, epsilon R is K. So F divided by K. When you divide something with K, it becomes decreased by K times. If I say K times of F means increased by K times. So then the maximum force of attraction between the two charges separated by the same distance is decreased by K times. It says when air is replaced, this is air, it is replaced with a medium. Replace means you have got a box. In this box you have two charges and air is present. Now instead of air you are filling the medium in it. That's what we call air is replaced with a medium, and which has dielectric constant K or relative permittivity K. So we say the new force in this will be F naught divided by F divided by K. So decreased by K times. I hope this is crystalline clear. I hope this is crystalline clear. Now, boys and girls, listen to me very carefully. Let's suppose you have a magnet over here. Okay. And you place a coin at this point. What is going to happen? It will attract it. You place a coin here, it will attract it. You place a coin here, it will attract it. You place a coin here, it will attract it. You place a coin here, it will attract it. You place a coin here, it will attract it. So means this magnet is applying the force on the coin. That is what we call magnetic force. So if you are placing a coin near to the magnet around it, it is applying force. So can I not say this magnet is basically creating some sort of field around it? This magnet is basically creating some sort of field around it. And if in that field, a piece of iron or a coin is placed, it experiences force. And this field is called magnetic field. Now place a charge. Sir, if we place a charge over here, there is a charge, there is a charge. And there is one more charge Q naught. Okay, we are placing one more charge Q naught. This is the test charge. Sir, this charge will repel this test charge in this direction at this point. It will apply force. This charge is going to repel this test charge in this direction. This charge is going to repel this charge in this direction. This charge is going to repel this charge in this direction. This charge is going to repel this charge in this direction. This charge is going to repel this charge in this direction if you place it around it. So can I not say, if I am placing another charge near to this Q, we say this is applying force on this. So can I not say this charge is also creating some sort of field around it? And if in that field some other charge comes, it experiences force. So this field is what we call electric field. Sir, does that mean if you have a charge, it will create a field around it? Any charge will create field around it? Yes. And if in that charge some other charge comes, it experiences force. And this field is what we call electric field. This field is what we call electric field. Now see what is mentioned over here. Electric field. It is a space. See guys, it is a space around a charge. This is a charge. It is a space around a charge in which if any test charge comes, it experiences force. It experiences force. Okay. So from now onwards, if there is a charge, it will create field, electric field. Now see, this is the positive charge. Listen carefully. I'll make you this understand this point. If there is a positive charge, if you place a test charge here, test charge is always positive. This is using for testing purposes to find the electric field. Okay, test charge is used to detect the direction of electric field, to find the magnitude of electric field. So we said this test charge will be repelled. Here, it will be repelled. So if test charge is repelled, then by using this logic, we say the direction of electric field due to this positive charge is away from the charge. This is the direction of electric field due to this positive charge. Why, sir? Because test charge was repelled. Now see, you have got over here negative charge. You place test charge here. Test charge is always negative. So my dear NEET aspirants, in this particular case, what we say is that this negative charge is going to attract it towards itself. If you place here, it will be attracted. So what I can say from this logic, the direction of electric field due to negative charge is always away from the charge. It is always away from, towards the charge, because it is attracted. It is attracted. It is towards the charge. It is towards the charge. Towards the charge. Okay. The direction of electric field due to negative charge is towards the charge. The direction of electric field due to positive charge is away from the charge. Okay. Electric field of positive charge is away from the charge and negative charge will be towards the charge. For negative charge, it will be towards the charge. Okay. One more important thing. See guys. If I say you have a charge over here. This charge creates the electric field. Test charge is always positive. See, this charge creates the electric field around it. This charge creates the electric field around it. We consider the electric field of test charge as 0. We neglect the electric field of test charge. If this is a charge, it creates electric field around it. Okay. Now, if I say from this charge, I go at r distance. Sir, how much field is here? What is the intensity of field at this point? What is the intensity of field at this point? So electric field at this point will be how much? Listen carefully. How do we find the electric field? So at this point, electric field will be simply E is equal to, what is the intensity, strength of electric field due to this point charge? That is K. Charge is how much? Q divided by, I would say, R square. KQ by R square. And what is the relation between E and R? That is inverse relation. So I can say electric field is inversely proportional to R square. Now see, bigger is the magnitude of the charge, bigger will be the field. Electric field is directly proportional to the charge. And if R is large, if this R is large, we say field will be less. Now, if we draw the graph between electric field versus R, I would say it is a rectangular hyperbola. Graph between electric field versus R, it is a rectangular hyperbola. It is rectangular hyperbola. Okay. Now, some graph tricks I want to show you in this particular case. Some graph tricks I want to show you in this particular case. See guys, plot the graph for two positive charges. If I say plot the graph of a positive charge. This is a graph of positive charge. One charge. It is rectangular hyperbola. For one charge, we draw it like this. For two charges, let me show you, my dear friends, in this particular case. Listen to me very carefully. I'll be showing you the sign conventions first. Sign conventions. Sign conventions. Let's suppose this is a charge. This is a positive charge. We said due to a positive charge, electric field is away from the charge. Something like this. Due to a positive charge, electric field is away from the charge. So this direction of electric field is towards the right. Consider this positive. This direction of electric field is towards left. Consider this negative. Similarly, in case of negative charge, electric field will be towards the charge. So this electric field is towards the right. It is positive. This electric field is towards left. It is negative. That's it. These are the sign conventions you are supposed to remember in this particular case. Come here. Now you have to draw the graph between electric field versus R for two positive charges. On y-axis, I'll be placing electric field, and on x-axis, I'll be placing R. Okay. So this is minus electric field from the lower side. This will be minus electric field from the lower side. From the upper side, it is positive electric field. Now, boys and girls, what I'm trying to say in this particular case is, if you have to draw the graph between electric field versus R for two positive charges, place two positive charges at certain distance. Draw y-axis, draw x-axis. Here also, y-axis, x-axis. On y-axis, place electric field, from the lower side, minus electric field. And on x-axis, place R. On this, place electric field, minus electric field. Now draw the sign convention. Now draw the sign conventions. See guys, due to this positive charge, I would say, listen carefully, I would say electric field is away from the charge. Something like this. So instead of showing it here, I'll show you here. I'll show you here. So this electric field is positive. This electric field is negative because it is towards left. And this positive, due to this positive charge also, electric field is away. This is electric field due to positive. Sorry, this is electric field negative. This electric field is positive. This electric field is positive. Now, my dear NEET aspirants, what I'm trying to say in this case is, let's talk about this charge first. On the left side of this charge, this is the left side, this is the right side. Electric field is negative. So if electric field is negative, from the upper side we make positive electric field, from the lower side we make negative electric field. So come on to the left side of this. Electric field is negative means we have to make the graph from the lower side. Will be this only. It will be this only. It will be this only. Then come on to the right of this. Come on to the right of this. Electric field is positive. Shall I make the graph from upper side or lower side? Upper side. Because electric field is positive. Graph is positive. Then come on to this charge. Then come on to this charge. Electric field on the right of this. Come on to the right side of this charge. Electric field is positive. So electric field would be like this. Come on to the left of this. Come on to the left of this. Electric field is negative. So the graph would be something like this. Graph would be something like this. And here also you need to basically match this at a point. At this point, we say net electric field is 0. So this is what we call neutral point. Neutral. So this is the graph actually. Let me show you one more. Let me show you one more. The question is, let's suppose you have minus q, you have minus q, you have minus q and minus q. Okay, let me show you between plus q and minus q. Plus q and minus q, because minus q and minus q is simple. Plus q and minus q. Okay. Now, first of all, they are placed at certain distance. Draw y-axis, draw x-axis. Draw x-axis. This is y-axis. This is negative y-axis. So this is electric field. This is negative electric field. This is R. This is electric field. This is negative electric field. This is R. Now, my dear NEET aspirants, first and the foremost thing, you guys are supposed to draw the sign convention. Sign conventions will be, in case of this, electric field will be away from the charge. This is away. So this electric field will be considered as positive. This electric field will be considered as negative. This is negative. In this case, electric field is considered as something like this. This electric field is negative. This electric field is positive. Now, boys and girls, what you are supposed to do here is, on the right side of this electric field is negative. So graph is from upper side or lower side? Lower side, because electric field is negative from this side. This one. Now come on to this side. This was the right. On the right side of this electric field is negative, so lower. Now come on to this side, left side. Electric field is positive, so graph will be from upper side. Now come on to this charge. On the right of this electric field is positive, so graph is from upper side. Graph is from upper side. Sir, shall you not touch it over here? No, because here no neutral point is created. Neutral point is not created. Come on to the left side of this. Electric field is negative, so negative electric field will be here. Negative electric field will be here. So this is the graph. I believe this is crystalline clear. Guys, give me the signal in the chats if this is crystalline clear. Come on, come on. Quick, 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 quick. Let me know in the chats. Let me know in the chats if this is clear. Give me the signal in the chats if everything is crystalline clear. And do smash the like button. Everybody do smash the like button. Okay. Let's move on to this question. See, this is an important question also. You are supposed to tell me in this particular case, what is the net electric field due to all these charges at origin? What is the net electric field due to all these charges at origin? You are supposed to tell me that. See, guys, when it comes to the net electric field at origin, this charge from the origin is at what distance? 1 meter. This negative is at 2 meters. This positive is at 4 meters. And what is the electric field due to a point charge at r distance? Electric field due to a point charge at r distance is kq by r square. So it is kq by r square. So in this particular case also I can say electric field due to this charge will be simply, that is kq divided by, at what distance it is? 1 square, that is 1. Then minus electric field due to this kq divided by, at what distance it is? 2 square. 2 square is 4. Sir, why are you mentioning minus? Because negative charge over, it is negative charge over here. And when you write the electric field here, this is a vector sum. Okay. 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 Then, my dear NEET aspirants, plus, what is the electric field due to this? kq divided by 4 square is 16, plus, what is the electric field due to that? Minus KQ divided by 8 square, that is 64, and plus so. Okay. KQ by R square, KQ by R square, KQ by R square, and so on. Now in this particular case, my dear NEET aspirants, when I say net electric field, can I take this KQ common? Yes. So I can write over here 1. Then minus 1 divided by 4. Then plus 1 divided by 16. Then minus 1 divided by 64. Then plus so on. This is what we call GP series. This is what we call GP series. And how do we find the sum? I have told you in the last marathon also, the sum of the GP series. How do you add these numbers? These are till infinity, okay? It is not 4 or 5 numbers. These are till infinity. So we have a formula to add the GP series. Sum is equal to A upon 1 minus R. I have told you previously, this A means first term. What is the first term here? That is 1. R means common ratio or common term. How do you find R? Take any term like 1 by 16. Divide it with the term which comes before it. That is minus 1 by 4. Take any term. Divide it with the previous term. 1 by 16 divided by minus 1 by 4. 4 ones are, 4 fours are. So this will be minus 1 by 4. Now if you find sum will be A. A is 1 upon 1 minus R. 1 minus R. R is minus 1 by 4. Minus 1 by 4. Now sum in this case will be 1 upon 1 minus into minus is plus 1 by 4. So sum will be 1 upon 4 into 1 is 4. 4 plus 1 is 5. 5 by 4. So if you take in the numerator, it will become 4 by 5. So sum of all of this came out to be how much? 4 by 5. So I can say when it comes to the net electric field is KQ. And instead of all of this, what you can write, that is 4 by 5. So you'll be writing over here, instead of K, it is 1 by 4 pi epsilon naught. Okay. Then my dear NEET aspirants, it is 4 divided by 5. 4 and 4 will be cancelled. So it is Q divided by, I would say 5 pi epsilon naught. Q divided by 5 pi epsilon. This is the net electric field. This is the net electric field. I hope this is crystal and clear to each and every single student. Let's move on to the electric field due to a ring. Let's move on to electric field due to a ring. See guys, ring means ring. A ring means ring. This is not a ring, by the way, okay? A ring means this is the ring. This is the ring. If I say, imagine this is the ring. Charge is placed on the ring. I am distributing the charge on this ring. I am saying, will this ring also create the electric field? Absolutely, sir. A ring is also creating the electric field because charge is placed on it. Now, from the center to x distance, move from the center to x distance. Move from the center to x distance. This is the ring. How much is the radius of the ring? R. Charge is how much? Q. So from center to x distance, this x distance, how much is the field here? Directly you guys will be remembering, from center to x distance, field is KQX. Q is the charge placed on this. X is the distance at which you have to find the electric field from the center. Then we say R square plus x square. This is the radius. X is the distance where you have to find the field, whole raised power 3 by 2. Now let's suppose if you move towards the center, we say x will decrease. If you move away from the center, x will increase. Exactly if I say what is the value of x at the center? Value of x at the center is 0. So at center, if x is 0, put 0 over here. Entire term will be 0. Electric field at center will be 0. Electric field at center will be 0. Then if I say very close to the ring, very close to the ring, very close to the ring, like this is the ring at this point here. This is x and this is r. Very close to the ring means just outside the ring, just outside the ring. Just outside the ring means X is much less than R. X is much less than R. If X is much less than R, then in that particular case, electric field is going to be KQX divided by, guys, if X is very small as compared to R, it means you are adding a very small quantity to a very large quantity. It will not create any difference. Why? Because adding a bucket of water to the ocean, will it create any difference? No. Ocean has got billions of liters of water. Adding 1 liter, it will not create any difference. So neglect this X. So you can write R square whole raised power 3 by 2. 2 and 2 will cancel. So it will come out to be KQ divided by R cube. KQX divided by R cube. And clearly you can say electric field is directly proportional to X when you are very close to the ring. Next, very far from the ring. Very far from the ring. Very far from the ring. Like this is the ring. Its radius is R. You are at a very large distance. In this case, R is much less than X. Very far from the ring. Now, what is going to be the electric field? That is KQX upon. Sir, why did not you neglect X in the numerator? Because it is in multiplication. We neglect X only when it is added or subtracted. So sure, I'll be neglecting R because R is small as compared to X. Okay, so it is going to be X square whole raised power 3 by 2. 2 and 2 will cancel. So electric field will come out to be KQ upon KQX upon X cube. Now X and this square will cancel. So it is X square. So electric field will be KQ divided by X square. KQ divided by X square. Okay. Now, my dear NEET aspirants, what is the relation between electric field and X square? Inverse. This is inverse relation when you are very far from the ring. So, if you have to make the graph between electric field versus X, see guys, let me show you the graph here. This is not correct. Let me make the correct graph. So, this is electric field, this is X. So I would say very close. This is the value of X0. So means this is the center. What is the value of electric field at the center? Value of electric field at the center, X is equal to 0, electric field is 0. So I would say graph will start from the origin. So it will go like this. Okay. Okay. It will go like this. It will go like this. And then this is very close. Electric field is directly proportional to X. Electric field is directly proportional to X when you are very close to the ring. So means these are the closer points to the ring because this is the center of the ring when you are close to the center. When you move away from the center, then it is a rectangular hyperbola. E is inversely proportional to X square. So join this with a smooth curve. Okay. So very close to the ring, electric field is directly proportional to X. Very far from the ring, electric field is inversely proportional to X square. Now see, if this is a ring, it will create the electric field from right side also, on the left side also. So from the left side also, graph is going to be the same. And this is the point where electric field to the ring will be maximum. And if somebody says how much is the, at what distance electric field is maximum, X is equal to R divided by root 2. When the value of X is R by root 2, electric field will be maximum. In this particular case, I would say electric field is maximum from the left side. Electric field is maximum from the left side. And value of X here is R divided by root 2. Okay, it is minus R by root 2, by the way. It is minus R by root 2. It is minus R by root 2. Come on, guys. Give me the signal in the chats if this is clear. Give me the signal in the chats if this is clear. So very close to the ring, electric field is directly proportional to X. Very far from the ring, electric field is inversely proportional to the X. X square. So this is going to be the graph in this particular case. Now, boys and girls, Now, boys and girls, let's move on to this one first. Listen carefully. This one is very important. I would want you guys to give me 100% of your attention. Everyone means everyone. Listen carefully, my dear NEET aspirants. See. If I say electric field due to a segment of ring, first and the foremost thing, sir, what does segment of ring actually mean? This is a ring. This is a complete ring. If I say you break this ring into two parts, this is called a semicircular ring. This is called a semicircular ring. So one complete ring has got two semicircular rings. One complete ring has got how many rings? Two semicircular rings. If I break it something like this, this is what we call chord. One complete ring has got how many chords? 4. Now, if I say in this particular case, sir, why the graph is from the negative side? Because I told you electric field from this side is positive. If this is a ring, electric field from this side is positive. Electric field from this side is negative. That's why graph is from the negative side. This is minus E. Sign conventions, na? Now, my dear NEET aspirants, in this particular case, if I say cut this ring from here to here, this is what we call some portion of the ring. Now, my dear NEET aspirants, you call this as some portion of the ring. This will be radius R. This will be radius R. Some portion of the ring actually means segment of ring, or we also call it the arc. Now you take this segment of ring, place it over here. Okay. Yes. Now if I say due to this segment of ring, what is going to be the electric field at this point at its center? From center to this end, this is the radius R. From center to this end, this is the radius R. Like here, R. And angle between this and this is theta. If you ask me what is the electric field at this point, I'll be directly writing electric field will be 2k lambda. K is Coulomb's constant. Lambda I'll be telling you divided by R. R is radius. Then I say sine of theta by 2. This is the electric field due to this ring at center. 2k lambda by R sine of theta by 2. Now if you ask me, sir, what is lambda? Wait. See. Let me first show you this. What is lambda? My dear NEET aspirants, let's suppose you have a rod over here. Okay. And on this rod, charge is present. This is a rod, charge is present. Okay. Charge is present. Sir, how much charge is present? Q. How much is the total length? L. Guys, if I say you have got 10 apples, you have got 10 person. How many apples you are supposed to distribute these apples in 10 person? One person will get how many apples? 1. Sir, how? 10 apple divided by 10. You say total by total. 10 apple you are supposed to distribute in 10 number of people. So how you can? 10 by 10, total by total. So that will be 1. Now this rod has total charge Q, total length L. If I say what is the charge on unit length, you say total charge divided by total length. This is what we call lambda. Total charge divided by total length. This is what we call lambda. Okay. So lambda is simply total charge by total length. This tells you charge present on the unit length. Like if you have 10 meter rod and you have 10 Coulomb charge. What is the charge on unit Coulomb? What is the charge on unit length? 1 meter. You say 10 by 10. On 1 meter, you have 1 Coulomb charge. That is lambda. So lambda helps you to find the charge on unit length. Now see, if the charge is present on the sheet, surface, charge is Q, area is A. If I say what is the charge present on unit area, on this unit area, you say, sir, that is total charge divided by total area. That is sigma. Sigma helps you to find the charge on unit area. This is charge per unit area. This is charge per unit length. If I say charge is present in the volume, like a sphere, charge is present in this sphere. In this sphere, charge is present. Okay. How much charge is present in the sphere? That is Q. And how much is the volume? V. If I say what is the charge present in the unit volume? That is total charge divided by total volume. That is what we call rho. Rho helps you to find the charge present in the unit volume. Okay. This is the charge present in the unit volume, my dear NEET aspirant. Now, similarly, if this is a rod or this is a ring, this is a charge is distributed on the rod. This is the rod only, na? If you make it straight, it will become rod. So that's why if you have to find the charge, how much charge density is here. Sir, more charge is present, density will be more. Lambda is charge density. Lambda is charge density, charge per unit length. How much is the charge present on the unit length? That is going to tell you lambda. That's why this one. Then, if I move on to this one, let's suppose you have a semicircular ring. Right? See. This is the radius R. This is the radius R in case of a semicircular ring. This is another radius R in case of a semicircular ring. So from here to here, this angle is 180. Because, guys, how do we define the angle? Angle is between the two radius. This radius and this radius. What is the angle between this radius and this radius? That is theta. So here if you draw the radius, so it is R, that is theta. Theta is 180. And if you have to find the electric field at this point, so theta in this case is 180. 180 means pi radians. Okay, in degrees it is theta. 180 it is pi. And then when we talk about this one, electric field here, we use the general formula only. This is the general formula. So we use the general formula only. So electric field will be simply 2k lambda divided by R sine of 180 by 2. Sine 180 by 2 is sine 90. So electric field will come out to be 2k lambda divided by R sine of 90. Sine 90 is 1. So electric field will come out to be 2k lambda divided by R. So due to this, electric field will be 2k lambda divided by R. And it will be away from the charge, Because it is positive, so electric field is away from the charge. Let's talk about chord. See guys, this is the chord. Now in this particular case, my dear NEET aspirants, this is the radius R. Join one end of the chord, join another end of the chord. This is radius R. What is the angle between the two? 90. You have to tell me electric field at this point. You have to tell me electric field at this point. You'll be again using the same formula. Electric field is 2k lambda divided by R. Then you say sine of theta by 2, 90 by 2. That is 45. I'll be directly writing over here sine 45. So, when it comes to the electric field, you'll be saying, sir, electric field will be 2k lambda divided by R. Sine 45 is 1 divided by root 2. Okay, sine 45 is 1 by root 2. So, you'll be like electric field will be, that is 2k lambda divided by R. And then we say root 2. This is 1 divided by root 2. Okay, do one thing, rationalize it, multiply with root 2 and divide with root 2. So, root 2 into root 2 is how much? That will become root 2 whole square. Square and root will cancel, it will come out to be 2. So root 2 into root 2 is 2. So this 2 will be cancelled with this 2. So electric field will be, take this root 2 in the numerator, root 2 k lambda divided by R. Root 2 k lambda divided by R. Root 2 k lambda by R. So due to a semicircle, it is 2k lambda by R. Due to this chord, it is root 2k lambda by R. Let's suppose if the angle is given as 120, something like this, you have to tell me what is the net electric field at this point. Okay. So we'll be simply saying electric field will be 2k lambda divided by r sine of 120 by 2. Because this is the radius 1. One end of this charges from here to here only. Charges from this point to this point only. So this is the radius r, this is the radius r. Angle between this r and r is theta. So that is 60. So electric field in this case will come out to be 2k lambda divided by r. Sine of 60. Sine 60 is 1 by 2. Sine 60 is root 3 by 2. 2 and 2 will cancel. So electric field will come out to be a root 3k lambda divided by r. I hope this is also clear. Okay. Find the net electric field at the center. Guys. You are supposed to tell me net electric field at the center. What I would suggest you in this particular case is, see, clearly in this case, charge is present on this cord. This you can consider another cord. And these are the two cords. So better is to break this in 4 cords. Better is to break this into 4 cords. Guys, see. This will be first chord, 4 chords. Why? Because charge is distributed in chords over here. That's why I'm breaking it into the chords. Due to this chord, electric field is away from the chord. And how much? A root 2k lambda by r. Because what is the electric field due to a chord? A root 2k lambda by r. It is mentioned, a root 2k lambda by r. Okay. And due to this chord, my dear NEET aspirants, electric field will be towards, because this charge is negative. And how much? A root 2k lambda by r. Right? Due to the chord, it will be root 2k lambda by r only. Now, due to this negative charge chord, electric field will be towards how much? A root 2k lambda divided by r. Due to this negative chord, electric field will be how much? A root 2k lambda divided by r. This and this will be cancelled. So what is the net electric field, guys? This and this are in the same direction. I can say net electric field will be root 2k lambda by r plus root 2k lambda by r. Plus I would say root 2k lambda by r. So that will be 2 times of k lambda divided by r. That will be 2 root 2 k lambda divided by r. Because 1 plus 1 is 2. 2 times na. Okay, what about this one, guys? See. In this particular case, charge is present here. This is the charge on upper chord. This is the charge on lower chord. This is the charge on lower chord. This is the charge on lower chord. In this case, we'll break this into 2 semicircles. Guys, we'll break this into 2 semicircles. Upper semicircle, lower semicircle. Let's talk about the electric field due to upper semicircle. That will be 2k lambda by r. What about the lower semicircle? Electric field due to lower semicircle will be also 2k lambda by r. 2k lambda by r plus 2k lambda by r. When I say net electric field in this case, 2 plus 2 is 4k lambda by r. 4k lambda by r, because they are in the same direction. Due to this, it is negatively charged semicircle. That's why I'm showing the direction towards the charge. Net electric field in this case, guys, in this particular case, we'll be breaking this, resolving this into into two chords. Okay, into 2 chords. So, guys, see, this is an interesting question over here. Due to this positively charged chord, electric field at this point will be something like this, away from the charge. How much? A root 2k lambda by r. Because due to a chord, electric field is root 2k lambda by r. Okay. Due to this negatively charged chord, my dear NEET aspirants, electric field is towards, that is how much? A root 2k lambda by r. And my dear NEET aspirants, this angle is 45, this angle is 45. So total angle in this case is 90. Please remember this. In case of a circle, this is 90, this is 90, this is 90, this is 90. So if you draw a line between the two, this will be 45, this will be 45. So total is 90. Now tell me, if you have two vectors, a root 2k lambda by r or root 2k lambda by r, similar vectors at an angle of 90. Okay, then what is going to be the resultant in that particular case? This will be E net. Guys, if this is 2k lambda by r, sorry, if this is x, resultant is root 2x. If this is f, resultant is root 2f. If this is y, resultant is root 2y. If this is root 2k lambda by r, this is root 2k lambda by r. So resultant is going to be a root 2 times of whatever this is, a root 2k lambda by r. At an angle of 90, we write root 2 times, na? Root 2 times this factor. So root 2 into root 2 is 2k lambda divided by r. Because root 2 into root 2 is 2k lambda by r. Okay. Now we have, guys, tell me in the chats if this is clear till over here. Come on, quick. Give me the signal in the chats if this is clear till over here. And do smash the like button, everybody. We'll take the break exactly at 12:55. 12:55 we'll be taking the break. Now, guys, tell me. You have an infinitely long rod over here. You have an infinitely long rod. Infinitely long rod means it is going till infinity. It is going till infinity. You can assume it simply like that. This is an infinitely long rod. And you have to tell me electric field due to this infinitely long rod at what distance? At r distance. Okay. So at r distance, electric field is going to be 2k lambda by r. R is the distance where you are finding, and k lambda is the charge density. Directly you'll be remembering this. Okay. If you have a semi-infinite wire, my dear friends, mean in which one end is finite, it is here. Another end is going till infinity. And infinite wire means in which both ends are going till infinity. Here only one end is going till infinity. So here electric field will be 2k lambda by r, let's suppose at this particular point. Okay. Okay, you can make it like this also. So at this point P, electric field is going to be a root 2k lambda divided by r. This is an electric field due to the infinitely wire. Okay, yes. Now, listen to me very carefully. What are the types of questions that can be asked in this one? Find the position where net electric field is 0. This is a rod on which charge density is n lambda. This is another rod on which charge density is lambda. And these are infinitely long wires. Sir, charge is n times of this. Yes. Okay. Let's check at this point whether the electric field at this point will be 0 or non-zero. See, electric field due to this positively charged rod at this point is away. Electric field due to this positively charged rod at this point is away. So both the electric fields are in the same direction. Net electric field cannot be equal to 0. Let's check at this point away from outside of the two rods. Due to this rod, electric field will be away. Due to this rod, electric field will be away. So net electric field is not equal to 0 at this point also. Let's check at this point. Electric field due to this rod is something like this away from the rod E1. Electric field due to this rod is something like this away from the rod E2. And E1 and E2 will be equal. So here at this point, net electric field will be 0. At what distance? At x distance. So I can write over here. So at x distance, net electric field is equal to 0 in between the two rods. Okay. Net electric field is equal to 0. Now, if this is the rod on which charge is negative, minus n times of lambda. Here it is lambda. When the two charges are of the similar nature, when the two rods have got the similar charge, okay, similar nature charge, positive, positive. In this particular case, charge is negative, positive. Here I would say net electric field is 0 at this particular point from the outer side. At what distance? X. Okay, one more important thing, guys. If somebody says what is the value of this X? Value of this X will be simply X is equal to R upon N plus 1. Don't put root over here. Root is over there. Okay, R upon N plus 1. And this is from this rod, okay, which is having the charge density lambda. From the smaller density from the smaller density rod. Okay. And in this particular case, you would say, sir, net electric field is 0 from the outer side. Sir, why not inner side? Okay, check. At this point, field due to this will be away. Due to this, it will be towards. So both the fields are in the same direction. So net cannot be equal to 0. So that's why I'm saying from the outer side. At what distance? X. From the, and this X will be R upon N minus 1. Please keep this thing in your mind. When the two rods have opposite nature charge, then it will be R upon N minus 1. And this is from smaller density rod. From smaller density rod. From bigger density rod, it will be how much? R plus X. Okay, let me mention this also. From bigger density rod, it is going to be R plus X. It is going to be R plus X. Guys, see, let's suppose you have 5 lambda, you have lambda. First and the foremost thing, tell me what is the value of N. N will be this 5 lambda bigger density minus smaller divided by smaller density. So it will come out to be 5. Now at what distance, my dear NEET aspirants, net electric field is 0? That is at X. So this X, at X, I would say net electric field is 0. Due to this positively charged rod, electric field is away. Due to that negatively charged rod, electric field is towards. So E1 is equal to E2, net is 0. And if somebody says what is the value of this X? So value of this X will be R upon N minus 1. So X will be, what is the value of R? That is 10 upon this 10. Then N will be 5 minus 1. So this is going to be 10, 5 minus 1 is 4, 10 divided by 4. That will be 2.5. Okay. Now, my dear friends, this is from the smaller density rod. If I say from the bigger density rod, it is at what distance? From the bigger density rod, I would say it is going to be R plus X. And what is the value of R, my dear NEET aspirants? That is 2.5. Okay. Then we say plus. What is the value of X? R is 10. X is 2.5. So that is going to be 12.5. Okay. This one. See guys, in this particular case, find the electric field at the midway of the two infinity. This is a question from NEET 2019. See guys, you have an infinitely long rod with charge density minus lambda. You have an infinitely long rod with the charge density lambda. So this the distance between the two is 2r. You have to find electric field at this point. Array sir, it is very simple. Guys, due to this positively charged rod, electric field at this point will be 2k lambda divided by r. Due to this negatively charged rod, electric field will be 2k lambda divided by r. And in this case, electric field is away. In this case, electric field is towards, because this is negative. And if both the electric fields are in the same direction, what is going to be the net electric field? 2k lambda divided by r. Then you say plus 2k lambda divided by r. So it will be 4k lambda divided by r. Okay. Now guys, see this one. There is a rod. This rod is having charge density, let's suppose lambda. This rod is having charge density, let's suppose lambda. Now, my dear NEET aspirants, what I'm trying to say in this particular case, at r distance, there is a charge minus q. There is a charge minus q. Its mass is m. If you give some velocity to this charge, it will start rotating, revolving around this in a circle. Okay. It says that what velocity must give to it, what velocity we must give to it, so that it moves in a complete circular path. If I give velocity v to a charged particle at r distance from the line, it will follow the circular path. Okay. Okay. So what is the value of velocity v? What should be the velocity given to the charge so it follows the circular path? See guys. First and the foremost thing, since this is a rod having positive charge, this is having negative charge, minus q. So this rod is going to attract this towards itself with an electrostatic force. Okay. And this electrostatic force, you write over here, it will be q times of E. It will be q times of E. Sir, why it is q times of E? Listen to me very carefully, my dear NEET aspirants. Please, 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 please. Listen to me very carefully. I am saying that if this is a positive charge over here, q1, if this is another charge over here, q2, then you can say k q1 q2 by r square. But you write this particular expression from now onwards. You remember this expression means electric field is force upon charge. You remember this expression. Okay. So from now onwards, you'll be directly, after some time, I'll be explaining this. As of now, you remember, force on the charge will be q times of E. I am not using q1, q2 by r square here because one charge is rod, another is a point charge. That formula, k q1, q2 by r square, is only valid when both the charges are point charges, q1, q2. So here, both the charges are not point charges. So my dear NEET aspirants, we say, in this particular case, we say set electrostatic force will act. Yes, sir. What did I tell you? Whenever the particle moves in a circle, centripetal force will also act. And here also that centripetal force will be equals to electrostatic force. And centripetal force has got two formulas, mv square by r and mr omega square. mr omega square. These are the two expressions of centripetal force. Now see, what is the electrostatic force acting on this charged particle? That is q times of E. What is the centripetal force? mv square by r. Directly, whenever charge moves in a circle, make centripetal force equal to the electrostatic force. In gravitation, make gravitational force equal to the centripetal force. Now, this force is due to the two charges and this force is due to the circular motion. Now guys, we have to find the value of V. Take it over here. So V square will come out to be Q R E divided by, I can say, M. Now tell me, my dear NEET aspirants, E is basically the electric field due to the rod. Or if F is equal to Q times of E, force on this charged particle is Q. Q is the charge and E is the electric field. What is the electric field due to the rod at r distance? This is infinitely long rod, 2k lambda by r. So since I would say electric field is 2k lambda by r, so what is going to be V square? It is Q R. Instead of electric field, it is 2k lambda divided by r. Then we say M. R and R will cancel. So take the square over here. V will be under root of 2kq lambda divided by M. Is that clear? Is that clear? Guys, give me the signal in the chats. Is this clear? Come on, quick. Tell me in the chats if this is crystalline clear. Guys, give me the signal in the chats. Quick. We'll be taking the break at 12:55. Now see, electric flux. What does electric flux actually mean? What does electric flux actually mean? Electric flux simply means the number of field lines crossing the surface perpendicularly. Let's suppose this is a surface over here. I am placing a charge. Due to this charge, field is coming out. Due to this charge, field is coming out. And that field is crossing the surface. This sheet, you are placing the sheet. Now, in this particular case, how many number of field lines are crossing? Like, in the sheet, we say how many field lines are crossing? 1, 2, and 3. So, flux is 3. So, flux is defined as number of field lines crossing the surface perpendicularly. Okay. Now see, tell me one thing. This flux is directly proportional to electric field. More is the electric field. If I say you place a big charge over here, so field will be large. So if field is large, flux will be large because more field lines will cross. And flux is directly proportional to area. Guys, if you place a bigger area, then more number of field lines are going to cross. Okay. So we say in this particular case, flux is proportional to electric field, flux is proportional to area. So we say this flux is actually, that is electric field into area, and then we say cos theta. Or we say this flux is equal to electric field dot area. E dot A, dot product of electric field and area. So what is electric field? Number of electric field lines crossing the surface perpendicularly. So that is E dot S. S is the area, or E dot A. You mention E dot A. Okay. You write E dot A. So you say, sir, flux is simply, that is EA cos theta. Or you say, sir, flux is simply, that is E dot A vector. Dot product of electric field and area vector is what we call flux. Okay. Now guys, we understood this. Electric field is large, so more field lines will cross. Area is large, we say more field lines will cross. So we say flux is more. Cos theta we couldn't understand, sir. See guys, I'll tell you something very beautiful, very beautiful. See, let's suppose you have a surface over here. Listen carefully. Let's suppose you have a surface over here. And in this particular case, this surface has got this area. Area is a vector quantity. The direction of area is always perpendicular to the surface. The direction of area is always perpendicular to the surface. Okay. Okay. Now guys, let's suppose electric field is crossing something like this. It is not crossing perpendicularly. It is like this. Electric field is crossing at an angle. Okay. Now this at an angle theta. Now this electric field will have two components. This is E cos theta. This is E sin theta. Now tell me, in this particular case, which of the two components is crossing the surface? Sir, E sin theta is just touching the surface. E sin theta is just touching the surface. Okay. And E cos theta is crossing. So here, which is going to create flux? E cos theta. That's why we say here flux is going to be E cos theta into area. So flux in this case will be, that is EA cos theta. So basically we take that component of electric field which crosses the area, which creates the flux, Like let's suppose if I give you the question something like this. See guys. The question is, this is a sheet. Its area will be always perpendicular. This is a sheet. Its area will be like this. Okay. In this particular case, my dear NEET aspirants, let's suppose this is the direction of electric field. This is the electric field, something like this crossing. And this electric field is creating at an angle theta with the horizontal. Now this electric field will have two components, E cos theta. Okay. And along this, it is going to be E sin theta. Now, this is a very good question. Now, electric field will have E cos theta, E sin theta. Which of the two components is crossing, cos or sin? Sin. So we say here, E sin theta creates flux. So in this particular case, my dear NEET aspirants, flux is going to be, that is EA sine theta. Because here you'll be taking the sine component. It is not always cos component. Okay, it is that component which creates the flux. It is that component which creates the flux, which crosses the surface. Even if some people don't agree with me, I'll use that formula also. Flux is equal to EA cos theta also. I'll use this formula also. If you say this is the general formula. Now, what is, when you say EA cos theta, what is this theta? Theta is the actually angle between electric field and area. This is area A. Now, here electric field is E. What is the angle between electric field and area? This is area A. If this is theta, total is 90. This will be 90 minus theta. So EA cos of 90 minus theta, angle between E and A. Now, my dear NEET aspirants, EA cos 90 minus theta. Cos 90 minus theta is sine theta. So it is going to be EA sine theta. It is going to be EA sine theta. Again, by using that formula also. Now see, Gauss law. Gauss law. What does Gauss law actually say? It says that flux through any closed surface is charge inside divided by epsilon naught. See guys. Let's suppose the diagram is given over here. This is a cylinder. This is a cylinder. I hope this cylinder is visible. This is a cylinder. This is a cylinder. This is a cylinder. Now, my dear NEET aspirants, in this particular case, you have placed a charge inside. We know due to this charge, field lines will come out. Absolutely, sir. Field lines are coming out of this charge. Something like this. Something like this. These are the field lines coming out of the charge. Yes. 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 Now, these field lines are crossing the surface. So, they will create the flux. If I say how much is the flux created over here, you'll be directly writing flux will be in this case Q divided by epsilon naught. Flux is Q by epsilon naught. And Q is the charge placed inside. You don't have to derive because Gauss says flux through any closed surface is equal to charge enclosed divided by epsilon naught. Charge enclosed divided by epsilon naught. Okay. Now in this case also, what is the flux through this closed surface? It is a cube. It will be also Q divided by epsilon naught. So what if I place 10Q? Then it will be 10Q by epsilon naught. Whatever is the charge inside divided by epsilon naught. Okay. Now see, my dear NEET aspirants, in this case, what I am going to do. Let's suppose I say you have a charge placed on the surface, on the edge of the cube. Like this is the cube. On this edge, sorry, not edge, on the face. Sir, is this charge enclosed? The charge is not enclosed. You have to make the charge enclosed. Listen to me very carefully. I'll be making the charge enclosed. Okay. So, directly I would want you guys to understand this particular case. Okay. This is the cube. This is the cube. Okay. Now guys, see. I'll make you understand over here. This charge is not enclosed charge. If you want to make this charge enclosed charge, then in that particular case, you have to attach this cube over here. Then you have to attach this cube over here. Like, let me just show you over here in this case. See guys. Okay. Let's suppose this is a cube. If I say, my dear NEET aspirant, charge is placed inside, what is the flux through the cube? Q by epsilon naught, without a shadow of doubt, because charge is enclosed. You need to make the charge enclosed. But in this case, charge is not enclosed. It is placed on the surface. Surface means it is placed on this face. Some portion is outside, some portion is inside. Now, to make the charge enclosed, what you are going to do is that you will attach one more cube. To make the charge enclosed, you'll attach one more cube. Now here closed surface is formed. This is a closed surface. It is formed due to two cubes. Now if you say in this particular case flux through the closed surface, it will be actually flux through two cubes, because closed surface here is two cubes. And how much is flux through closed surface? That is Q divided by epsilon. So this is the imaginary cube you are attaching. In reality, you are not doing this imaginary. So this is the flux through two cubes. If I say what is the flux through one cube? If I say flux through two cubes is 50. What is the flux through one cube? 25. So it is going to be 1/2 of this Q by epsilon naught. That will be Q divided by 2 epsilon. Okay. Similarly, if you place the charge on the edge is this, on this edge, if you place the charge on the edge, how many more cubes you need to attach to make the charge enclosed? I would say here, flux is going to be Q divided by 2 epsilon naught. Here, 1, 2, and 3. When the charge, guys, directly remember this. Okay, now is not the time to demonstrate every single thing. How is it possible? Directly add 3 more cubes to make the charge enclosed. Okay, and 3 more cubes. Already there was 1, so total is 4. So here closed surface means I would say how many cubes? 4 cubes. So flux through 4 cubes will be flux through closed surface. And that is how much? Q divided by epsilon naught. If flux through 4 cubes is Q by epsilon naught, what will be the flux through 1 cube? Q divided by 4 epsilon naught. Then in this case, if I say, sir, charge is present at the corner, how many more cubes you are supposed to add so that it will become enclosed? I would say add 7 more cubes. In this particular case, add 7 more cubes. So when you add 7 more cubes in this particular case, so total of how many cubes? 8. So I would say flux through the closed surface is going to be flux through the 8 cubes. And that will be simply Q divided by epsilon naught. So this is flux through 8 cubes. If I say, my dear NEET aspirants, what is the flux through 1 cube? That is going to be Q divided by 8 epsilon naught. That is going to be Q divided by 8 epsilon. This one. Okay. So this is the flux through 4 cubes. This is the flux through 1 cube. Q by 8 epsilon naught. I hope this is crystalline clear. Let's talk about this one. This is a cylinder. Guys, is this clear? Tell me. Is this clear? This is the cylinder. Flux passing through R is phi. This is a cylinder in this particular case. And cylinder has got how many faces, by the way? How many surfaces? Okay. Guys, cylinder has got 3 surfaces. Curved one, this plane, this plane. It says flux through. This curved surface is phi naught. If the flux through curved surface, R means curved surface is phi naught, then find flux passing through one plane surface. Guys, when I say cylinder, let's suppose charge is inside. We say flux will come out that will pass through this. So it is passing through 2 plane surfaces as well as curved surface. So this is the net flux. So can I say in this particular case, when you say flux through the closed surface, that means flux through the cylinder. If you say closed surface or you say cylinder, it is one and the same thing. And that is, my dear NEET aspirants, listen to me very carefully. That is, my dear NEET aspirants, I would say flux through closed surface means flux through cylinder. Okay. That means flux through one curved surface. Okay. Plus flux through two plane surfaces. Yes, sir. Two plane surfaces. So either you say complete cylinder, either you say closed surface, or you say one curved or two plane. It is one and the same thing, and that is how much Q divided by epsilon naught. It is Q by epsilon naught. Now this is flux through this much. Now if I say what is, see guys, now consider this portion. So what is flux through closed surface given? Sorry, curved surface given, that is phi naught, plus flux through two plane surfaces. It will be Q divided by epsilon. Now take it over there. Flux through plane surface will be Q divided by epsilon naught minus phi naught. Okay, this is flux through two plane surfaces. If you take this over there, it will be minus phi naught. So flux through two plane surfaces is this much. What is going to be the what is going to be flux through one plane surface? One plane surface. It is going to be one half of I would say Q divided by epsilon naught minus I would say phi naught. One half of Q divided by epsilon naught minus I would say phi. Q by epsilon naught minus I would say phi. Tell me guys, is this clear? Is this clear? Is this clear? Yes. Is this clear? Tell me guys. Okay. Now guys, let's talk about this one. Let's talk about this one. Electric field due to a hollow sphere, metal sphere, or conducting. Either you call it the hollow sphere, metal sphere, conducting sphere, or you call it the spherical shell. Okay. Now, my dear NEET aspirants, in this particular case, let's suppose you consider a hollow sphere. Hollow sphere means football, in which is hollow from inner side. Nothing is present inside, which is hollow. And here in this particular case, my dear NEET aspirants, this is the hollow sphere which you are considering. So in case of a hollow sphere, charge is stored or present on its surface. If you put the charge on a hollow sphere, it will be present on the surface. It will be stored, distributed on the surface. Okay. Now we have to find the electric field at 3 points. Outside the sphere at small r distance, on the surface at capital R distance, inside at any point. Guys, when you talk about the outside point, from a very far distance, from a very large distance, if I say hold a hollow sphere, so from a very large distance, it will look like a point. So whatever is the field due to a point charge, same will be due to the hollow sphere. So electric field outside is kq by r square, small r square. So small r is from the center. From a very large distance, we consider it point. So electric field is inversely proportional to r square outside. Then we say at surface, my dear NEET aspirants, if you move towards the surface, don't you think value of this small r will become capital R? Yes. And exactly at center, value of small r is 0. So at surface, value of small r is capital R. So electric field on the surface is going to be kq by capital R square. Instead of small r, you'll be putting capital R. Now guys, when I say inside charge, is there charge inside? No, sir. Charge is present on the surface, sir. So we say inside charge is 0. So electric field inside is 0. So if charge inside is 0, means electric field inside is 0. Electric field will be only when there is charge. We'll take the break at 12:55. Okay. So it is 12:49, just 5 more minutes. Okay. Okay. Now, my dear NEET aspirants, if I make the graph, guys, see. Let's suppose this is a sphere. Graph is between electric field versus R. From center to surface, don't you think that field is zero? The electric field is zero. That's why I have made the graph on this line. And then if I move outside, from outside the sphere, electric field is inversely proportional to R square. This is outside. So the graph will be rectangular hyperbola. And inside, my dear friends, electric field inside is zero. Electric field inside is zero. And this is surface. At surface, value of small r is capital R. This graph is important, by the way, okay? This graph is important, by the way. And then if I say solid sphere, guys, take a look at the solid sphere. Electric field due to a solid, I would say non-conducting sphere. We also call it non-conducting sphere. Solid sphere, you say. Non-conducting sphere, you say. Now see, in case of a solid sphere, charge is stored in its volume. Solid means, guys, hollow sphere means football. Solid sphere means cricket ball, which is filled from inner side, which is not hollow. See, charge is present inside. So how much charge? Q. Sir, we have to find electric field at 3 points. Outside, at small r distance, surface, capital R distance, and inside at small r distance. Now see. Guys. When I say outside, whatever is for hollow, same is for solid. Why? Because if I give you a hollow sphere or solid sphere, then I look at it from a very large distance. Both will appear point now. So this is a point charge, field, electric field due to point charge, kq by small r square. Okay. And when we say at surface, what is the value of small r? Capital R here also. So kq by capital R square on the surface. And inside right now, my dear NEET aspirant, charge is present. Don't say inside field will be zero. Sir, electric field inside will be kq small r divided by rq. Kq small r divided by rq. Okay. And my dear NEET aspirants, listen to me very carefully. I would say, sir, inside also small r, outside also small r. Yes, it is variable. Small r is variable. See, guys, for outside point, small r is greater than radius, greater than capital R. For inside point, small r is less than capital R. For surface point, small r is equal to capital R. For center, small r is equal to 0. Okay. So here, if you see electric field inside is directly proportional to small r. Electric field outside, it is inversely proportional to small r square. Here it is directly proportional. So could you please tell me how will the graph look like? Guys, this is center, electric field at the center. Okay, this is, I would say, r is equal to capital R. This is surface. Now from center to surface means inside. Tell me, electric field inside is directly proportional to small r when the graph is directly proportional to straight line. And when you move outside, electric field outside is inversely proportional to small r square. So the graph will be rectangular hyperbola. Guys, tell me, is this clear? Is this clear? This graph is also important. You can directly remember this graph also. Is this clear? Tell me quick. Is this clear? Is this clear? Give me the signal in the chats. Okay. Now guys, let's take a long break. Get done with your lunch, or you can go for the prayer also. Break till, I would say, 12. Break till, it is 1:55, 1:50. It is a long break. Okay. Yes. See you after the break. Then we'll have 3 more hours, 3 more hours. Okay, guys, let's get back to the business. Let everybody join. Okay. So, my dear NEET aspirants, let's take a look at this question. This question was actually asked in IIT JEE Advanced 2014. Okay. See, when it comes to the hollow sphere and solid sphere, I recently told you, in case of a hollow sphere, electric field outside is kq by small r square. Okay. Electric field on the surface is kq by capital R square. And electric field inside is 0. And when we talk about a solid sphere, in case of a solid sphere, electric field outside is kq by small r square. On the surface, kq by capital R square, and inside is kq into small r divided by capital R cube, where capital R is the radius. Okay, capital R is the radius. And R is the distance inside where you are supposed to find the electric field. Okay, let's take a look at this question. See, guys, this is the question over here. This is a sphere. This is a sphere. You are supposed to find the electric field at point P in all the 3 cases. And these are the solid spheres. Now, guys, point P is at R distance. If you try to look at this particular sphere over here, this sphere has got radius R by 2. This has got R. This has got radius 2R. So if I say you have to find the electric field at R distance, so R will be outside because its radius is R by 2, na? So this will be R by 2 and this will be R by 2. So total is R. So here same R will be on the surface. Here same R will be inside. So here you need to use outside formula. Here you need to use surface formula. Here you need to use inside formula. Okay. Now, my dear NEET aspirants, if I say in the first case, electric field in the first case, so that is going to be kq divided by small r square. And which formula I am using? Outside. Because outside electric field is kq by small r square. Now, I'll be writing this electric field. This will be k. What is the charge on this? That is q divided by small r. Small r is actually the distance from the center to that outside point. And that is over here, capital R. Array, sir, yes. So I'll be writing over here capital R square. Then, my dear NEET aspirants, if I say in this particular case, I'll be using the surface formula. That is kq divided by capital R square. So electric field on the surface in this case will be k. What is the charge on this? That is 2q divided by, and R. R is the radius. What is the radius of this sphere? That is capital R square. And this is the surface formula. And then, my dear NEET aspirants, I would say in this particular case, I'll be using electric field inside. That is kq small r divided by capital R cube. What is small r? This is the inside formula. In this particular case, you'll be saying that, sir, small r is the distance inside from the center where you have to find the field. Small r is this r here. And this is the radius. So you'll be like electric field inside. It is k. And charge over here is 4q. And instead of small r, you'll be writing capital R. Okay. And divided by, instead of capital R, you'll be writing 2r because its radius is 2r whole cube. So now, guys, what you will write? So this will be 4kqr. And 2 cube is 8. And then we say r cube, 8r cube. Okay. So 4 ones are, 4 twos are. So R, and here it will be R square. So electric field in this E3 will come out to be kq divided by 2R square. Now basically this is the question done. So basically we were supposed to compare where the electric field is more and at which point electric field is less. I think, sir, electric field 2, E2, is greater than electric field on this surface, E2 is greater than, because here it is 2kq divided by r square, 2 times. Here it is 1 times, so it is greater than E1, which is greater than here, kq divided by 2. That is, E2 is greater than E1 is greater than E3. This is the relation between the three. This is the relation between the three. I believe this is crystal and clear to each and every single student. Okay. Now guys, next is electric field due to an infinitely long non-conducting sheet. We have two types of sheets. Let's suppose you have a sheet over here. We distribute a charge on this sheet. Okay. This sheet will be considered as non-conducting sheet. This is an infinitely large. Okay. We have to find electric field due to this sheet. Like, since we have distributed the electric field charge on this sheet, we have to find electric field due to this sheet at this point. Since it has charge, it will create electric field. So electric field due to this sheet will be sigma by 2 epsilon naught. Sir, why do you mention sigma over here? Because when charge is present on the surface, in that particular case, we consider charge per unit area, that is sigma charge density. Now tell me, we say sigma is equal to charge divided by area. I have recently told you. Now put it over here. Electric field will come out to be, that is Q divided by 2A epsilon naught. This is the electric field due to a non-conducting sheet in terms of, this is in terms of charge. And this expression is in terms of sigma. Now, let's suppose if I say I have a conducting plate or conducting sheet. Conducting sheet looks something like this. It looks like these are two sheets. This is one sheet and this is another sheet. In between the sheets, there is no charge, no field in between the sheets. So it is like one sheet, another sheet. Okay. This you can consider as conducting sheet. Okay. Now guys, electric field here is sigma by epsilon naught. Here electric field is sigma by 2 epsilon naught. Here electric field is sigma by epsilon naught. And one more important thing. If I say in this particular case, sigma is total charge. How much is the total charge present on the sheet? That is Q divided by area. Shall you take area A or 2A? Sir, 2A. Area of this is A, area of inner sheet is A. So this is Q divided by 2A. Now put it over here. Electric field will be, instead of sigma, you will be writing Q divided by 2A epsilon naught. So one thing I would want you guys to remember, that is, in terms of charge, electric field due to conducting as well as non-conducting, it will be same. It is obvious because same amount of charge is distributed. Here same amount of charge is distributed on two sheets, and here same amount of charge is distributed on one sheet. That's why electric field in terms of charge is same. But electric field in terms of density is different. Here it is sigma by epsilon naught. Here it is sigma by 2 epsilon naught. This you guys need to remember over here. Okay. So due to a conducting sheet, non-conducting sheet, you'll be remembering sigma by 2 epsilon naught. And due to a conducting sheet, you'll be remembering sigma by epsilon naught. Let's take a look at this particular question over here. See guys, in this particular question, what we are supposed to say, you have two parallel infinitely long non-conducting sheets. You have to tell me electric field at A, B and C. This is point A, this is point B, this is point C. Guys, one thing I want you to understand over here. Electric field due to non-conducting or conducting does not depend upon the distance, because it is an infinitely large sheet. So if I say electric field at this point, 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 it is same. It will be same. So it does not depend upon the distance. So can I say in this case, This is a positively charged sheet. In this case, electric field due to this will be over here, sigma divided by, since it is non-conducting, due to non-conducting, it is sigma by 2 epsilon naught. Due to this, it will be towards the sheet and it will be sigma divided by 2 epsilon naught. Due to the negatively charged sheet, I am showing the direction of electric field towards. So this and this will cancel. So net electric field in this case will be 0. If I say at point B, due to this sheet, it will be towards, and how much it will be? Sigma divided by 2 epsilon naught. Due to this sheet, it will be away. How much it will be? I would say sigma divided by 2 epsilon naught. So here net is not 0. I would say these two electric fields are in the same direction. So net electric field will be simply this plus this. That is 2 times of sigma by 2 epsilon naught. 2 and 2 will cancel. So it will be sigma by epsilon naught. Okay. Yes. Let's talk about point C. Due to this negatively charged sheet, electric field is sigma by 2 epsilon naught. Due to this positively charged sheet, it is sigma by 2 epsilon naught away. This will be cancelled with this. So electric field at point C is 0. So at B it is non-zero, at C it is 0. Let's suppose you have 3 sheets. You are supposed to tell me, and guys, see. I am writing electric field due to all the sheets same. Why? Because it does not depend upon the distance. Don't say, sir, field due to this at this point will be small. No, it will be same. It will be same. It is infinitely large. Let's talk about this question. This is positively charged sheet, negatively charged sheet, positively charged sheet. So if I say electric field at point A, due to this, it will be, let's consider E. E is what? Sigma by 2 epsilon naught. E is sigma by 2 epsilon. Due to this, it is going to be towards, and it will be how much? E. Due to this, it will be away. How much? It will be E. Now this E will be cancelled with this E. Electric field at A will be E. And what is the value of E? Sigma by 2 epsilon naught. Absolutely, sir. Now due to this, electric field at this point will be towards. Consider it E. Electric field at this point will be away. Consider it E. Electric field at this will be away. Consider it E. This and this will be cancelled. So electric field at B will be also, it is E. That is sigma by 2 epsilon naught. Let's talk about point C. Due to this sheet, electric field at this point will be towards E. Due to this sheet, electric field at this point will be away. Due to this sheet, electric field at this point will be away from the sheet. So this will be cancelled with this sheet. Electric field at point C is again sigma divided by 2 epsilon. At point D, due to this sheet, electric field is away. Due to this sheet, electric field is towards. Due to this sheet, electric field is away. Now this will be cancelled with this. So net electric field is again E, and E is sigma divided by 2 epsilon. I believe this is also crystal and clear to each and every single student. Okay. Yes. Let's move on to this one, guys. Let's move on to this one. Motion of a charged particle placed in a uniform electric field. Understand this very carefully. Understand this very carefully. Let's suppose you have an electric field over here. And in this electric field, you are placing a charge which is having the mass M. Okay. Sir, where does this electric field come from? Maybe you might have placed a charge over here. You might have placed a charge over here. Because of that charge, my dear NEET aspirants, this electric field is created. This electric field is created. Now you are placing this charge, another charge in the external electric field. Always remember, whenever an external electric field is placed in whenever a charge is placed in an external electric field, it experiences force. This is the force. And how much is that force? That is Q times of E. Directly remember, Q times of E. Q is the charge, E is the electric field. Now one thing, if I say, my dear NEET aspirants, charge is positive, the direction of force will be the same as the direction of electric field. If I say charge is negative, the direction of electric field will be opposite to the direction of force will be opposite to the direction of electric field. But magnitude wise will be same. And if this is a force, it will have acceleration. Why? Because acceleration is force upon mass. Now force is how much? That is QE, and divided by m, mass is m. So acceleration is QE by m. Then my dear NEET aspirants, directly remember in this particular case, this will be force, this will be acceleration. If I say when force acts on this charge, it will start moving. After time t, it will gain some velocity. So this is the velocity of the charge after time t. I would say velocity after time t. After time t. So how much is that? That is QE divided by m into t. Q is the charge, E is the electric field, m is the mass, t is the time. Now if I say, sir, since force is acting on this, it will move, it will have some velocity. So after time t, how much displacement it will cover, how far it will go. So this is the displacement of the charge after time t. 1 divided by 2, QE by m into t square. 1 divided by 2, Q is the charge, E is electric field, m is mass into t square. This is the displacement after time t. Let's suppose somebody says, sir, what is the momentum? Momentum after time t will be this momentum, because whenever there is mass, it has velocity, it will have momentum. Momentum is QE into t. And if somebody says, what is the kinetic energy after time t? Kinetic energy after time t. What is the kinetic energy of this charge after time t? You simply say it is Q square, E square, T square divided by 2m. Because whenever there is mass, it has motion, it will have kinetic energy. Sir, what is the velocity after displacement x? Velocity after displacement x. It is like, what does it mean, sir? See, let's suppose you have an external electric field, okay? And in this external electric field, you are placing a charge. In this external electric field, you are placing a charge. We say it will cover some displacement. Sir, how much x? So after covering displacement x, how much is the velocity? Like there are two questions. What is the velocity of this object after 10 seconds? This is after time t. Then you will be using this formula when it says in terms of time. If I say what is the velocity of this particle after displacement x, then you will be saying 2QE x divided 2QE by m into x. This is v square. So from here v will be under root of 2QE x divided by m. This is the velocity of the charge after displacement x. I hope this is clear. Okay. Yes. I hope this is crystalline clear. Now guys, see, there is a question. Understand this very carefully, my dear NEET aspirants. Understand this very carefully. This is a very good question. Find the time of fall of electron in comparison to the time of fall of proton. This question is from NEET 2018. Find the time of fall of proton in comparison to the time of fall of electron. See. Guys, you have got an electric field over here. This is the direction of electric field in this case. Means this is the electric field present. Okay. Now you are releasing an electron from this point. It will fall. Force will act on this. Because if the electric field is upward, force on this electron will be downward. So we say, my dear, and it's a gravity-free space. There is no gravity. It is a gravity-free space, my dear NEET aspirant. Okay. Now, my dear NEET aspirants, what I'm trying to say is that this is the electron. On this electron, force acts in the opposite direction. Due to this force, it will fall down. So it will take some time. That is called time of fall of electron. Okay. And when now see, the direction of electric field is downward in this case. You see in this particular case, proton is released. On the proton, force will be in the same direction of electric field. We say it will also fall down. It will take time of fall of proton. We have to check which one is going to take more time or less time. See guys, use this formula. S is equal to ut plus 1 by 2 at square. We say both are released. Electron is released, proton is released. Whenever a particle is released, we consider its initial velocity 0. Release means it is release, initial velocity 0. If you throw something, in that case, initial velocity is not equal to 0. If you throw something, in that case, initial velocity is not 0. So this height of electric field is h. Here also height of electric field is h. So this is h is equal to 1 by 2 acceleration. Acceleration is qe divided by m into t square. Or you can directly use this particular formula. Displacement covered by the charged particle 1 by 2 qe by m into t square. Okay, because acceleration is qe by m. Now take it over here. This will be 2m into h divided by qe is equal to t square. So take the square over here. So t will come out to be under root of 2m into h divided by, I would say, qe. Now, my dear NEET aspirants, what I'm trying to say over here is this time, it is direct. Okay. Tell me, in these two cases, what is constant? Sir, this is falling height h. This is also falling height h. Height h is constant. H is constant. So when it comes to the charge of electron, 1.6 in 10 raised power minus 19. Charge of proton, 1.6 in 10 raised power minus 19. That is negative. This is positive. But magnitude wise, it is same. Charge is same. Okay. Q is same. Okay. And when I say electric field, both are placed in the same electric field. Okay. Magnitude wise, electric field is same. Direction wise, it is opposite. That doesn't matter. But here it is magnitude. So E is same. So all these equations which are constant, you can neglect these because time cannot depend upon constant. So remove H, remove Q, remove this. So I can say this T only depends upon root of mass. So what does that mean? Means the one which is heavier is going to take more time. T is directly proportional to root m. So you'll be saying, sir, mass of proton is much greater than mass of electron. So time of fall of proton is greater than time of fall of electron. So when you take electron, it will reach in less time. When you take release proton, it will take more time. So this is the logic over here. Don't use the logic, sir, the one which is a heavier particle will fall quickly. No, this is not, this is a gravity free space. Gravity is zero here. So they are falling because of the electrostatic force. They are falling because of the electrostatic force. This question. If proton, deuteron and alpha particle, are placed in a uniform electric field. See guys. This is the electric field. This is proton, alpha particle, deuteron and alpha particle. They are placed in a uniform electric field. Find the ratio of their momentum after time t. Even find the ratio of their kinetic energy also. See, when I say proton, when I say deuteron, when I say alpha particle, directly remember from now onwards, guys. First we'll write charge, then we'll write mass. Charge of proton is E, mass of proton is m. Charge of deuteron is E, mass is 2m because it is 1h2. Charge of alpha particle is 2e, mass of alpha particle is 4 times mass of proton. Simple. Mass of charge of this is same as charge of proton. Mass is 2 times mass of proton. Charge is 2 times, mass is 4 times. Okay. It says you have to find the ratio of their kinetic, find the ratio of their momentum. When it comes to the momentum of a charged particle, you say QE into T. Now guys, see, in this particular case, all the 3 particles are placed in the same electric field. After same time they are saying, so these are constants. So can I say this momentum only depends upon what? Charge. So the one which has more charge will have more momentum. Let's find the ratio. Momentum of proton is to momentum of deuteron is to momentum of alpha particle. It is going to be, so charge, that is E is to, I would say 2E. E and E will be cancelled. So 1 is to 2. I can write it something like this. Then my dear NEET aspirants, if I say what is the ratio of kinetic energy also? What is kinetic energy equation? Kinetic energy is Q E square. What is kinetic energy? Q square E square divided by 2m. Q square E square divided by 2m. Q square E square T square divided by 2m. Now for all the three, whatever is constant, remove that. Sir, I think charge is not constant. I think electric field is constant because they are placed in the same electric field. I think time is constant, so these two are constants. So can I say kinetic energy will only depend upon Q square divided by 2m? Yes, I can say it like that. Kinetic energy only depends upon Q square by 2m. So can I say in this particular case, kinetic energy of proton is to kinetic energy of deuteron is to kinetic energy of alpha particle. Guys, Q square by m. Q square by m. Don't write 2 because 2 is also constant. So Q square by m. So charge of this divided by mass of this, that is E square divided by m, is to charge of this mass of this, that is E square divided by 2m. Then charge of this, that is 2E square, that means 4E square divided by 4m. Okay, what can you cancel in this particular case? 4, E square, m. So it will be 1 is to 1 by 2 is to 1. So cross multiply 2 into 2. So 2 is to 1 is to, I would say 2. This is basically the answer. So multiply this 2 with 1. 2 with 1. 2 into 1 is 2. 2 is to 1 is to 2. So this is the ratio of kinetic energy. This is the ratio of momentum. This is the ratio of momentum. This is the ratio of momentum. Now guys, see this one. Charged particle projected perpendicular to the electric field. If you send a particle perpendicular to the electric field, this is electric field, okay? You are sending a charged particle which has charge Q mass m perpendicularly, something like this. It is perpendicular to the electric field. Now guys, whenever you send a charged particle inside the electric field, listen carefully. We say its charge is Q and its mass is m. We say on this force will act, that is Q times of E. Force will act Q times of E. Since it wants to go straight, cross this electric field. But due to this force, it is deviated from its path. So this force which is pulling it in the upward direction, it is deviating it. And it comes out at an angle of theta. And if somebody says how much is this theta is tan inverse of Q. Q is the charge. E is the electric field. D is the width of electric field divided by m. M is the mass into U square divided by mu square. This is the angle at which the charged particle comes out of the electric field. So this is following the parabolic path, projectile path. This is the projectile path. It is like if you throw a projectile, it will fall and it will fall down. Similarly. So this is the parabolic path. Now, one thing I just want you to understand over here. See, my dear NEET aspirants, listen carefully. Let's suppose this is the electric field over here. This question is very important. Okay. This is the charge Q. You are launching it with a velocity v. Understand this very carefully, my dear NEET aspirants, please. You are launching it with a velocity v. And it's a gravity-free space. No gravity. Gravity-free space. If you are launching this charged particle with velocity v at an angle theta, we say it will go high. Since due to this electric field on this positive charge, when it reaches here, we say in the downward direction, I would say Q times of E is acting. At this point, I would say Q times of E is acting. So it wants to go straight, but due to this QE, it will follow this parabolic path. It will follow the parabolic path. Here, my dear NEET aspirants, it is not mg acting because it's a gravity-free space. It is QE. Due to QE, it is following the parabolic path. Now, if I say, in this particular case, since it is following parabolic path, projectile motion, it is a projectile motion, what is the time of flight? How much time it will reach the ground once again? So guys, when it comes to the time of flight, listen carefully. In projectile motion, that is 2u sine theta. U is the velocity with which you are launching. Theta is the angle with which we are projecting, divided by g. G was the acceleration due to gravity. That acceleration which is due to gravity, But instead of G, you have here, instead of G, we use QE divided by M. Over there, acceleration was G. Here, acceleration is QE by M. And that's what we studied recently. 2u sine theta divided by G. Instead of G, I'll be writing over here QE divided by M. This is going to be the time of flight in this particular case. I believe this is clear. I believe this is clear. Then, my dear friends, if I say maximum height, H max, maximum height means how high it can go. How high it can go. Okay. So, maximum height formula was, that is u square sine square of theta divided by 2g. Instead of g, we use QE divided by M, because acceleration here is QE divided by M. This is the maximum height. Then we define range also. Range means how far it can go, in the horizontal direction. So range over there was, guys, see, that is 2u sine theta, u sine theta, u cos theta divided by G. Instead of G, we write QE divided by M. Instead of G, we write QE divided by M. This is the range in that particular case. I believe everything is crystalline clear. One more important question. A positively charged pendulum is oscillating in a uniform electric field in the given figure. Find the time period of oscillation. It is not a gravity-free space. See, guys, this is a time period. It has this bob. Remember this directly, if there is a pendulum which is oscillating, sir, time period of pendulum means what? Time period means in how much time it will complete one oscillation. See, one oscillation means if this is a pendulum, if you displace, it will go here. Then it comes back. This is called half the oscillation. Then it goes here. Then it comes back. This is one oscillation. Or here comes back. Then here comes back. This is one oscillation. In how much time it is going to take in completing one oscillation. So this time period is 2 pi under root of L divided by G. This is the time period of oscillation. Directly remember this. We say here. In this particular case, my dear NEET aspirants, what I can write, this time period will be, that is 2 pi under root of. Guys, see. On this charge Q, listen carefully. We say electrostatic force will be acting in the upward direction. Okay. That is electrostatic force. F electrostatic force. And mg will be acting in the downward direction. We say here you will be writing 2 pi L under root of L. L is the length of the string. Divided by, instead of G, you will be writing G minus QE by L. When you have this in the gravity. When gravity as well as electrostatic force is present. Now guys, another one. If let's suppose electric field is in this direction. Now this is the pendulum Q. Now if electric field is in this direction, we say mg will act downward. We say electrostatic force will also act downward. In this particular case, if you have to write the time period of this pendulum, you'll be simply 2 pi under root of L divided by G plus QE by. Please directly remember these two expressions. 2 pi under root of G divided by 2E by. Okay. Yes. So if electric field is in the upward direction, opposite to this, then you can write G minus QE by M. This is the net acceleration, effective acceleration. Here, this is G plus QE by M. Please tell me in the chats if this is crystalline clear till over here. So that we move on to the dipole. Quick guys, quick. Make it fast. Tell me in the chats. Quick. Electric dipole. Give me the signal in the chats. Is this clear? Do smash the like button, guys, if you are not liked the session yet. Huh? Then, my dear NEET aspirants, electric dipole. What does electric dipole actually mean? See, we say when two equal and opposite charges are placed at a very small distance, it forms electric dipole. Like you have got this charge, it is minus q. You have got this charge, it is plus q. They are placed at a distance of d. This is what we call electric dipole. And we say every dipole has a dipole moment. So that dipole moment is represented with P. And this P is magnitude of charge multiplied by separation between them. Like this dipole, it has a dipole moment, that is this P. Okay. It is always from negative charge to positive charge. And this dipole moment is equal to, that is magnitude of charge Q multiplied by separation between them, that is D. So this is the dipole moment between the of the dipole. Dipole moment kind of tells you the strength of the dipole. Okay, more is the charge, more will be the dipole moment. As simple as that. So when two equal and opposite charges are placed at certain distance, it forms dipole. Sir, can we call this as dipole? Minus 2q plus 2q. Absolutely, absolutely. Sir, minus 4q. And this will be minus 4q. Is this a dipole? No, sir. Because the two charges are magnitude wise, they are same, but they are not opposite. They must be opposite. So plus, now it is a dipole. Okay. See, guys. This is a question that we have on the screen. Before this, let me show you this one. Okay. Okay. Now, guys, see. When it comes to this particular question, you have to tell me what is the net dipole moment in this particular case. See guys. Over here, this is a negative charge, this is a positive charge. Dipole moment is always from negative to positive. This will be the dipole moment. And when it comes to this and this, dipole moment is going to be this. This will be the dipole moment. So you can make it something like this, guys. You can make it something like this. This is dipole moment P. This is dipole moment P. Okay. And this is the angle 90 over here. Tell me, if you have two dipoles in which angle between the two is 90, what is the net dipole moment? In that particular case, net dipole moment will be root 2 of P. Now, this will be root 2 of. Now, guys, what is P? P is the charge Q multiplied by distance between the two, Q into D. So, it will be like a root 2 and then charge is Q only. Now, guys, what is the distance between the two charges? From here to here, radius is R. So, this will be also R. R plus R is 2R. So, that is going to be 2R. So, take this 2 here. So, this will be 2 root 2 Q into R. This is the net dipole moment. Let's talk about this one. See, guys. You have 3Q, you have Q, you have 2Q, you have 4Q. Sir, can we consider this as a dipole over here? Guys, let me show you how can we make this a dipole. See. Can we do one thing? Keep this minus Q as it is. We have to find net dipole moment over here. Keep this minus Q as it is. And this minus 3Q, you can break it with plus Q and plus 2Q. Again, minus 2Q, plus Q, plus 2Q is plus 3Q once again. This minus 4Q, you can write over here minus 2Q, minus 2Q. Because minus 2Q is plus 4, minus 4Q. And this plus 2Q over here. Now, my dear NEET aspirants, if you take a look in this particular case, this forms one dipole, negative and positive charge. This forms another dipole. This forms another dipole. Array, sir. Done and dusted, sir. Done and dusted, sir. Now tell me, guys, in this particular case, can I say dipole moment will be from negative to positive? Yes. In this case, dipole moment is from negative to positive. In this particular case, dipole moment is from negative to positive. This will be P. This will be 2P. This will be 2P. Why 2P? Guys, magnitude of charge is twice. So dipole moment will be twice. Magnitude of charge is Q and Q. So dipole moment is P. Now you can make it like this. Guys, This dipole moment is downward, you can make it like this. This dipole moment is upward, you can make it like this. And this dipole moment is backward, you can make it like this. There is no problem in that. So this is P, this is 2P, this is 2P. Now what is the resultant of this one and this one? You'll say, sir, 2P minus P. If this would have been P, this was P, then they would have cancelled each other. But since this is 2P, this is P, so 2P minus P is P. So in this particular case, my dear NEET aspirants, this is 2P and this is P. This is P. So 2P minus P is P and this is 2P. Now resultant of this one and this one, it is going to be this. This will be P net. And if somebody asks you what is the value of net dipole moment over here, you say value of net dipole moment in this particular case, it will be under root of this square, that is 2P whole square, plus this square, that is P square. So this, my dear NEET aspirants, would be 2P whole square will be 4P square, plus I would say P square. 2 square is 4, 4P square plus P square. 4P square plus P square is 5P square. So this will be 5P square. So this is going to square and root will cancel, but for 5 it will remain. So root 5P. Root 5P is the net dipole moment. Is this clear? Oh? Okay. Now guys, see, electric field due to an electric dipole. Electric field due to an electric dipole at an angle theta. Guys, see, listen to me very carefully. You have a negative charge over here, you have a positive charge over here. So its dipole moment will be P, from negative to positive. Now you go at an angle of theta at this point P, which is at x distance. You find the electric field. Guys, see. Does dipole have charge in it? Yes, negative and positive. Dipole does have charge in it. Okay. So if dipole does have charge in it, so it will create electric field because charge has electric field. So we have to find electric field at x distance, which is at an angle theta. So electric field will be this. Kp, P is the dipole moment, divided by x cube. X is the distance at which you have to find the field. Then under root of 3 cos square theta plus 1. Then under root of 3 cos square theta plus 1. Kp by x cube under root of 3 cos square theta plus 1. This is the theta. Let's suppose if I want you guys to decrease the value of theta. So you reach this particular point. This is what we call the axial point. Axial point. Could you please tell me, guys, this theta is actually angle between this x and dipole moment. Dipole moment is forward. If you reach the axial point, don't you think that angle between this dipole moment and x will be 0? So for axial point, what is the value of theta? 0. If you put theta 0 over here, electric field will be Kp divided by x cube. Then under root of 3 into cos square of 0. Cos 0 is 1. So this will be 3 plus 1. Because this term will be 1. 3 into 1 is 3. 3 plus 1 is, this will be root 4. Root 4 is how much? 2. So this will be 2Kp divided by x cube. This is the electric field at the axial point, at axis of the dipole, at this point. This is the general point. This is the axial point. Let's suppose if I talk about this point. If I talk about this point, this is the equatorial point. This is the axial point. At equatorial point, what is the angle? Theta will be 90. So we say theta will be 90 at equatorial point. So what is going to be the electric field at equatorial point? So that is Kp divided by x cube under root of 3 cos square theta. Theta is 90. So cos 90 is 0. So this will be cos 90 is 0. So this will be root 1. This term will become 0 now. Cos 90 is 0. 0 into 3 is 0. So then it will be plus 1. Root 1 is 1. Root 1 is 1. So it will be Kp divided by x cube. And most importantly, my dear NEET aspirants, you write minus Kp by x cube. Why? Because at this point, electric field will be net in the backward direction. Here it will be in the forward direction. Directly remember, electric field due to this dipole at axial point will be in the forward direction. At this point, equatorial point, it will be in the backward direction. So that's why I'm writing minus Kp by x cube. Backward direction as is opposite to the direction of dipole moment. At axial point, electric field will be in the same direction of dipole moment. At equatorial point, electric field will be opposite. In the opposite direction. In the opposite direction. See, this is the on axis. At axial point. 2 Kp by x cube. At equatorial point, it will be in the backward direction. Why backward? Let me give you the logic also. Due to this negative charge, electric field will be towards. Due to this positive charge, electric field will be away. The net will be in between the two. So that is net will be at equatorial point. Simple. Simple. Okay. Let's move on to this, guys. See, find the electric field at point A and point B. This is a dipole. Due to this dipole, you have to find the electric field at point A and B. And this side is L. How much is going to be this? That is root 2L. Guys, clearly you can see this point A is the general point because angle is given over there. Na? It is like this point, A point. So what is the electric field due to a dipole at point A? Guys, electric field at point A, I'll be using the general formula. Kp by x cube under root of 3 cos square theta plus 1. Theta is how much? 45. So electric field will be Kp divided by x is how much? That is root 2L. Root 2L whole cube. Then under root of 3 cos square of theta, that is cos square of 45 plus 1. Now you need to solve this. Huh? So Kp divided by, that is root 2L cube. Root 2L cube. Root 2L cube. 3 cos square theta plus 1. Cos 45 is 1 by root 2. 1 by root 2 whole square becomes 1 by 2. So this becomes 3 by 2 plus 1. This becomes 3 by 2 because 1 by root 2 whole square is 1 by 2. Square root will cancel. That's why 1 by 2. Now 2 into 1 is 2. 2 plus 3 is 5. So it is going to be Kp divided by root 2L whole cube. Then this is going to be a root something like this. Root 5 divided by root 2. Now how many times root 2 is there, guys? 4 times. Root 2 whole cube into root 2. So root 2 into root 2 into root 2 into root 2. So root 2 into root 2 is 2. Root 2 into root 2 is 2. Now 2 into 2 is 4. So I can write it like this. So Kp directly root 5 divided by 4. Instead of these root 5 by 4. Then Kp divided by L cube. Kp by L cube. This is the net electric field at point A. And if I say what is the electric field at point B? Don't you think that this point B is the axial point? And electric field at axial point is 2 Kp divided by x cube. And what is the value of x for this point? That is L. So this will be 2 Kp divided by L cube. I hope this question is crystal and clear. Let's talk about this question. I hope this is crystalline clear. I hope this is crystalline clear. Find the net electric field okay guys, from tomorrow you will have the classes in the Phoenix batch. Okay, please do not worry about that. I told you already, na? 2 classes. I'll be taking 2 classes every single day. From tomorrow till 15th of March, we'll get done with the syllabus. Now guys, find the net electric field at point A in the given figure. You have two dipoles, this one and this one. This one and this one. Due to this, guys, one thing I recently told you, if this is a dipole, this is called equatorial point, this is axial point. At axial point, electric field will be in the same direction. At equatorial point, electric field will be in the opposite direction. Yes. Now see, due to this, for this point is going to be the equatorial point. Okay, you can rotate it also. You can rotate it also. It will become equatorial point. And for this dipole, this is going to be the axial point. Now, due to this, electric field will be in the same direction. How much will be that? 2kp divided by, this distance is r cube, 2kp by r cube. Cool. And due to this, electric field will be opposite to the direction of dipole moment, because this point is the equatorial point for this dipole. And how much is that going to be? That is going to, at equatorial point, it is kp by x cube. And instead of p, I'll write 8p. It is 8p divided by x cube. X is r plus r. That is 2r. So that is 2r whole cube. I hope this is crystal and clear to each and every single student. Now, how much it is going to be? That is 8kp divided by 2 cube is 8r cube. Array, sir. This also comes out to be a kp by r cube. Okay, this is 2kp by r cube. Okay. So guys, what is the resultant of this one and this one? Resultant of this one and this one will be this P net. And when two vectors are at an angle of 90 degree, what is the resultant? Resultant will be this square plus this square. How much is the resultant at 90 degree? P net is equal to under root of P1 square plus P2 square plus 2 times of P1, P2 cos 90. And cos 90 is 0, guys. So this term will become 0. Only this term will remain. Under root of P1 square plus P2 square. So P1 square is 2kp divided by r cube, its whole square. Plus, for this, it is going to be kp divided by r cube, its whole square. So this is going to be, guys, 2 square is 4. So this will be 4 kp divided by r cube, its whole square. Keep the square of this as it is. Only do the square for 2. Then plus kp divided by r cube whole square. Now 4 times of kp by r cube whole square plus kp by r cube whole square. This will become 5 times. 5 times kp divided by r cube, its whole square. Now its square and root will cancel, but for 5 it will remain. So root 5 kp divided by r cube is the final answer. Root 5 kp by r cube is the final answer. What about this? Find net electric field at the center. Find net electric field at the center. Find net electric field at the center. See guys, this is the dipole. Due to this dipole, electric field at the center will be, my dear NEET aspirants, electric field at the center will be something like this. And how much? 2kp divided by r cube. Because this is the axial point for this dipole. For this dipole, this point is also axial point, and this will be 2kp divided by r cube. Yes. For this dipole, this will be the equatorial point. And at equatorial point, electric field is opposite to the direction of dipole moment. So in this direction. And that will be kp by r cube. Array, sir. Array, sir. Now tell me guys, what is the resultant of this and this? 2kp by r cube minus kp by r cube. That is kp by r cube. But direction will be along the bigger vector. So this will be kp divided by r cube. And in the upward direction, you have 2kp divided by r cube. Now, my dear NEET aspirants, in this particular case, the resultant of this one and this one, it is going to be this. So this is going to be the net dipole moment in this particular case, and that is under root of this square plus this square, 2kp divided by r cube, its whole square, plus this kp divided by r cube. Again, when you solve this, it will come out to be a root of 5 kp divided by r cube. This is the answer to the question. Is this clear? Give me the signal in the chats. Is this clear? Come on, guys. Come on. Torque on a dipole placed in the uniform electric field. Torque on a dipole placed in a uniform electric field. Torque on a dipole placed in a uniform electric field. Now, guys, see. This is a dipole over here. This is a dipole over here. This is the electric field over here. This is the electric field. And in this electric field, you are placing a dipole. This is a negative charge. This is a positive charge. Okay. On this positive charge, force will act in the same direction of electric field, and that is Q times of E. On negative charge, force will act in the opposite direction of electric field. Yes. Now, don't you think that these two forces will try to rotate the dipole? Yes. These two will try to rotate the dipole. And when there is rotation, we say there is torque. Sir, torque, what is torque? Torque is basically, if I say this is a body, when you apply force on a body, it will rotate. But if I say this is a rod, if you apply force on this rod, torque will be created due to which it will rotate. Simply in shortcut, you remember, when there is rotation, there will be torque. Okay, torque is acting on this particular body. If the body was rest, if body was at rest, now it started rotating, it is because of the torque. If body was at rest, now it started moving, it is because of the force. It is because of the force. So when here, the body will rotate, dipole will rotate, torque is produced. And torque in this case will be how much? That is P. P is the dipole moment. E sine theta. Dipole moment of this dipole is from negative to positive, and electric field is in the forward direction. This is E, and this angle is theta. Angle between dipole moment and electric field is theta. So we can also write it P cross E, because A cross B is AB sine theta. So cross product of, I would say dipole moment and electric field is torque. Okay. Yes, is torque. I believe this is crystal clear. I believe this is crystalline clear. Okay. Let's first understand this potential energy, then I'll show you the questions. So whenever you place a dipole in an external electric field, in the previous question, it was E net, net electric field, not net dipole moment, net electric field. I mentioned now. Find the net electric field, not dipole moment. Net electric field. Net dipole moment was here. That I asked you here. Now see, electrostatic potential energy. See guys, I'll tell you a concept over here. There is a beautiful concept. What is that? This I have told you already in gravitation, in work, power and energy, if you remember. See guys, let's suppose if you have an object placed on the surface, what is the potential energy stored on it? Zero. On the surface, we assume potential energy to be zero. Now, if you take it to the height h, by doing the external work done, you applied external force, okay? So if you are taking the object to the height h, we say at height h, its potential energy stored will be mgh. How was this potential energy stored? When you lifted the object from the surface to height h, then only potential energy is stored. Else, there will be no potential energy in this one. Now, my dear NEET aspirants, in this particular case, what I want you to understand here is, if you lift an object from surface to height h, we say you did the work done. Due to that work done, potential energy is stored. So initially it was 0. Finally it is something. So due to this external work done, I would say potential energy has been changed. So that is delta U. And how much potential energy has been stored finally? That is mgh. How was it stored? Because of the external work done when you lift the object from here to here. And what is the force acting in the downward direction? That is mg. And I have so many times told you this external force, its magnitude is exactly equal to magnitude of mg. Whatever is the value of this, if this is 10 Newton, you will be also applying the 10 Newton force. You will not apply 11, 12, 13, 14, something like that. So whatever is the work done of this external force, same must be the work done by mg. Absolutely, sir. And here instead of delta, you will be writing minus delta U. Why? Because mg is opposite to external force. That's why you are putting the negative sign over here. See, magnitude wise, they are same. Whatever the amount of work external force does, same amount of work this will do. But in the opposite direction, because this is opposite to this, that's why negative sign over. Same is the case over here. Guys, so what I'm trying to say is that when you lift this ball from surface to height h, you did the work. You use external agent did the work. I'm the external agent who lifted the block. I used my own energy. And that energy was stored in the form of potential energy. Use the same analogy over here. See? Let's suppose dipole is at this point initially, P. This is the dipole placed in the external electric field. Dipole means this will be the negative charge, this will be the positive charge. I'm representing with P here. Now I am rotating the dipole. And I rotated it by theta. Who rotated the dipole? Me. Who am I? External agent. I did the external work over here. On rotating the dipole, you have to do the external work done. Okay. That will be stored as potential energy. Of the dipole. So here at this instant, it has some potential energy. So when you rotate it, its potential energy was changed. Its potential energy was gained. So can I say due to the external work done here also, potential energy is changed? Yes. And one more important thing, work done by, here you say work done by mg. Mg means conservative force. I have told you this previously, which does not depend upon the path. Directly remember, mg means conservative force. So electrostatic force is also a conservative force. Mg is also a conservative force. So we can say work done due to conservative force will be what? Negative of change in potential energy. These equations are valid here also. So when you did the external work done, my dear NEET aspirants, due to that external work done, potential energy was changed. And that change in potential energy is over here. Now if somebody says, sir, no doubt you changed the potential energy of this to this. How much is the potential energy stored finally? How much is the potential energy stored finally at an angle theta? We say at angle theta, potential energy is minus P, P is the dipole moment, E is the electric field, cos theta. P E cos theta, you can write also P dot E, because A dot B is AB cos theta. Like here, when you did the external work done, potential energy was changed. How much was the potential energy change? mgh, from 0 to mgh. So here also, when you rotated the dipole, potential energy is changed. So how much is the potential energy stored at angle theta? Minus P E cos theta. I believe this is crystalline clear. Okay. I believe this is crystalline clear. Now guys, take a look over here. Case 1. When theta is equal to 90 degrees, this is the electric field, this is the dipole moment. Okay. If the dipole is rotated at an angle of 90 degree, what is the potential? Okay, first tell me what is the torque. Torque is, that is PE sine theta. Sine of 90. Array, tell me na, how much is the torque at an angle of 90 degrees? I told you. How much is the torque at an angle theta? PE sine theta. How much torque is acting at an angle theta? PE sine theta. So in this particular case, if I say, chalo, it is mentioned over here. Why do I have to write it again and again? See. What is the net force acting on this dipole? Let me just show you over here. Guys, this will be negative charge. This will be positive charge because dipole moment is from negative to positive. On the negative charge, force will be in the backward direction. On the positive charge, force will be in the forward direction. The two forces are equal and opposite. So net force will be 0. What is net torque? That is PE sine of 90. Sine 90 is 1. So torque will be P into E, maximum torque. This is called maximum torque. And potential energy at 90 degrees. Recently you studied what is the potential energy? Minus PE cos theta. So you will be writing over here, this will be minus PE cos of 90. Cos 90 is 0. So this will be 0. Okay. Now, let's suppose, my dear NEET aspirants, if the dipole is at an angle of 0 degrees. If the dipole is at an angle of 0 degrees. If the dipole is at an angle of 0 degrees. 0 degree means parallel to the electric field. So this will be negative charge. This will be positive charge. Now tell me, in this particular case, on the positive charge, force will be in the same direction. On negative charge, force will be in the opposite direction. What will be the net force? 0. What will be the net torque? PE sine theta. Sine 0. Sine 0 is 0. What will be the potential energy? Minus PE cos 0. Cos 0 is 1. So it will be minus PE. It will be minus PE. And this is called minimum potential energy. Minus P is minimum potential energy. And this is what we call the stable equilibrium. Directly remember, stable equilibrium of the dipole will be when it has minimum potential energy. When it has minimum potential energy. Come here. Come here. Let's suppose the dipole is something like this, my dear NEET aspirants. The dipole is something like this. The dipole is something like this. In this particular case, this will be the negative charge, this will be the positive charge, because dipole moment is from negative to positive. On this negative charge, force will be backward. On this positive charge, force will be, on the negative charge, force will be opposite. On the positive charge, force will be in the same direction. So since the two forces are opposite and equal, net force will be 0. Now, if I say what is the value of net torque? Sir, net torque is PE sine of 180. Sine 180 is also 0, so net torque will be also 0. Okay. So in this particular case, my dear NEET aspirants, we say what is the potential energy? What is the potential energy? Listen carefully. What is the potential energy in this particular case? You say, sir, potential energy in this case will be minus PE cos 180. Cos 180 is minus 1. Minus into minus is plus, so potential energy is this. So this is the maximum potential energy. And this is called unstable equilibrium. Directly remember, at theta is equal to 90 degrees, potential energy is 0 and torque is maximum. At theta is equal to 0 degrees, when dipole and this is placed in the same direction, torque is 0. Potential energy will be minus PE, that is minimum potential energy, and it is called unstable. It is called stable equilibrium. And when theta is 180, means opposite direction, we say net torque in that particular case will be 0. Net force will be also 0. And potential energy will be plus PE. This is called, I would say, unstable equilibrium. That is stable equilibrium. I hope this is crystal and clear. Let's suppose this is the question that you have on the screen. This is the let me write it. once again. The question is, find the work done by external agent in rotating the dipole. Find the work done by external agent in rotating the dipole from stable to unstable equilibrium. Okay, this is the question. Stable to unstable equilibrium. Stable equilibrium is theta is equal to 0. Unstable equilibrium is theta is equal to 180. Means initially dipole is something like this. This is initially. And finally it is something like this. Okay. So initially what is the value of theta? 0. Finally angle is 180. So when it comes to the work done, you always say it is change in potential energy. Array sir. So it is final potential energy minus initial potential energy. So work done will be final, and it is work done by external agent. If it was work done by, if it was work done by, I would say the conservative force, then in that particular case, I would have said that is negative of change in potential energy. But here it is positive of change in potential energy. So my dear NEET aspirants, final potential energy minus initial potential energy. So final potential energy. So what is the value of potential energy? That is minus PE cos of theta. Minus PE cos theta. So work done will be that is final potential energy, that is minus PE cos theta. So cos of, what is the value of theta in this particular case? Guys, finally, how much angle it is making? 180. So minus PE cos of 180 minus, this is initially PE cos of 0. Because initially it is making how much angle? That is 0. Now tell me here. So this will be minus PE cos 180 is minus 1. Minus into minus is plus. So this is PE cos 0 is 1. Minus into minus is plus. PE plus PE will be 2 times of PE. So this is going to be 2 times of PE in this particular case. Please tell me if this is clear. Please tell me if this is clear. Is this clear? Okay. Let's move on to the electrostatic potential energy. Okay, guys, let me just give you a basic idea. Let me just give you a basic idea over here. See, electrostatic potential energy is basic idea. Let's suppose you have a charge Q1 over here. And there is one more charge Q2 over here, which is at infinity. At infinity, we assume potential energy to be zero. Now, if I say you bring this charge from here to here. So when you are bringing the charge from here to here, let's suppose at what distance? R distance. Okay. From where? From infinity. So in order to bring the charge from infinity, you will have to do the external work. You will have to do the external work done. Okay. Yes. And my dear NEET aspirants, we say this charge is repelling this charge in this direction. This will be electrostatic force. On this charge, if this was Q2, we are bringing this charge from infinity to this distance. So on this charge Q2, we say electrostatic force is acting. Okay. Electrostatic force is acting. And my dear NEET aspirants, we are applying the external force in the opposite direction of electrostatic force, means we are doing the work. So when you took the charge from infinity to this distance, work has been done. Due to that work done, again potential energy will be changed. Here potential energy is zero, here potential energy will be UR, potential energy at R distance. And my dear NEET aspirants, we say potential energy, this work done, this is work done by external agent. If I say work done by conservative force, work done by conservative force means work done by electrostatic force. Whatever is the work done of external, same will be the work done of electrostatic, but it will be negative. Why? Because it is in the opposite direction. Directly remember, same thing again I'm saying. If you are bringing the charge from infinity to here, work has been done. That work will be stored in the form of potential energy. That work will be stored in the form of potential energy. And that, due to that work done, potential energy is changed. That is delta U. So work done by conservative force is equal to negative of change in potential energy. Now, if you say, sir, how much potential energy will be stored at R distance? You say simply, it will be K, Q1, Q2 divided by R square. These three things you need to remember over here. These three things you need to remember over here. Okay, these three things you need to remember over here. So on bringing the charge from infinity to R distance, you will have to do the work done. Due to that work done, potential energy will be changed. Okay. So we say due to the external work done, potential energy is changed. So whatever is the work done of this, because we say external force is exactly equal to negative of this external force is equal to, I would say, this electrostatic force, or I would say negative of electrostatic force. So whatever is the work done for this same will be for conservative force, but negative. And how much work has been done, or how much energy you have stored at R distance? K, Q1, Q2 by R. Okay. Now, if I say, my dear NEET aspirants, you are displacing this charge by a small distance. You are displacing this charge by a small distance. That is dr. You are displacing this charge by a small distance dr. Means you have done the small work dw. Absolutely, sir. So can I say, due to small work done, can I not say in this particular case, sir, this dw will be equals to small change in potential energy? Absolutely, sir. So how do we write the work done? Work done means force multiplied by displacement, F into dr. Force multiplied by small displacement is small work done, is equal to minus du. So you can write this force will be as minus du divided by dr. Minus du divided by dr. Okay. So this is what we call the relation between force and potential energy. This is what we call the relation between force and potential energy. Now, my dear NEET aspirants, I'm directly saying over here, if you have brought Q2 from infinity placed over here, how much is the potential energy stored between the two? That is K, Q1, Q2 by R. This is the potential energy stored between the two charges. Now let's take a look. Let's say if somebody says find the net potential energy of the system, if somebody says what is the net potential energy of this particular system over here, what is the net potential energy of this system over here, you'll simply say net potential energy of this system will be potential energy. Check how many pairs are over here. Guys, see, between this and this k q1 q2 by r, how many pairs will be formed over here? You can clearly see between this and this k q1 q2 by l, k q1 q2 by l, k q1 q2 by l, k q1 q2 by l. Okay, 4 corner pairs, and this one diagonal pairs. So k q1 q2 upon root 2l. Between this one and this one, k q1 q2 upon root 2l. So 4 side pairs, 2 diagonal pairs. So what I can write in this particular case, net potential energy will be k q1 into q2 is q square divided by I would say L. And this is how many times? I would say 4 times plus this. The diagonal pairs. K q into q becomes q square divided by a root 2 into L. And this is 2 times. Okay. This. Okay. K q square, this will be 4 k q square divided by L plus 2 divided by root 2 k q square divided by L. Okay, this is a question which was asked in NEET 2022. This is a NEET 2022 question. Okay. In this question, it says that you have got six charges, something like this. And there is this charge. This charge was initially at infinity. This charge Q naught was initially at infinity. It says if we bring this charge from infinity to the center, how much work is being done in this particular case? How much work we are supposed to do if we bring the charge from infinity to the center? Because if we bring the charge from infinity to the center, you have to do the work done. No? How much work you are supposed to do? Guys, see, the work done in bringing the charge Q naught to the center of the hexagon from infinity. When it comes to the work done, it is change in potential energy. That is final potential energy minus initial potential energy. Tell me guys one thing. Initially it was at, this is initially it was at infinity. So what is the potential energy at infinity? That is 0. Finally it is at center. So initial potential energy is 0. Finally, I would say in this particular case, potential energy at center. See guys, when this is at center, potential energy between this and this, between this and this, between this and this, between this and this, this and this, and this and this. Let's write final potential energy. So first write the potential energy between positive charges. K Q naught Q. K Q naught Q divided by, and if this side is D, this will be also D, because in case of hexagon, all the sides are same, D. Now see, the similar pairs, this one, and this one. So I would write 3 times. For negative charge, I'll be writing separately, minus, because when you write the potential energy between positive and negative charge, you mention the sign also. You have to write it along with the sign. You have to mention it along with the sign. Keep that thing in your mind. Then minus potential energy between this and this, this and this, this and this. So it will be 3 times of K Q naught Q divided by D. This and this will cancel. Final potential energy is also 0. Okay. So if somebody says, sir, what about the potential energy of between these charges? If you consider that also, that will be also cancelled. Consider that initially, consider that finally, that will be also cancelled. So we say work done is going to be 0. Final potential energy minus initial potential energy. Work done is 0. Electric potential. See what is electric potential. Guys, take a look. What is electric potential? What is electric potential? Okay. See, electric potential is nothing but potential energy of 1 Coulomb charge. Like, see, let's suppose you have a charge over here. This is Q. And there is another charge, Q naught, which is having 1 Coulomb value, which is at infinity. Now, if you are bringing this charge from here to here, you are placing it at r distance. You will have to do some work, and that work will be stored in the form of potential energy. So, that potential energy will be how much? K, Q1 is Q, Q2 is Q naught divided by R. So, U is equal to K, Q. What is the value of Q naught? That is 1, because it is actually a unit charge. This is a unit charge. Unit charge. Okay. Divided by, I would say, R. So, U is equal to KQ divided by R. What is this KQ by R? This is actually the potential energy stored in bringing 1 Coulomb charge from infinity to that point. And this is what we call potential. Sir, potential is also the potential energy. Yes. In bringing how much charge? In bringing 1 Coulomb charge. Electric potential is nothing but potential energy per unit charge. Potential energy of unit charge. Okay. So that is this. KQ divided by R. This is the potential. This is the potential. So from now onwards, if somebody says, sir, if this is a charge at R distance, what is the potential? You say, sir, KQ divided by R. So what is this actually? This is actually the potential energy of how much? Of 1 Coulomb charge, when you have brought 1 Coulomb charge. Now take a look at this particular question. And this potential is a scalar, and potential energy is also a scalar. See, guys, these are the charges. You have to tell me what is the net potential at this point, origin. If I write what is the net potential over here, guys, we say potential due to a charge, it is K cubed by R. R is how much? From here to here, it is 1 plus. Potential due to this charge is K cubed divided by, from here to here, it is 2 plus. Potential due to this third charge is K cubed by 4. From here to here, it is 4. Potential due to this charge is, I would say, K cubed divided by 8, and so on, and so on. Okay. Now, my dear NEET aspirants, what I can say in this particular case, net potential will be, take this KQ common over here, 1 plus 1 divided by 2, then plus 1 divided by 4, plus 1 divided by 8, and so on. Okay. Now, my dear NEET aspirants, what I want you guys to do in this particular case, you have to basically add all of these terms. Then you will get the net. So when you add all of these terms, you say, sir, sum. Sum is equal to A upon 1 minus R. A upon 1 minus R. So A means what? A is the first term. R is the common term. How do you find the common term? Take any term. Let's suppose 1 by 4. Divide it with the term which comes before it, 1 by 2. 2 ones are 2 twos are 4. So it will be 1 by 2. It will be 1 by 2. Now, guys, tell me, when it comes to the sum, A means 1 upon 1 minus 1 by 2. So sum is equal to 1 upon 2 into 1 is 2. 2 minus 1 is 1 divided by 2. Take this in the numerator, it will come out to be 2. So basically, sum of all of this came out to be 2. So when it comes to the net potential, it is KQ. And instead of this sum, I'll write 2. So it is 2KQ. It is 2KQ. Let's talk about this one. Guys, find the net electric field and net potential at the center. Net electric field and net potential at the center. I want you to understand this one. Due to this positive charge, electric field at this point will be away. Electric field is a vector quantity, potential is a scalar quantity. Electric field is a vector. It has both magnitude as well as direction. Potential is scalar. It does not have the direction. Electric field due to this at this point will be away from the charge. Electric field at this charge will be away from the charge at this point. electric field at this will be electric away from the charge. This will be cancelled with this. This will be cancelled with this. So what I can say in this particular case, net electric field is 0. Okay. Okay. And when it comes to the net potential, my dear NEET aspirants, net potential will be simply, guys, if this is Q, what is the potential due to this at center? So it is KQ divided by R. R is the distance from this point to the center. If the side is L, half of the diagonal will be L by root 2. L divided by root 2. And similarly will be the potential of this, same as the potential of this, same as the potential of that. So I would say net potential is 4 times. So this will be 4 under root 2 KQ divided by L. 4 under root 2 KQ divided by L. Okay. 4 under root 2 KQ divided by L. I believe this is crystal and clear. And it does not have the direction, just the magnitude, Okay. And one more important thing I just want to tell you over here. Guys, see, you say, as we know, we say work done is equal to this one. dW is equal to, we have recently studied this delta W is equal to, and W is equal to, that is change in potential energy. Work done by conservative forces, negative of change in potential energy. Yes. Now, my dear NEET aspirants, can I say in this particular case one thing? Small work done will be equals to minus du, small change in potential energy. Yes. Now, I would want you guys to divide Q on both sides. Okay. Now, what I can say in this particular case, dW by Q, dW divided by Q is equal to minus du by Q. Whenever you divide the charge with the potential energy, see. We say, what is potential? Potential is potential energy per unit charge. Potential energy divided by charge. Like, what was the potential energy? K, capital Q, small q divided by R, divided by Q. You check over here. When you took this charge, this Q to here, or you say Q naught, or you say Q, from Q there. So what is the potential energy? K, Q, Q naught, you say Q or Q naught, one and the same thing, divided by R. So here also, my dear NEET aspirants, this and this will be cancelled. It will come out to be KQ divided by R. So potential is simply potential energy divided by charge. You can write it like this also. So this comes out to be dV. This will be dV. Whenever you divide potential energy with charge, it will become potential. Now guys, do one thing. Take this over there or take it here also. So what is force? What is work done? That is F into dr is equal to minus dV divided by Q. Guys, tell me, you have recently studied force is equal to Q times of electric field. Electric field will be F divided by Q. Yes. So put it over here. So electric field into dr will be equals to minus dV. Absolutely. Take it over there. Electric field will be minus dV divided by dr. Minus dV divided by dr. Minus dV divided by dr. So this is the relation between electric field and potential. This is the relation between electric field and potential. This is the relation between electric field and potential. This is the relation between electric field and potential. Okay. Now guys, take a look. Potential due to a hollow and solid sphere. This is hollow one. Okay. So potential due to a hollow sphere. This is first one is the hollow one. Hollow conducting also you say. Hollow sphere. Potential due to a hollow conducting sphere. Now guys see, hollow sphere. I have told you previously, in case of a hollow sphere, we say charge is present on its surface. Charge is stored on its surface. So we have to find potential due to this hollow sphere outside, on the surface and inside. Outside, on the surface, and we say inside. Inside at smaller distance. What is the potential due to this hollow sphere outside? It is kq by small r. Okay. Because from a very large distance, we consider it a point charge. So whatever is the potential due to point charge, same will be due to this, kq by r. On the surface, my dear NEET aspirants, we say value of small r is capital R. So put it over here, capital R, it will become kq by capital R. And inside, here inside, no doubt charge is 0, but potential will not be 0. So potential will be kq by capital R. Right now, I will not be giving you this explanation. Okay, but later on, as of now, you just directly remember this. Okay, kq by capital R. Whatever is this at the center, same will be on the surface. And guys, see, K is constant, Q is constant, R is constant. K is constant, Q is constant, R is constant. So from center to surface, potential is constant. And outside, V is inversely proportional to small. Now see the graph. Graph between potential versus R. It is constant and then this. Because from center to surface, potential is constant. Outside, it is inversely proportional to R. Outside, it is inversely proportional to R. Potential due to a solid sphere. Solid sphere means in which charge is present inside also. If this is a solid sphere, guys, you have to tell me potential outside. You have to tell me potential on the surface. You have to tell me potential inside at small r distance. When it comes to the potential outside potential will be kq divided by small r at a very large distance. On the surface, potential will be kq by capital R. Kq by capital R. Okay. Because on the surface, value of small r is capital R. And when I say at the center, and inside, guys, this you need to remember. Kq upon 2r cube. And then interchange. Take this 3 over here, 2 over there. So 3r square. Kq upon 2r cube. Then 3r square minus small r square. This is the potential inside at r distance. At any point you can find. Now, if somebody says, what is the potential at the center? Guys, if you say, what is the potential at the center? You need to place 0 over here. Okay. You need to place 0 over here. See guys, wait. So you need to place 0 over here. Then remains 3r square. R square and cube will cancel. What remains? 3 by 2 kq by r. This is the potential at center. At center. At center. This is outside. This is on surface. This is inside. This is outside. And if you clearly see, my dear NEET aspirants, outside potential is inversely proportional to R. Okay. 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 Now let's take a look at the graph. Okay. One more important thing. At center, potential is 3 by 2 kq by r. 3 by 2 means 1.5. On the surface, it is kq by r. 1 kq by r. Here it is 1.5 kq by r. So means potential at center is greater than potential on surface. So this is the graph between V versus R. So at center, what is the value of small r at center? What is the value of small r at center? 0. So at center, potential will be maximum. V naught, 3 by 2 kq by r. Then potential will go down. This will be the potential at surface where R is equal to capital R. Small r is capital R. And on the surface, this will be the potential on surface, kq by capital R. This is inside. And when you move outside potential and I would say R is inverse relation. Outside potential and R is inverse relation. That's why we are getting this graph. That's why we are getting this graph. I hope this is crystal and clear. Now there is a question. In this particular question, I would want you guys to tell me, find the potential V net and E net at P and Q due to the given hollow spheres. Very, very good question and very, very important question. Okay, very, very good question and very, very important question. Come on, guys, tell me. Give it a try, guys. Give it a try from your end. Okay, let me just show you, my dear NEET aspirants, this particular question over here. See. Before this, when it comes to the potential due to a hollow sphere, understand this very carefully. Guys, see, this is a hollow sphere. Okay, this is a charge Q. If I say outside, surface, inside. First of all, electric field. Electric field outside is KQ by small r square. Electric field on the surface is KQ divided by capital R square. Electric field inside is 0. When we talk about potential, this is a hollow sphere. Outside potential is KQ divided by small r. Then we say potential on the surface is KQ divided by capital R. Then we say potential inside is, it is also KQ divided by capital R. KQ divided by capital R. Now take a look. My dear NEET aspirants, first of all, let's find potential at P. Let's find potential at Q. Okay. Potential at Q will be, guys, see, for this, these are the concentric hollow cylinders, hollow spheres. Potential due to this at outside point will be simply, that is, first let's write due to the smaller one, K, charge of this is Q, divided by R, small r. From its center to here, what is the distance? That is 2r. This is the value of small r over here. Then plus potential due to the bigger one, it is going to be K. And then I would say 3Q divided by charge of this is 3Q. From here to here, it is 2r. So you can say in this particular case, K, and this is 3KQ by 2r. This is KQ by 2r. 3 plus 1 is 4. 4KQ divided by 2r. Done. When I say potential at point P, this point is outside of this. So outside formula. Outside is KQ, charge is Q. Okay, that is K charge is Q divided by, from its center to that point, what is the distance? Divided by R, then plus. This point is inside of the bigger sphere. We know whatever is the potential on the surface of the bigger sphere, same will be inside. So what is the potential on the surface of this? That is K 3Q divided by its radius. What is the radius of this? That is B. That is B. Array, sir, done and dusted, sir, done and dusted. This will be the potential at point P. And then, my dear NEET aspirants, even if I say one more point, this is point, let's consider this point X. So if I say potential at point X, you will be simply saying potential at point X. This point is inside of this sphere. So whatever is the potential on its surface, same will be inside. So potential on its surface will be KQ, its charge, divided by its radius, that is A, plus whatever is the potential of bigger sphere on the surface, same will be inside. That is K, charge of bigger sphere is 3Q divided by this radius is B. Okay, this radius is B. Okay. This is B. This is B. This is B. And then, my dear NEET aspirants, let's talk about the electric field. Electric field at point Q. This is the outside point of the bigger sphere. So electric field will be KQ by small r square. So Q is this Q, and this first we'll write the electric field of the smaller sphere at outside point, that will be 2r whole square plus what is the electric field due to bigger sphere? That is K, charge is 3Q divided by, from here to here, this will be 2r whole square. So this is 3 times 1, so 3 plus 1 is 4KQ divided by, this will be 4r square. This and this will cancel. It will be KQ divided by r square. This is outside. So if I say, my dear NEET aspirants, what is the potential at this point? Electric field at point P. Guys, due to this smaller sphere, it is outside of this charge, outside of this sphere. So it will be KQ divided by, at what distance it is? R square. Plus, due to the bigger sphere, since due to the bigger sphere, inside electric field will be 0. So this is the net electric field. Even if I say electric field at point X, electric field at this point X, due to this sphere, electric field at point X will be 0. Why? Because it's inside. Due to this sphere, electric field at point X will be 0. So electric field at X will be 0. This is very important. And it's a very good question, I must say. Electric potential due to a ring on its surface. Electric potential due to a ring on its surface. This is a ring. You have to tell me what is the electric potential on its at x distance. Electric potential due to the ring at x distance will be this. Okay, this is a ring. Then you move from here to here. So potential will be KQ upon under root of x square plus r square. X is the distance where you have to find the field, potential, and r is the radius. Now in this particular case, my dear NEET aspirants, if I say very close to the ring, this is the ring. Very close to the ring means this will be r. So in this particular case, x is much less than r. So what is going to be the potential? That is KQ upon under root of x square plus r square. So if x is much less than r, so neglect this x. So it will be under root of r square. This and this will cancel. So it will be KQ divided by r. So this is the potential due to ring at very close distance. If I say very far from the ring, so this is the ring, its radius is r, and at this distance you are finding. In this particular case, r is much less than x. So what is going to be the potential? That is KQ upon under root of, what are you going to neglect in this particular case? R, because r is very small. So you'll be saying x square. This and this will cancel. So V will come out to be KQ by x. A distance in both the cases will be same na, because these are the concentric shells from this same radius, same distance. For the bigger sphere also same center na. If the center is same for both, then we say distance from the center to that point will be the same na. These are the concentric spheres. This sphere, and inside of this there will be another sphere. So at very far distance, potential due to the ring will be kq by x. At very close, it will be kq by r. Even if I say at center, what is the value of x? 0. At center, value of x is 0. So put the value of x 0 over here, then square and root will cancel. So potential will be kq by r. This is at center. This will be very close to the ring. This will be very far from the ring, and this will be at x distance. This will be at x distance. Like you have this particular question over here. You have a charge, you have a ring, its charge is q. You have another ring, its charge is minus q. Okay, its charge is minus q. Okay. Tell me. You are supposed to tell me what is the potential difference between A point and B point. This is the point A of this. This is the point B of this. See guys. See. This ring, this point, this center, this A point is the center of this first ring. B point is the center of second ring. You are supposed to tell me potential difference between A and B. First of all, tell me potential at point A. See. So this point A is the center of this ring, but for this ring, it is at a very large distance. At a very large distance, potential is kq by x. At center, potential is kq by r. These two. So due to this ring, potential at its center will be kq divided by r. R is the radius. And due to this ring, this is at x distance. See, this is x. It will be minus kq divided by x, because charge is minus, that's why minus. Then we say potential at point B. Point B is the center of this ring. So due to its own ring, potential at center will be minus kq divided by r, because charge is negative. Then due to this ring, this point is at x distance, so it will be plus kq divided by x. Then we can say VA minus VB. VA minus VB. Value of VA is this. That is kq divided by r minus kq divided by x. Then we say this minus, formula minus. Then we say this one. We say minus kq divided by r plus kq divided by x. So this will be kq divided by r minus kq divided by x. Minus into minus is plus kq divided by r. Minus into plus is minus kq divided by x. So this will become 2 times na? Kq by r, 2 times kq divided by r, minus kq by s, minus kq by s, minus 2 kq divided by x. This will be 2 kq. This will be 1 divided by r minus 1 divided by x. VA minus VB, VA minus VB, VA minus VB. Is this clear? Is this clear, guys? Okay. Now we have the equipotential surfaces. Equipotential surfaces. We say that surface upon which the potential is same everywhere, that is what we call an equipotential surface. Like see, example I'll give. Let's suppose this is a charge over here. We say at r distance, if you go, what is the potential? Kq by r. Here r distance, Kq by r. Here r distance, Kq by r. Here r distance, Kq by r. Now, if you join these points, it's spherical. This is a point charge. At r distance, Kq by r, 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 Kq by r. Join all these points, okay? It will form a sphere. So for this is going to be the equipotential surface. Equipotential. So that surface upon which potential is same everywhere is called equipotential surface. Like for point charge, draw a sphere around it, that's the equipotential surface. Now if I say what is the potential at this point, potential at this point, you say, sir, same, Kq by r, Kq by r. So what is the potential difference? Kq by r minus Kq by r. So it will be 0. So potential difference on an equipotential surface is 0. This is also Kq by r. This is also Kq by r. So Kq by r minus Kq by r is 0. Yes. Okay. This is a point charge. These are the equipotential surfaces drawn. This is the electric field. Could you please tell me what is the angle between electric field and equipotential surface? 90. What is the electric field and equipotential surface angle over here? 90. So electric field is perpendicular to equipotential surface at all the points. At all the points, electric field is making 90 degree with the equipotential surfaces. No work is done by the electric force in moving a charge on equipotential surface. No work is done in moving the charge on equipotential surface. See guys, let's suppose we say work done is equal to, if you remember, work done is equal to delta U. Okay. Or minus delta U. So you say divide by charge, divided by charge. So work done divided by charge will become minus delta V, because potential energy divided by charge is potential difference. So take it over there. W is equal to minus Q delta V. Now tell me, on equipotential surface, potential energy is, potential difference is 0. Delta V is 0. So if this is 0, so work done will be how much? 0. That's what I'm saying. No work is done by electric force in moving a charge on equipotential surface. If you move the charge on equipotential surface from one point to another, we say no work is done in that particular case. So this was asked in NEET 2022, by the way. This point directly. So with this, we are done with the first chapter. Now we are starting the second chapter. That is, it took us a bit more time because this is a big chapter, bro. It's a big chapter, huh? Okay, let's move on to the capacitors. Now, my dear NEET aspirants, what is a capacitor? What is a capacitor? We say capacitor is actually a device which is used to store electrical energy. Capacitor is a device which is used to store electrical energy. As simple as that. Like, or electric charge, you can say. See guys, why do we use capacitors? Let's suppose you have a television at your home. You want to run this, you want to start this television. It is not possible that you will directly send a supply to this television and it will start working. No, it is not possible. So basically what you are supposed to do is that it is not possible to send a large amount of energy through this wire. So you connect a device over here, capacitor. So capacitor stores the energy. So when, my dear NEET aspirants, this energy is required, at that point of time, we say in the starting, this capacitor sends the energy and this television starts working. Directly you remember, capacitor is a device which stores electrical energy or electric charge. Like the first capacitor I'm taking over here, this is a spherical capacitor. Okay, like you have a bucket. What is bucket? Bucket is used to store water. Similarly, capacitor is used to store charge. Now you are developing, you are storing charge Q on it. We know when charge Q is developed. This is the spherical capacitor, means sphere, hollow sphere, you can kind of say. And you are storing Q charge on this. How much potential is developed over here? V is the potential developed in this particular case. The radius is R. Now, my dear NEET aspirants, I can say this Q is directly proportional to V. More is the charge stored, more will be the potential array. Recently you studied, na? What is potential? That is KQ divided by R. Charge is more, potential is more. Okay, yes. Now replace this with a constant, that is C. So we say Q is equal to C into V, where C is the constant, and this C is called the capacitance of a capacitor and is called capacitance of a capacitor. It is called capacitance of a capacitor. Okay. Capacitance of the capacitor means ability to store the charge, capability to store the charge. Okay. Some capacitors may have small capacitance. Some capacitors may have large capacitance. Like if I say, sir, this will have less capacitance, this will have large capacitance. So means this will store less charge, this will store more charge. As simple as that. Then we say capacitance of a spherical capacitor. Spherical capacitor has got capacitance C is equal to 4 pi epsilon naught into R. See, this only depends upon the dimensions, that is radius. And this epsilon, medium. So this is the capacitance of a spherical capacitor. As simple as that. As simple as that. Now there is a famous question which is asked in this one. You have got n number of small capacitors, n small capacitors, okay? And these small capacitors have got charge small q, potential V, capacitance C, radius small r. They are combined together by any means, by melting, whatever it is, okay? Or you can, in some questions, it will be mentioned drops, n small drops are combined. So n small capacitors are combined to form a one big capacitor, which has got radius capital R, voltage potential V, capacitance C dash, and this charge Q. You have to tell me the value of C, C dash, V dash, R dash, Q. So means if n small capacitors are combined to form a one big capacitor, what is the charge of big capacitor? Directly remember, I'll not be deriving. In the regular classes, I derive it. Here, I'll not be deriving. So it will be n times of Q. N. If I say, sir, 9 small capacitors, so 9Q, where Q is the charge of small capacitor. R, radius of big capacitor will be n raised power 1 by 3 times of R. C dash is n raised power 1 by 3 of C. Okay. V dash is n raised power 2 by 3 of V. V is the voltage or potential of small capacitor. C is the capacitance of small capacitor. R is the radius of small capacitor. Like there is a question which was asked in NEET 2021 from this one. 27 small drops of same size. This drop, this drop, this drop, this drop. So value of n is 27. Value of n is 27. At 220 volts means voltage of these is given. It's not charge, is voltage 220 volts. They combine to form a big drop. They combine to form a big drop. You have to tell me what is the potential of the big drop. V dash. Just one liner if you remember the concept. V dash is equal to n raised power 2 by 3 into V. So we'll be saying, sir, this V dash will be n raised power 2 by 3 into V. V is the potential of small capacitor. So V dash will be n. What is the value of n? That is 27 raised power 2 by 3 into V. V is 220. Now, my dear NEET aspirants, what you can write over here, this V dash will be simply 27 is 3 into 3 into 3. That is 3 cube. Whole raised power 2 by 3 into 220. 3 and 3 will cancel. 3 square is 9. 9 into 220, 1980 is the answer. Even you can find the capacitance of the big capacitor also. C dash is equal to, how do you find the capacitance of the big capacitor? N raised power 1 by 3. N raised power 1 by 3 into C. N is how much? 27 raised power 1 by 3 into C. 27 means 3 cube into 1 by 3C. 3 and 3 will cancel, so it will be 3C. Parallel plate capacitor, my dear NEET aspirants. Parallel plate capacitor. So that was the spherical capacitor. Let's talk about parallel plate capacitor. Parallel plate capacitor is nothing but there are different types of capacitors. So that capacitor, spherical capacitor, was not very good because charge leakage was very common in that capacitor. That's why. So this is a parallel plate capacitor. So here it has got one plate, it has got another plate. In case of parallel plate capacitors, you have got two parallel plates. Area of this is A, separation between the two is D. Okay? And this is the battery connected to this. This is the battery connected to this. So basically, this is what we call the positive terminal of the battery. This bigger one. This is called a negative terminal. So this positive terminal stores positive charge on this. This negative terminal stores negative charge on this. Directly remember. If positive terminal is connected to this, so positive charge will be on this, negative charge will be on this. And electric field will be always from positive to negative. Why? Because I have told you, in case of positive charge, electric field is away. In case of negative charge, electric field is towards. So overall electric field is from positive to negative. Positive to negative. So here electric field is developed from positive to negative. Something like this. And if somebody says, what is the capacitance of this capacitor? Capacitance, capacity, you'll be saying, sir, that is epsilon naught A by D. A is the area, D is the separation between the two. This is the capacitance. See the question of NEET 2022, what was asked in this. See, find the capacitance of a capacitor if the area of the plates is A by 2 and separation is 2D. See guys. You have got a parallel plate capacitor over here. Area is A, separation is D. Its capacitance will be epsilon naught A by D. Then it says what is happening with this capacitor is, it says area of the plates becomes A by 2. And this separation becomes 2D. What is the new capacitance? New capacitance C dash will be epsilon naught. Instead of A, I can write A by 2. Instead of D, I can write 2D. So this will be epsilon naught A upon, this will be 4D. Epsilon naught A by D, that is C. So new capacitance will be C by 4. Now guys, see. What is the use of capacitor? To store charge. To store charge means to store energy. Absolutely, sir. So this capacitor stores the energy. Listen to me very carefully. Charge Q is stored. So how much will be the energy stored in this capacitor? You simply say it is Q square by 2C. Okay. Q square by 2C. So this is the, see, C is the capacitance and Q is the charge stored in the capacitor. This is the energy stored in the capacitor in terms of charge and capacitance. If somebody says in terms of voltage and capacitance, 1 by 2 CV square. This in terms of potential difference and capacitance. We say U is equal to 1 by 2 Q into V. This is in terms of charge and voltage. In terms of charge and voltage. As simple as that. So this is the energy in terms of charge and capacitance, in terms of capacitance and voltage, in terms of charge and voltage. Okay. This is the energy stored. Like you have the question over here. Guys, see. The question in this particular case is a capacitor of capacitance 700 picofarad. This capacitance is 700 picofarad. And we measure the capacitance in farad. So if you have to convert this to the farad, you multiply with 700 into 10 raised power minus 12. It will become farad. You multiply with 10 raised power minus 12. So 1 picofarad. How many farad? 10 raised power minus 12. Then, my dear NEET aspirants, if you have to, and is charged with a 100 volt battery. Battery has got the potential of 100 volts. It is like, this is the capacitor. Its capacitance is given. It is charged with a 100 volt battery. This battery has got 100 volt potential. It is charging this capacitor. So I can say energy will be, which of the three formulas you will prefer over here? So if capacitance and voltage is given, I'll prefer second one. So you'll be saying 1 divided by 2 CV square. So U is equal to 1 divided by 2. C is 700 into 10 raised power minus 12 into V square is 100 whole square. Okay. Okay. So solve the 700 divided by 2 is 350. This is 10 raised power 4. It will come out to be this. It will come out to be this. Next. Force between the plates of a capacitor. 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 Is this clear till over here? Tell me guys quickly in the chats. Tell me. Now guys, yes, I'll give you the break after some time. Wait. You have got two plates over here. Okay, this is the first plate. Charge on this plate is, let's suppose positive charge is placed on this plate. It is because of the battery. Battery has stored positive charge on this due to the positive terminal. Negative charge is placed on this plate. Now, don't you think that this positively charged plate and negatively charged plate will attract each other? Yes, sir, they will attract each other with a force. And that force is what we call the force between the plates of a capacitor. Two plates attract each other because of the opposite charge. And that force, my dear friends, will be simply F is equal to Q square divided by 2A epsilon naught. This is in terms of charge. In terms of sigma, you can also write. In terms of charge density, because here it will be sigma into A square, sigma square into A. Sigma is the charge per unit area. A is the area divided by 2 epsilon naught. This will be in terms of charge. This will be in terms of sigma. Okay. The question is, the electrostatic force between the metal plates of an isolated parallel plate capacitor having charge Q and area A. The charge on the plates is Q, area is A. What is the force between the two plates? Q square upon 2A epsilon naught. Yes. Now, this is the formula that you are supposed to write. You cannot write something else. So in this particular case, does it depend upon the distance? No, it does not. It is independent of the distance between the plates. It does not depend upon the separation between the plates, na? This expression. Okay, one more important thing if I just derive over here. Since you have got force between the two plates, force is acting on this plate, it has area, so pressure will be created. So pressure on the plates. Pressure on the plates. So you say pressure is simply force per unit area. So pressure will be, what is force? Sigma square A divided by 2 epsilon naught. Sigma square A divided by 2 epsilon naught. If somebody says, where does this come from? Guys, you say simply sigma is equal to Q divided by A. So Q is equal to sigma into A. Just put it over here, you will get this expression. So this will be divided by this area A. A and A will cancel. So pressure will come out to be sigma square divided by 2 epsilon naught. This pressure. Now, whatever are the dimensions of the pressure, same will be the dimensions of energy density. Same expression is used for energy density. Energy density. Energy density means energy per unit volume. Guys, see. If I say this is a cylinder, how much is the energy stored in the cylinder? Sir, 10 joules. Okay, or we say E. How much is the energy in the unit volume? That is energy divided by volume. Okay, total energy and energy per unit volume is a different concepts. So we say that is energy per unit volume is equal to same expression, sigma square by 2 epsilon. Now take it over there. This energy will again come out to be, okay, this will be energy. What is energy? U divided by A into L. Okay, A into D. Don't write A into L, A into D. What is area of this capacitor? What is the volume of this capacitor? Area multiplied by separation. Separation is D. So into D is equal to sigma square divided by 2 epsilon naught. Take it over there. U will be equals to sigma square divided by 2 epsilon naught A into D. Sigma square divided by 2 epsilon naught A into D. Okay. This is done. And this is, by the way, guys, this is total energy. This is the energy density. This is energy density. This is energy density. Energy density. Or we say energy per unit volume. This is total energy because I'm taking the volume over here now. Total energy. So these three expressions are also the total energy. In terms of charge and capacitance, capacitance and voltage, charge and voltage. This is the total energy in terms of sigma, area and distance between the plates. Okay, yes. Now guys, take a look in this particular case. Common potential. You will be given 3 capacitors. Okay. Now take a look. One thing I just want to mention over here, my dear NEET aspirants, listen carefully. Let's suppose there's a battery over here. There's a battery over here. Okay, there's a battery over here. Let me show you here. There's a battery over here. Okay. This battery, my dear NEET aspirants, let's suppose it has got potential difference of 20 volts. This is the symbol of battery. Directly remember. This is potential difference, delta V. This is one end of the battery. This is A. This is another end of the battery. This is B. Always remember the point which is connected to higher potential. This is what we call higher potential. This is called lower potential. Higher potential. And this is what we call lower potential. This will be higher potential. First of all, this is the symbol of the battery. This bigger one is what we call higher potential. This is what we call lower potential. Okay. Now, my dear NEET aspirants, always remember this higher potential minus this lower potential is always equal to this potential difference, delta V. Or you can say delta V is higher potential minus lower potential, or positive terminal minus negative terminal. Okay. So, this one. Let's suppose, my dear NEET aspirants, if I say you have got a battery over here. This has got 20 volts potential difference. This potential of VB is given as 0. You are supposed to tell me what is the potential of this end. Because this end is connected to this, it will be at higher potential. You'll be saying, sir, higher potential minus lower potential is equal to delta V. So higher potential is VA minus lower potential is 0. Delta V is 20. So VA will come out to be equal to 20. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Like if you have this question. If you have this question. This is 40 volts. This will be over here 20 volts. What will be the value of this VA? You say, sir, this VA, higher potential minus lower is 20, is equal to V delta V, that is 40. Take it over there. VA will be equals to 40. Take it over there. 40 plus 20 is 60 volts. 60 volts. Common potential. See, you have got multiple capacitors connected over here. C1, C2, C3. Its one end has got potential V2. Its one end has got potential V3. Its one end has got potential V1. This is what we call the common point of all the three. This has this. If somebody says what is the potential of this common point, or this is what we call midpoint potential. You say simply C1 V1, C2 V2, C3 V3 upon C1 plus C2 plus C3. This is what we call the common potential, my dear. This is what we call the common potential. This is what we call the common potential. This is what we call the common potential. That is V mid. Okay. See, find the charge in each capacitor. My dear NEET aspirants, one formula I would want you to remember that I told you in the starting itself. That is this. Q is equal to C into V. This will help us to find the charge in a capacitor. It is actually Q is equal to C delta V. Delta V is the potential difference, my dear NEET aspirants. Now, let's use this formula only to find the charge in the capacitor. Take a look at this particular question. Take a look at this particular question. See, boys and girls. See, boys and girls. First and the foremost thing, whenever you see the question of this sort, I'll be showing you these pattern of questions in the current electricity also. Assume the potential at 0. Let potential at 0 at this point be 0. Assume the potential at any point 0. Sir, at which point? This I'll tell you. Right now, assume at this point. As we move on to the different number of questions, you will get to understand at which point you guys are supposed to assume the potential as 0. At this point, assume 0. If I say potential at this point is 0, this is 20 volts. What will be the potential of this point? And this is connected to higher potential. You say, sir, this VA minus this VB must be equal to 20. So VA is 20. Array, sir, this is 20 volts. Now see, sir, potential of this is 0. This is 10. What will be the potential of this point? You say, sir, potential of this point, this is higher potential. So this is VA minus lower potential is 0. Must be equal to how much? 10. So this is, sir, I would say this is plus 10 volts. Amazing, sir. Okay. You can, the link will be mentioned over here. Study Cephere 2004. The link will be mentioned over here, na? Okay. It will be in the chats, or you can see in the comments also. You can go to the link, you can click onto that link, or it will be in the description also. You can click onto that link and you will land onto the page. Unacademy's subscription page. Okay, there you can buy the Unacademy subscription. There you will get the personal mentorship program. Okay. Now, guys, so this is 10. Now, this is a simple wire going till over here. This will be also having 10-volt potential. Sir, does it mean what you are trying to say is that if the wire is not having any sort of load in between, the potential will remain the same? Absolutely. Here it is 20, here also it will be 20. Sir, can I say here also it will be 20? No. Why? Because capacitor came in between. If this is the wire only, you can say potential remains the same. Now, guys, so basically you have to find the charge in 4 microfarad. Before finding the charge, I'll show you something what you are supposed to do. Find the potential of this point. For this point you got. For this point you got. This point, this point. Now find the potential of this point. So redraw. A redraw. When you redraw it, this is the capacitor. This is the capacitor. This is the capacitor. Okay. This has got plus 20 volts potential. This has got plus 10 volts potential. This has got 0 volts potential. And this is the potential VA you are supposed to find. Don't you think that I'll have to use this common potential C1 V1 C2 V2 C3 V3 upon C1 plus C2 plus C3? Absolutely, sir. Now see, this potential, this is C1 V1 and this is 5 microfarad. This is 4. This is 1. Now find potential of A. C1 V1, that is 5 into 20, plus C2 V2, that is 4 into 10, upon C3 V3, that is 1 into 0, plus 1 into 0, upon C1 plus C2 plus C3, 5 plus 4 plus 1, 4 plus 1. Now this is 100 plus 40 divided by 10. That is 140 divided by 10. That will be 14 volts. So potential of this point came out to be 14 volts. Potential of this point came out to be 14 volts. Okay, potential of this point came out to be 14 volts. Now, my dear NEET aspirants, what I'm trying to say in this particular case over here, if you got the potential of this point as 14 volts, so whenever you see the question of this sort, first figure out the potential of every point we got. Now, in which capacitor you want me to find the charge? This, whatever, bro, I'll find in all. Let's find in 4 microfarad. Charge in 4 microfarad. So this is 4 microfarad. Potential of this is 14. Potential of this is 10 and this is 4 microfarad capacitor. If I say charge is Q is equal to C delta V. Q is equal to C. C is 4 microfarad. Delta V. Delta V is potential difference. That means higher potential minus lower potential. That is 14 minus 10. That is 4. 4 into 4 is 16. So it is 16 microcoulomb. So basically, sir, you have to first find out the potential. Then you can find the charge. Absolutely. Okay, let's find charge in this one. 5. This is 5 microfarad. Okay. This is 20 volts. This is 14 volts because potential of this will be how much? 14. So what I can say in this particular case, Q will be C delta V. C is 5 and delta V is higher minus lower. Right now 20 is higher. 20 minus 14. It is 6. 6 into 5 is 30 microcoulomb. So for this also you can calculate C delta V. Same. Guys, tell me in the chats if this is clear. Tell me in the chats if this is clear. Come on, quick. Tell me. Quick. Is this clear? Oh, tell me in the chats. Okay. Now take a look. Capacitors with dielectrics. Capacitors with dielectrics. Now, my dear NEET aspirants, listen to me very carefully. Capacitors with dielectrics. This is a capacitor. This is a positive plate and this is a negative plate. Okay. Now, what you are doing is that you are placing a dielectric. Okay. First of all, you tell me one thing. If you have a capacitor over here, this is positive plate. This is negative plate. Don't you think that these two plates are going to attract each other? Yes, these two plates are going to attract each other. Yes. So if the two plates are going to attract in this particular case, my dear NEET aspirants, if the two plates are going to attract in this particular case, my dear NEET aspirants. So what I can say over here, we say the distance between the two will be, they will stick to each other. There will no longer be the distance between the two. So in order to overcome this problem, the capacitor should not stick to each other, because when we define parallel plate capacitor, epsilon naught A by D, separation must be there. If separation is not there, my dear NEET aspirants, then you cannot say this is a capacitor anymore. So in order to overcome this problem that the two plates must not stick to each other, we place a material in between the two that is called dielectric. Dielectric, like you have conductors, insulators, similarly dielectric is a material you are placing in between the two. Now see, what happens in this particular case, when you place this dielectric in between the capacitor, dielectric has got positive as well as negative charge inside. This positive plate of the capacitor will attract the negative plate of the dielectric, will attract the negative charge of the dielectric, negative of the dielectric. And this negative plate will attract the positive charge of the dielectric. So after some time, negative charge will occupy onto this wall of the dielectric. Positive charge will occupy onto this wall of the dielectric. This is what we call induced charge. This is what we call induced charge. And this is what we represent with Qi. And this Q is the charge on the plates. Qi is the charge on the dielectric. Okay. So my dear NEET aspirants, in this particular case, what we do actually, we say charge induced will be, that is Q into 1 minus 1 divided by K. Qi is equal to Q into 1 minus 1 divided by K. Okay. This is what we call the charge induced. And K is the dielectric constant. And we say, if somebody says, what is the sigma I? That is charge density. How much is the charge density over here? Density of the charge over here, charge per unit area. That is sigma into 1 minus 1 by K. Both were asked in JEE Mains 2021. So this is the charge induced on the walls of the dielectric, 1 minus 1 by K. K is the dielectric constant. Every dielectric will have the dielectric constant. Like for this, it is K. So this is the in charge density. Okay. So this is induced charge density on the walls of dielectric. on the walls of dielectric. Okay? Yes. Absolutely. Absolutely. Okay. Now, guys, let's take a break. Huh? We'll take a break. So, break is still. It is 4:30 almost. We'll take 20 minutes break. Huh? Break till 4:50. Check. Okay, guys, come on. Now, guys, see. Understand one thing very carefully. Very carefully. What is that? That is, let's suppose, my dear NEET aspirants, if I say, you have got, a capacitor over here. This is a capacitor. Okay, these are the two plates of the capacitor. And separation between the two plates is D. And you are filling this gap with a dielectric. And dielectric also has got the same width D. And it has dielectric constant K. Sir, what will happen to the capacitance? Always remember, capacitance becomes K times of C. C dash becomes K times of C. So whenever we fill the dielectric with the capacitor, whenever we fill the capacitor with dielectric, okay, we say capacitance becomes K times of C. So dielectric constant times the capacitance before it was filled with the dielectric. Like, let's suppose if the dielectric is not filled between the plates, what is the capacitance? C. So C is the capacitance of the capacitor without dielectric. C dash is the capacitance of the capacitor with dielectric. So this is the capacitance when the dielectric is filled in the entire width. Now take a look. These are the two plates over here, positive plate and negative plate. And in this particular case, my dear NEET aspirants, you are filling this with a dielectric which has a dielectric constant K, width is T. And gap between the two plates is D. If somebody says, what is going to be the capacitance in this particular case? This will be the capacitance in this particular case. That is epsilon naught A upon D minus T plus T by K. D is this width, T is the width of dielectric, K is the dielectric constant. This is the capacitance of the parallel plate capacitor after placing the dielectric. But here dielectric is not in the entire width. Here dielectric is in the entire width. Keep this thing in your mind. And if, my dear NEET aspirants, listen to me very carefully. If you have got multiple dielectrics filled between the plates, like this is K1, K2, K3, K4. D1 is the width of this, D2 is the width of this, D3 is the width of this, D4 is the width of this. And in this, and area of the plates is A. If somebody says, what is going to be the capacitance over here? Epsilon naught A upon D1 by K1. This D1 by K1, D2 by K2, D3 by K3, D4 by K4. This is going to be the capacitance in this particular case. Okay, this is going to be the capacitance in this particular case. Now, my dear NEET aspirants, take a look over here. This is the question which was asked in JEE Mains 2021. It says that you have to tell me what is the capacitance of this capacitor? Dielectric constant K, 3K, 5K, D, 2D, 3D. How do we find the capacitance? C dash is equal to epsilon naught A upon D1 by K1. See, D1 by K1, D2 by K2, D3 by K3, D4 by K4. So D1 by K1, D1 is D divided by K1 is K. D2 by K2, that is plus 2D divided by 3K, then plus 3D divided by 5K, 3D divided by 5K. Okay. So what you can do in this particular case, epsilon naught A, and you can take common over here, D divided by K. What remains? 1 plus 2 by 3 plus 3 divided by 5. This will remain. Now do the cross in this particular case, epsilon naught A upon. This will come out to be D divided by K. Okay. This will be 34 divided by 50. If you solve this, it will be 34 by 50. Now take this in the numerator. It will be 15K will go in the numerator. Epsilon naught A upon 34D. I think this is the correct option. Let's take a look at this. See guys, let me show you this. Let me show you this. So you have a plate, you have the two plates. You have the two plates. And a capacitor, this capacitor is filled with a dielectric, but dielectric right now is conductor. We are replacing dielectric with a conductor. And for conductor, we say value of K, dielectric constant of conductor is infinity. Keep that thing in your mind. Now, what is the formula that we can use? Sir, this is the formula we studied recently. Epsilon naught A upon D minus T plus T by K. So you'll be like, this is epsilon naught A upon D minus T plus T divided by infinity. Instead of K, you'll be putting infinity. So anything by infinity, this will be 0. So epsilon naught, this will be epsilon naught A upon D minus T. This will be basically the dielectric constant. This will be the capacitance of this capacitor. Okay. Now guys, this is what we also call the series combination of dielectrics. Your dielectrics are placed in series and equivalent capacitance will be this. Equivalent capacitance will be this. If somebody asks you. Okay. If somebody asks you, equivalent capacitance will be this. Now, my dear NEET aspirants, even if we say also equivalent dielectric constant, directly remember guys, see, like you have series combination of cells, parallel combination of cells. In that particular case, you find, sir, equivalent EMF or equivalent resistance, net resistance. Similarly, if you have multiple dielectrics in series, this has got dielectric constant K1, K2, K3, K4. How to find equivalent dielectric constant? This is the capacitance, not capacitance, equivalent dielectric constant. Means if you want to replace all of these with one dielectric, what that would be? That would be D upon, I would say D1 divided by K1 plus D2 divided by K2 plus D3 divided by K3 plus D4 divided by K4. Keep this thing in your mind. This is going to be the equivalent dielectric constant in that particular case. Equivalent dielectric constant in that particular case. Okay. If the dielectrics are placed in parallel, these dielectrics are placed in parallel. How do we find? Guys, this is the positive plate. This is the positive plate. And this one is negative plate. This one is negative plate. Now here dielectrics are placed in parallel. This has K1, K2, K3 dielectric constant. This width is A1, this width is A2, this width is A3, and this width is D. This width is D. What you are supposed to find out in this particular case is capacitance. Epsilon naught by D, A1, K1 plus A2, K2 plus A3, K3. This is going to be the capacitance of this capacitor when dielectrics are placed in parallel. Okay. And in this particular case, if you want to find the equivalent dielectric constant, also K equivalent. That is, if you want to replace these dielectrics with just one dielectric, you'll be mentioning that is A1 K1 plus A2 K2, then plus A3 K3, then I would say upon A. A is the area of the plates. A is the area of the plates. This is the equivalent dielectric constant in this particular case. I hope this is also crystal and clear. Like this, the question you have to find the C equivalent. Guys, see, this is air. Always remember, for air, dielectric constant we consider 1. Dielectric constant we consider 1. So if you have to find the capacitance C dash, net capacitance, how do you find the capacitance when the dielectrics are placed in parallel? Epsilon naught by D, A1, K1, A2, K2, A3, K3. Will be like epsilon naught divided by D, then A1 K1 plus A2 K2. Okay, because since there are two dielectrics only, so this is going to be epsilon naught divided by D, A1 K1 A1 is A by 2 and K1 is 1. This K1 is 1. Then plus A2 is A by 2 and then this K2 is K. So this is going to be in this particular case. Here A by 2 is common, epsilon naught A divided by D, then it remains 1 plus K. 1 plus K. Okay, A divided by 2 also. Okay, sir, it is not matching. See, it will match. What is epsilon naught by D? This is the capacitance C. Before placing the dielectric, what is the capacitance? C. Then we say divided by 2, epsilon naught A by D is C, then divided by 2, 1 plus K. Now it would be matching. Series combination of capacitors. When capacitors are connected in series, like these are the capacitors connected in series. If you have to find the equivalent capacitance in this particular case, always remember, my dear NEET aspirants, whenever you have to find the equivalent capacitance, in case of series combination, so you'll be mentioning 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Something like this. Okay. 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3 and so on. Okay. If you have for two capacitors, so it will be like 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Do the cross. So 1 by C equivalent you can write simply, that is C1 plus C2 upon C1 into C2. Now do the reciprocal. So C equivalent in this particular case will be C1 C2 upon C1 plus C2. In case of parallel combination of capacitors, if you have to find the net capacitance, these are the capacitors connected in parallel. If you have to find the net capacitance, it will be simply C1 plus C2 plus C3 and so on. See, this question is important over here. Find the equivalent capacitance in this particular case. If this is C1 is C, C2 is also C, C3 is also C. Guys, first and the foremost thing, whenever it looks like it is in series, but it is not in series. What is the potential of this point? It is B. What will be the potential of this point? That will be also same B. Okay. Same potential B, even same potential till over here B. Because I told you, until and unless load does not come in between, potential remains the same. So whatever is the potential here, same will be the potential here. Same will be the potential here, same will be the potential here, same will be the potential here. Whatever is the potential here, this is A, this is A, this is A. So this will be also A. Now, if you check in this particular case, all the capacitors are connected between A and B. All the capacitors are connected between A and B. This one is connected between A and B. This one also, this one also. So I am making the first one connected between A and B, second one connected between A and B, third one connected between A and B, C and C. This is between A and B, B and A and B. So C, 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 they are in parallel. And in parallel combination, how do you find equivalent capacitance? C1 plus C2 plus C3, that is 3C. That is 3C. Okay. Like this one, guys. NEET 2021. NEET 2021. Find the equivalent capacitance of the system. See, guys. If I say, let's suppose potential of this point is A, this point would be also A. If I say, let's suppose this potential of this point is B, this would be also B. Even here also it would be B. Even here also it is going to be B. Now, whenever you see the potential across the load is same, no potential difference, so it will be short circuited. So it is short circuit. Short circuit means you are supposed to remove this from the circuit. When you remove this from the circuit, we can say this capacitor will remain. This capacitor will remain. This is C and this is C. Okay. Now in this particular case, when it comes to C equivalent, that is going to be 2C. C equivalent in this case is going to be 2C because C plus C is 2C. Because here we say potential between these 2 points is same. That's fine. So we are done with the capacitors also, my dear NEET aspirants. Let's now move on to the current electricity. We have chapter 3rd, that is current electricity. That is current electricity. Okay. Now guys, see. In the chapter current electricity, what does current actually mean? In the chapter current electricity, what does current actually mean? Current simply means flow of charge. Current simply means flow of charge. Like if you have a conductor over here, okay? In this conductor, these are the free electrons which are moving in a unified direction, in a proper direction, not randomly, in a proper direction, in a proper direction. We say current is being produced. Whenever electrons flow, whenever charge flow, current will be produced. And that current will be how much? We say current upon charge upon time. Current is simply charge upon time. Okay. Then we define average current. Average current means delta Q by delta T, total charge flown upon total time taken. Simply, if I say, this is a conductor. In this conductor, electrons were flowing from 9 a.m. to, we say 1 p.m. So in this duration, if I say what is the current produced or what is the charge flown or how much is the current flown, that is what we call average current. What is the current flown from 9 a.m. to 1 p.m. in general in this duration? If I say when the time was exactly 10:30, at this time exactly, how much was the current flown? How much is the current flown? That is what we call instantaneous current. Current flown at a particular time, at a particular instant, that is called instantaneous current. Between this time and this time in an interval, that is called average current. It is Q2 minus Q1 upon T2 minus T1. Instantaneous current will be simply dQ by dt, differentiation of charge with respect to time. Okay. And SI unit of this is, we say ampere. We measure the current in ampere. Now see. Let's suppose for simple question, basic question. Q is equal to 2t square minus 3t plus 1. Find the current at t is equal to 2 seconds. When it says at means at this particular time, means instantaneous current. So you say instantaneous current is simply dQ by dt. Differentiation of this. Now tell me, what is the differentiation of this? 2 into 2 is 4t. Differentiation of 2t square is 4t. Minus 3, this will be 3. What is the differentiation of 3t? That is 3. Now this is the current. We say at t is equal to 2 seconds. We have to find the current. Current will be 4 into, put the value of t is equal to 2 minus 3. 4 into 2 is 8 minus 3 is 5 ampere. So this is the current at t is equal to 2 seconds. Find the charge flown from 0 to 2 seconds. See guys, if I say current is dQ divided by dt. Now take it over here. dQ will be simply integration of I dt. So integrate both sides. You will get Q is equal to integration of I dt. So this equation you will be using from now onwards when charge is given and you are supposed to find, when current is given, you are supposed to find charge. Current is given, you have to find charge. So Q is equal to integration of, what is the current? That is 4 plus 2t dt. In what time you have to find this current? Find charge 0 to 2 seconds. Put 0 here, put 2 here. So charge will come out to be, what is the integration of 4? It is going to be 4t plus. What is the integration of 2t? It is going to be 2t square divided by 2. From 0 to 2. From 0 to 2. Now guys, this 2 and 2 will cancel. Now in this t, you will be putting the upper limit first. 4 into 2 minus 0. Upper limit minus lower limit. Then here also, in this t, you will be putting upper limit plus, that is 2 square minus 0. Now tell me guys, 4 into 2 is 8 plus 2 square is 4. 8 plus 4 is 12. So this is 12. 12 Coulomb charge has been flown. 12 Coulomb charge has flown. Let's suppose, my dear friends, this is the current. And you are supposed to find, given the current flowing in a conductor is this, you are supposed to find average current. Now current is given, you are supposed to find average current. In this case, you'll be using this. Directly remember. Integration of I dt upon integration of dt. So you'll be simply saying average current in this particular case will be integration of I dt. I is t plus 1 dt upon integration of dt. From 0 to 2 seconds. From 0 to 2 seconds. So I am showing you all the varieties over here. If current is given, you are supposed to find average current. You will be using this. Now tell me, what is the integration of t? It is going to be t square divided by 2 plus. What is the integration of 1? That will be t. Limits are from 0 to 2. What is the integration of this dt? It is going to be t from 0 to 2. Now in this t, you will be first putting the upper limit. That is 2 square divided by 2. 2 square minus, then lower limit is 0. 0 will not mention. T is 2 square minus 0 is 2 square only. Then plus, in this you will be putting upper limit, that is 2 upon. Here also you will be putting upper limit 2 minus 0. So this will become 4 by 2 is 2. 2 plus 2 is 4 divided by 2. It will come out to be 2 ampere. So what did I tell you as of now? Directly remember. If charge is given, you have to find the instantaneous current. You will be using dq by dt. Differentiation. If charge is given, you are supposed to find average current. You will be using delta q by delta t. If current is given, you are supposed to find average current. You are supposed to use integration I dt upon integration dt. If current is given, you are supposed to find charge. You will be using q is equal to integration of I dt. These are the 4 equations which I wanted to tell. Drift velocity. Take a look at drift velocity. What does drift velocity actually mean? It is the velocity due to which free electrons are drifted towards the positive terminal. See guys. This is the conductor over here. Conductor has got large number of free electrons. Remember this. Conductor has got large number of free electrons. Okay. Now when you connect the battery to this conductor, this is the positive terminal, this is the negative terminal of the battery. I told you previously, positive terminal will send the positive charge on this side. Negative terminal will send negative charge on this side. So electric field is set up from positive to negative. Electric field is set up from positive to negative. Now, inside in this conductor, electric field is set up. So inside this conductor, you have electrons. These electrons will actually experience the force in the opposite direction of electric field. They will experience the force in the opposite direction of electric field. Now they will start moving in a proper direction, in a uniform direction. So they will gain some speed. That speed is called drift speed or drift velocity. That velocity with which electrons flow in a proper direction, that is what we call drift velocity. And drift velocity is equal to E by m into tau. E is the charge on an electron. This capital E is the electric field developed. M is the mass of this particle, electron. Tau is the relaxation time. You consider a time. It is basically the average time between the two successive collisions. Here we say basically particles do not move in a proper direction. They move in a zigzag path. Overall resultant motion will be the straight line motion. So they basically keep on colliding. So time between two successive collisions is, we say, relaxation time. This is the drift velocity. We'll get the answer of all the questions by using this. Now see, relation between drift velocity and current. See, you have got a conductor over here. You are connecting a battery. This positive terminal, this negative terminal. So positive charge will be occupied here. Negative charge will be occupied over here. Electric field will be set up. These electrons will experience force. So they start moving towards positive terminal. So drift velocity will be there. So if they are moving with the drift velocity, my dear NEET aspirants, so they are moving. So we say current is being produced. When electrons flow flow of electrons is current. Current is being produced. And if the direction of electron is this, if the direction of negative charge is this, the current will flow in the opposite direction. Always remember this. If the direction of positive charge is this, so direction of current is going to be the same. So in this particular case, we say here electrons are being drifted due to the drift velocity. So current is being produced. So there, if electrons are being drifted due to drift velocity, so current will be produced. So there must be the relation between current and drift velocity. We say I is equal to NEAVD. I is the current produced. N is the number of free electrons per unit volume. E is the charge on an electron. A is the area of cross section. VD is the drift velocity. VD is the drift velocity. We can write it like this also. Guys, see. We can say I is equal to NEAVD. So VD will come out to be I upon NEA. I upon NEA. This is the drift velocity. Now guys, this N we can write it like this also. N divided by volume. N means total number of free electrons. Free electrons. And this means volume. So N will be equals to total number of free electrons divided by A into L. A is the area of cross section. L is the length of this conductor. So total volume is A into L. Put it over here. So drift velocity expression will be I upon, instead of N, you can write N divided by A into L. Then you can write E into A. Now tell me, my dear NEET aspirants, A and A will be cancelled. So this drift velocity expression will be I upon N divided by L into E. This is the drift velocity in terms of number of free electrons per unit length, where N divided by L means number of free electrons per unit length. It is the number of free electrons per unit length. Okay. The drift velocity of free electrons in a conductor is V. Okay. The drift velocity of free electrons in a conductor is V. Take a look, guys. These are the free electrons moving in a conductor, and the drift velocity is V. If the radius of the conductor is doubled, okay, see guys, then what will be the new drift velocity? This is the drift velocity. Sir, drift velocity we recently studied, it is I upon NE into A. Absolutely, sir. So in this particular case, what I can do is drift velocity will be I upon, if the radius of the conductor is doubled and current is also doubled. Okay, current is also doubled. So I upon NE. What is area of cross section? You can write pi r square. So can I not say this drift velocity is proportional to current divided by r square? Because in the question only it says current is doubled, drift velocity, radius is doubled. So N, number of free electrons per unit volume, depends upon material. If conductor is same, material is same, so N will remain same. Charge on an electron same, pi is same. Okay. Now guys, drift velocity V1 divided by V2 will come out to be. Okay, finally it says, finally, what is the new drift velocity? Vd dash, it will come out to be. Finally, current is going to be 2I. Okay, and this is going to be, I would say, 2R whole square. Because it says, if the radius of a conductor is doubled and current is also doubled. So this is the initial relation. Finally, this is doubled. So this will be 2I upon 4R square. 2 ones are 2 twos are. So this will be I divided by 2R square. So can I say Vd dash will come out to be, instead of I divided by R square, we can write Vd. So it will be Vd divided by 2. So drift velocity will be halved. Drift velocity will be halved. Okay, this question, important. A wire carries a current of 1.6 ampere. Current is 1.6 ampere. If free electrons per meter means N divided by L, number of free electrons per unit length, N by L. It is not the value of small n. No, this is given as 2 into 10 raised power 24. Okay, calculate drift velocity. We have to find the drift velocity. Guys, I told you the two expressions of drift velocity. I have told you the two expressions of drift velocity. See, first one is this. I upon Ne by A. This you will be using when number of free electrons per unit volume is given. In this case, N divided by L is given. So you'll be using this expression. I upon N by L into E. So I upon N divided by L into E. So current is 1.6 upon N divided by L is 2 into 10 raised power 24. And then this charge on an electron 1.6 into 10 raised power minus 19 Coulomb. Okay. This is what you are supposed to find out. Then you have current density. Then you have current density. Then you have current density. Take a look, my dear NEET aspirants. When it comes to the current density, you have, let's suppose, a conductor. You have, let's suppose, a conductor over here. Okay. And electrons are crossing this conductor. Electrons are crossing this conductor. Let me just give you example over here. This is a conductor. This is another conductor. So we say electrons are crossing this cross section over here. They are flowing in this case. What is the difference between the two? So here density of electrons crossing the cross section is large. Here density of electrons crossing the cross section is less. So can I say here density of current will be large? Yes. Here density of current will be less? Yes. So current density simply means it is the amount of current passing through unit cross-sectional area. It is the amount of current passing through unit cross-sectional area. So we represent this with J. J is simply, that is current I divided by, I would say, this area. Current divided by area. I divided by A. Amount of current passing through the unit cross-sectional area. I divided by A. That is what we call current density. Okay, so we can say J is equal to I by A. I we recently studied NEAVD. A and A will be cancelled. So J is equal to NEVD. This is the relation between current density and drift velocity. Current density in terms of drift velocity. This is the relation. J is equal to NEVD. Okay. Even I can write it like this also. This I we can say that is current J dot A. J vector dot A vector. So current density is also mentioned as JA cos theta. Remember these two also. Let's talk about this one. The current density, drift velocity at point A, B and C will be. The current density and drift velocity at A, B and C will be. You are supposed to tell me current density, current and drift velocity at A, B and C. Guys, see. Current at all the 3 points will be same. Keep that thing in your mind. Why, sir? Why? Because if I say 5 electrons are crossing A, same number of electrons will reach B and cross B. Same number of electrons will cross C. So whatever is the current produced at A, B and A, same will be at B, same will be at C. Current will be same. When it comes to the current density, guys, current density is I divided by area. Now current at all the points is same. Even area at all the points is same. So JA is equal to JB is equal to JC. When it comes to the drift velocity, recently we studied J is equal to NEVD. If current density is same, this is same, so VA is equal to VB is equal to VC. Even drift velocity will be also same. Here, current at all the points will be same. Current at A will be equals to current at B will be equals to current at C. Okay, this one. Then, my dear NEET aspirants, we say current density will be current upon area. Now, at point A, area is less, so current density will be large. If this is same, what is the relation between J and A? Inverse. The point where area is less, current density will be large. So JA is greater than JB is greater than JC. Obviously, density of electrons here will be large. When it comes to the drift velocity, we say current density is directly proportional to drift velocity. It is obvious. Your area is less. Drift velocity will be large. Electrons will flow far with large speed. So drift velocity at A is greater than drift velocity at B is greater than drift velocity at C. Ohm's law. What does Ohm's law actually say? What does Ohm's law actually say? Guys, do smash the like button if you have not liked this session yet. See guys, what does the Ohm's law actually say? You have got a conductor over here. You have got a conductor over here. Okay. You have got a conductor over here. And in this particular case, my dear NEET aspirants, there are large number of electrons flowing inside the conductor. There are large number of free electrons flowing inside the conductor. Okay. So these are the electrons placed inside the conductor. You connect a battery. So battery will develop the electric field. Due to the electric field, these electrons will experience force. When these electrons experience force, they start moving. When they start moving, they will produce current. So what I'm trying to say is that in this particular case, due to the battery, electric field is set up. So force acts on the electrons. So current is produced. Now guys, we say battery has got potential difference, 40 volt, 50 volt, 60 volt. If I say you'll keep a battery, you'll put a battery over here which has got large potential difference, large EMF. So due to that, strong electric field will be developed. If this is large, electric field will be large. Due to that, strong force will act on the electrons. Due to that, more electrons will flow. Flow of electrons will increase. If flow of electrons will increase, we say current will increase. So can I not directly say this V is directly proportional to I? On increasing the potential difference across the conductor, we say current, flow of electrons will increase, so current will increase. So replace this proportionality with a constant, that is R into I, where this R is what we call the resistance. This is Ohm's law. Ohm's law is this. V is directly proportional to I. Power of I is 1, power of this is 1. This is Ohm's law. Ohm's law says that if you increase the potential difference across a conductor, we say flow of electrons will increase, due to which current will increase. And potential difference is linearly proportional to the current. Potential difference is linearly proportional to the current. Sir, if I say V is directly proportional to I square, is it Ohm's law? No, it is not Ohm's law. It is not Ohm's law. V is directly proportional to I, but power of I is 1, linearly proportional. Linearly proportional. That is what we call Ohm's law. Okay. Okay. And if I say, my dear NEET aspirants, we say there are two types of conductors: ohmic conductors, non-ohmic conductors. Non-ohmic conductors means which do not obey Ohm's law. In non-ohmic conductors, current will increase with potential difference, but not linearly. Now see, slope of VI graph in case of Ohm's law. This is V versus I. If I say what is the slope over here, guys, always remember, I have told you this so many times, slope means tan theta. And here tan theta is perpendicular by base. Perpendicular is V divided by I. Now tell me, what is Ohm's law? V is equal to I into R. So V divided by I is actually equal to R. So V by I is actually equal to R, resistance, according to the Ohm's law. So can I say slope is directly proportional to resistance in case of VI graph? In case of VI graph. If you have IV graph, we can say in this particular case, if somebody says what is slope? This is theta. Slope is tan theta. Tan theta is perpendicular by base. That is I divided by V. That is I divided by V. Okay. That is I divided by V. Now, my dear NEET aspirants, in this particular case, if I say V is equal to I into R, can I not say in this case, guys, V divided by I will be equals to R. I divided by V will be equals to 1 by R. Do the reciprocal. So I divided by V is actually 1 divided by R. So what can I say? This slope is inversely proportional to resistance in case of this. In case of IV graph. So in case of IV graph, if you have to check the resistance, you'll be checking the slope, but that will be inversely proportional. Now take a look, guys. Compare the resistance of 3 wires, A, B, and C. This is VI graph. In VI graph, if you have to check resistance, you'll be checking the slope. Now see, this, and this, which has got more angle? This. So I can clearly say in this particular case, slope of A is greater than, slope of B is greater than slope of C. So a resistance of A is greater than resistance of B is greater than resistance of C. I can say it's something like this. Okay. VI graph again. Okay. Let me show you first this one. Temperature. Guys, directly remember, a resistance is directly proportional to temperature. Now you have to tell me in which case resistance is more. In that particular case, temperature will be more. You have to compare T1 and T2. You have to compare T1 and T2. Compare T1 and T2. So temperature of this wire is T1, temperature of this wire is T2. Clearly theta 1 is greater than theta 2. So I can say slope of 1 is greater than slope of 2. So can I not say resistance of 1 is greater than resistance of 2? So temperature of first is greater than temperature of second. What about this one? This is IV graph. In case of IV graph, resistance is inversely proportional to slope. Now tell me here, I can say slope of first is greater than slope of second. Okay. So I can say resistance of first is less than resistance of second because slope is inversely proportional to resistance. So I can say temperature of first is less than temperature of second. This is the answer. This is the answer. Because slope is resistance is directly proportional to temperature. Now, for non-ohmic conductors, guys, see. First of all, when it comes to an ohmic conductor, this is V versus I graph for an ohmic conductor. This is ohmic conductor. Ohmic conductor. Could you please tell me, this is theta. In this ohmic conductor, could you please tell me resistance? You say, sir, resistance will be slope. And slope in this case is constant. Yes. So for ohmic conductors, resistance is constant. Resistance does not change. Resistance remains the same. And graph is a straight line. In this case, this is IV graph over here. Take a look, IV or VI. Take a look. We say from, this is O, this is A. We say from O to A. From O to A. We say wire behaves Ohm's law. Guys, because from here to here, we can say V is directly proportional to I from O to A. But from A onwards, it becomes a curve. So from here to here, the resistance is constant. Array slope is constant, na? From O to A, slope is constant. Then slope changes because of the curve. So these are what we call non-ohmic conductors, which do not obey Ohm's law. Which do not obey Ohm's law. What does that mean? That means in this case, V is not directly linearly proportional to I. See, when it becomes curve, when it's a straight line, V is linearly proportional to I. Here also, on increasing the voltage, current is increasing. Same thing. In this case, see, on increasing voltage, we say current is increasing. But slope is not constant. Slope is not constant. Means resistance is not constant. Slope is not constant means resistance is not constant. So this is the graph of a semiconductor. This I'll teach you in the semiconductors. I hope you got the basic difference of Ohm's law versus ohmic conductors versus non-ohmic conductors. I hope you got that difference. What is the actual difference between ohmic conductors and non-ohmic conductors? Okay. Is this clear? अक्सर नहीं थे बैठा कर Now guys, come on, let's move. Resistance. What does resistance actually mean? See guys, let's suppose this is a conductor over here. In this conductor, okay, we say these electrons move, they produce current. What do you guys think? They move smoothly, they don't face any sort of collision. They face huge number of collisions, my dear NEET aspirants, huge number of collisions with the atoms, ions, molecules. So this hindrance created in the production of current, in the flow of electrons, this is what we call resistance. Like if electrons has to move in this case, here they will have to face large number of collisions because length is large. So if length is large, collisions will be large. And if area is more, so collisions will be less. They can move freely. Okay, so resistance is directly proportional to length. Resistance is inversely proportional to area. Combining the two, we say resistance is L by A. So rho L by A, where rho is the constant. Where rho is the constant. Okay, where rho is the constant and is called the resistivity of the material. So where rho is the resistivity or specific resistance, it is also called specific resistance. Rho does not depend upon the length, area and resistance. See guys, this rho only depends upon the material. Like, if I say this is material X, this is material Y. Okay. This will have the different value of resistivity. This will have the different value of resistivity. Why? Because this may have some capability of producing resistance. A large number of electrons are produced, large number of electrons are produced, electrons are facing large number of collisions here. Electrons are facing less number of collisions here. It depends upon the resistivity. So some material may have the less resistivity, some may have more. Or my dear NEET aspirant, see, if I say this is a conductor over here. Okay. This is made up of copper. This is also copper. Do you think the size of this is large? Different? Yes, size is different. So this has resistance R1, this has resistance R2. Why? Because length area is different, so resistance will be different. But this has got resistance rho, this has got resistance rho. Because resistivity, this has got resistivity rho, this has got resistivity rho. Resistivity only depends upon the material. Okay. So resistance depends upon resistivity, length and area. But resistivity only depends upon the material. Okay. Like you have a question over here. Find resistance in this particular case. So electrons are flowing here. Electrons are flowing in this, through this. Electrons are flowing through this. Electrons are flowing through this. And in this particular case, it is hollow from inner side. It is hollow from inner side. So means current inside is zero. No electron is flowing from the inner side. So basically, it is a concentric cylinder actually. Okay. Electrons are flowing through this portion only. Through this portion only. Okay. Now guys, if electrons are flowing through this portion only, can I not say it is like this? It is like this. See guys. It is like this. It is like this. So electrons are flowing through this portion only, through this portion only, through this portion only. Okay. So radius of this is R and radius of this is 3R. So can I say only this portion will create the resistance? Yes. So what is the area which is creating the resistance? That area will be, guys, what is the total area? Total area. That is pi. What is the area of disk? Pi r square. Pi into 3r whole square. This is the total area. Minus. How much is this area? R. So this will be pi into r square. So this will be 9 pi r square. 9 pi r square minus pi r square. So this will come out to be 8 pi r square. So what is the portion which is creating the resistance in this particular case? It is only 8 pi r square. It is not the entire 9 pi r square. It is only 8 pi r square. So this creates the resistance, only this one. So in this particular case, resistance will be rho L divided by area. L is the length given. So resistance will be rho L. Area I'll be taking over here 8 pi r square, because the resistance is being created by 8 pi r square only. 8 pi r square only. Resistance will be created by 8 pi r square only. Is that clear, boys and girls? Okay. Now, boys and girls, what about this? Find resistance in this case. Find resistance in this case. This is a cube and current is passing through this area, through this area. If you have to find the resistance in this case, you say simply resistance is rho L divided by A. So you say resistance is simply rho L. L you will be taking this length, this length. Okay. Area will be that area through which current is crossing. Current is crossing this area. So area of this will be this B into C. Okay. This B into C. And length will be A. Length will be A. And area will be B into C. In this particular case. Okay. Let's suppose if it would have been like this. This is A. Okay, let's consider this again. This is C, this is B, and this is A. Here in this particular case, this is the current flowing something like this. So here, if I say resistance will be rho, length you will be taking over here C, because it is current is moving along C. And it is crossing this area. If this is A, this will be A. It is crossing this area. That is B into A into B. Let's suppose if you have a cuboid, this is a cuboid. Okay. In this particular case, this is length, this is breadth, and this height. Here, my dear NEET aspirants, maximum resistance will be rho L divided by B into H. Maximum resistance will be when the current will flow something like this. This will be the maximum resistance in that case. Minimum resistance will be in this particular case if the current flows something like this. Because then this will be, you will be taking this as length H divided by L into B. That is area of this. Maximum resistance is when it flows like this. Minimum resistance is when it flows like this. Keep this thing in your mind directly. And when the current flows something like this, length will be L, area will be area of this, that is B into H, B into H. Okay. And when the current flows something like this, in that case, length will be H, area will be area of this, that is B into L. That is B into L. And if we say maximum resistance divided by minimum resistance, you can basically find, so you can see this over here. Okay. Ratio in this particular case. One more important formula. Resistance in terms of mass and length. Resistance in terms of mass and length. This is the expression of resistance in terms of mass and length. Previously you studied resistance R is equal to rho L divided by A. Okay. R is equal to rho L divided by A. That is resistance in terms of density, length, and area. But right now, resistance in terms of mass and length. Length, this. And what is this? D is density here. D is density. Density of the material. And rho is resistivity. And for a material, we say resistivity and density are constant. So resistance will be proportional to L square by M. Resistance in terms of mass and area. This is the expression which is in terms of mass and area. This is the expression of resistance in terms of mass and area. That is rho M divided by D into A square. So rho and D will be considered constant. So resistance is proportional to M divided by A square. like you have this question over here. Like you have this question over here. Masses of 3 wires are in the ratio of. So masses of 3 wires, M1 is to M2 is to M3. Okay. Directly, this is M1 is to M2 is to M3. 1 is to 3 is to 5. And length L1 is to L2 is to L3. Find ratio of resistance. In this case, mass and length is given. Then which expression I am supposed to use? R is proportional to L square by M. R is proportional to L square by M. So I'll be using as R is proportional to L square divided by M. So can I say resistance of first wire is to resistance of second wire is to resistance of third wire? It will be L square by M. Length of first, it is going to be 5 square. It is going to be 5 square divided by M. Mass of first, it is 1. Is to length of second, it is going to be 3 square divided by mass of second, that is going to be 3. Then length of third, it is going to be 5 square divided by 1 square. Wait. 1 square divided by 5 because length, okay? So this will be 25 divided by 1 is to 9 by 3 is to 1 divided by 5 is to 1 divided by 5. Now guys, what can we do? 3 ones are 3 threes are 9. Now 5 into 25 is 125 is to 5 into 3 is 15 is to 1. This is going to be the ratio in this case. This is going to be the ratio in this case. This is going to be the ratio in this case. Is this clear, guys? Is this clear? Oh? Now guys, let's take a look exactly over here. See, this is the master concept which I would want you guys to remember over here. See, You have studied one equation of current and drift velocity. I is equal to NEAVD. And here drift velocity is EE by M into tau. If you put the value of, listen to me very carefully, my dear NEET aspirants. So from here, what will be the value of drift velocity? That is I upon NEA. So that I upon NEA you need to put over here. When you do that, you will get this formula. I'm telling you the approach. I'm telling you the approach. Okay. So here drift velocity will be I upon NEA. Put that over here, you will get this formula directly. This is what we call microscopic form of Ohm's law. This is what we call microscopic form of Ohm's law. Ohm's law. Okay. Then, my dear NEET aspirants, if you compare it with V is equal to IR, see, V, R, okay, leave R, I, and here you have R, you have ML upon NE square tau into A. So this will be the value of resistance. This will be the value of resistance. So R is equal to ML NE square tau into A. This is the resistance. This is the actual formula of resistance. Okay, actual form of resistance. Formula of resistance. Yes, sir. Okay. So when you compare this formula with this, so VV, I, rest of the thing will be equal to R. Then, my dear NEET aspirants, if you compare this equation with R is equal to rho L by A, you see R, you see R. See this, see this. You see R, you have R. You have L, you have L. You have A, you have A. Here you have rho. Here you have this. Ah, sir. So this is the actual formula of resistivity. Resistivity is M upon NE square into tau. M upon NE square into tau. Then, my dear NEET aspirants, resistivity is inverse of conductivity. If a material has got large resistivity, it will have less conductivity. So resistivity is inverse of conductivity. So conductivity will come out to be NE square, inverse of this. Take this in the numerator, take this in the denominator. NE square tau divided by M. This is conductivity. Conductivity is capability of a material in the production of current. Sir, large current is flowing in this material. It has large conductivity. Sir, resistivity is large. Capability of a material to produce the resistance. Capability of a material to produce the current. That is called conductivity. Capability of a material to produce the resistance is resistivity. They are opposite. They are opposite. Where there is more resistance, current will be less. So that's why this is conductivity. Is this clear? Please give me the signal in the chats. Come on, guys. Quick. Is this clear? Give me the signal in the chats. Temperature dependence of resistance and resistivity. Temperature dependence of resistance and resistivity. See, guys. Let's suppose you have a material over here. This is a conductor over here. Okay. This is a conductor over here. In this particular case, let's suppose it has a resistance R naught initially at 0 Kelvin. We have not increased the temperature at 0 Kelvin. We say it has resistance R naught. Okay. Now, finally, when you increase the temperature, okay, when you increase the temperature, this is the resistance at T initial or 0 Kelvin. When you increase the temperature, its resistance becomes R final. That is the temperature. It is like you have a material. You are increasing the temperature of the material. Inside this material, you have atoms, ions, molecules. They start vibrating. They start vibrating. Okay. They start vibrating. So when they start vibrating, we say, guys, these atoms, ions, molecules start vibrating. We say flow of electrons will face more collisions. If flow of electrons face more collisions, my dear NEET aspirants, we say resistance will be more. So resistance does depend upon the temperature. So if I say what is the value of final resistance, you say, sir, final resistance will be R naught, initial resistance, 1 plus alpha delta T. Alpha is the coefficient coefficient over here that we use. Okay. Okay. Alpha is the temperature coefficient of resistance and resistivity. Alpha decides that whether in a material on increasing the temperature, resistance will increase or decrease. Alpha defines alpha is what we call temperature coefficient of resistance and resistivity. Temperature coefficient of resistance and resistivity. Temperature coefficient of resistance and resistivity. So alpha decides whether on increasing the temperature, resistance increases or decreases. Or decreases. Okay. Alpha decides whether on increasing the temperature, resistance increases or decreases. Okay. Okay. So my dear NEET aspirants, so delta T is the change in temperature. Delta T is the change in temperature. That is final temperature minus initial temperature. Okay. Even you can find the value of alpha from this also. So this will be R naught. Okay. This will be R naught. This over here. In this particular case. So this is R naught. Take this R naught down. So RF divided by R naught. Then take this minus 1 over there. It will become minus 1 is equal to alpha delta T. So take it over there. This will be RF minus R naught divided by R naught is equal to alpha delta T. So alpha will come out to be final resistance minus initial resistance divided by delta T into initial resistance. Okay. So basically, sir, does resistivity also depend upon the temperature? Absolutely. Resistivity also depend upon the temperature. Okay. Resistivity also depend upon the temperature. Okay, we'll take the break exactly at 6:15, huh? Because we have iftari at 6:20. Huh? We'll take the break at 6:15. Now see, we are fasting, guys. Huh? By the way, that's why we'll have to take the break at. We'll have to break the fast actually at 6:20. That's why. Now, so this is alpha. Alpha is final resistance minus initial resistance, alpha delta T. Okay, this delta T into R naught. Now, my dear NEET aspirants, okay, I'll speak to Wasim sir about it. Pro-Palestinian, I'll speak to Wasim sir about it. Don't worry about that. See, in this particular case, temperature dependence of resistance and resistivity means on increasing or on changing the temperature, whether the resistance or resistivity of the material changes or not. Okay. So if I say initially temperature was R naught, finally temperature is RF. So final temperature is going to be R naught 1 plus alpha delta T. So alpha decides whether on increasing the temperature, we say resistance will increase or decrease. Like for conductors, we say value of alpha is positive. So if I say R final will be R naught 1 plus alpha delta T. Guys, see. If you keep alpha negative, means this will be negative. So initial resistance minus something. So initial resistance minus something will decrease. The final resistance will be less. If initially it is 10, finally will be 5. So resistance is decreasing. But for conductors, if alpha is positive, what does that mean? On increase, in temperature, resistance increases. Okay. And then, my dear NEET aspirants, if I say for semiconductors, we say alpha is negative. Alpha is negative means on increase in temperature. Increase in temperature. Okay, on increase in temperature, we say resistance decreases. We say resistance decreases. We say resistance decreases. Okay. Okay. Yes. So basically for this, okay, one more important thing over here, this one. Guys, let's suppose if you ever get a question of this sort and you have to find out what is the potential of point A. You have to find out what is the potential of point A. Okay. You have to find out what is the potential of point A. Okay. Now, my dear NEET aspirants, what I'm trying to say in this particular case is, if let's suppose this is the question given, you are asked to find the potential VA. Find potential VA. Listen carefully. Listen carefully. In this particular case, my dear NEET aspirants, what I say is that you start from this point. You start from this point. You start from this point. And then you move further, you'll have to reach this point. In this particular case, the first thing is select the path. Select the path. It is of your choice. If you want to go from A to B or B to A, completely of your choice. Let's suppose, okay, we are supposed to find VA minus VB in this particular case. Okay, it is given in the question. Not this. Okay, select the path. First thing, select the path. VB minus VA or VA minus VB. Then draw the sign conventions, my dear NEET aspirants. If this is the direction of current, always remember current will always flow from higher potential to lower potential. So this has to be higher, this has to be lower. Plus means high, minus means low. So this has to be high, this means low. Only in resistors you say, here higher is this is lower. In battery, this is higher, this is lower. In resistors, you will basically define plus minus according to the direction of current. Okay. Now, then if you select the path from B to A, so first you will be writing the potential of B, this potential. Then you will be writing the potential of this. What is the potential of this? Potential difference, 6 volt. And you are moving from lower to higher because this is your path. So on moving from lower to higher, directly remember, you will be considering its potential drop as positive. So plus 6 if you move from higher to lower. And here you are moving from higher to lower. Its potential drop. What is the potential drop in case of resistance? I into R. So current is 2, R is 2. So it is 2, resistance is 5. 2 into 5, I into R. And this potential drop will be negative. Why? Because you are moving from higher to lower. Again, when you reached here, this is minus 4 volts, plus 4 volts. Why? Because you are moving from lower to higher. And then when you move from here to here, this will be again minus I into R. Minus I into R. I is 2, R is 3. Is equal to, finally I'll write over here VA. Finally I'll write over here VA. Okay. So I can write over here, this will be VB plus, guys, what you are supposed to remember over here, in case of a resistor, potential difference will be V is equal to IR. Here also V will be equals to I into R. And if you move from higher to lower, consider potential drop as negative. If you move from lower to higher, consider potential drop as positive. If you move from higher to lower, consider potential drop as negative. So this will be 6. minus 2 fives are is 10 plus 4 2 threes are is 6 is equal to, I would say, VA. Okay. Now plus 6 minus 6 will cancel. 2 threes are 6, 2 fives are 10, 6, 6. Did I make any mistake? 2. First of all, 6 plus 6, then minus 5 twos are 10, then plus 4, then 2 threes are 6 minus 6. Yeah, correct. So VB minus 10 plus 4 is minus 6 is equal to VA. Take it over here. So VB minus VA comes out to be 6 volts. And if you find VA minus VB, VA minus VB will be minus 6. Minus 6. This is the question which was asked in NEET 2016 on the same pattern. This is the question which was asked in NEET 2016 on the same pattern. The difference between A and B in the given figure is, okay, the potential difference between A and B in the given figure is, in this case also select the path. Like we'll select from A to B. Okay. So first we'll write the potential VA. If this is the direction of current, this will be positive, this will be negative. This will be positive, this will be negative. Current always flow from higher to lower. And what is the potential difference over here? I into R. Current is how much? 2. And R is over here how much? That is 2 into this 2. So what is the potential difference over here? I into R. I is 2 and resistance is 1. Now tell me. First, here, potential difference of this one. Potential difference of this one, that is 2 into 2, VA, and this will be minus, because we are moving from higher to lower, minus 4. Then here, minus 3. Here also we are moving from higher to lower. Then here also minus 2 is equal to finally VB. Final point is VB. Last point you write equal to VB. So you say VA minus 4 minus 3 is minus 7 minus 9 is equal to VB. Take it over there. VA minus VB will come out to be 9 volt. Midpoint potential. Midpoint potential. Midpoint potential. Midpoint potential. Midpoint potential. See, my dear NEET aspirants, in this particular case, this is the point which is the common point. Potential of this point is V1, potential of this point is V2, potential of this point is V3. You are supposed to tell me what is the potential of this point. These are the 3 resistors. And when we use the common potential or midpoint potential formula, you simply say midpoint potential formula will be V1 divided by R1 plus V2 by R2 plus V3 by R3 upon 1 by R1, 1 by R2, 1 by R3. So this is the midpoint potential formula that we actually use over here. Okay, so it is not like capacitor C1 V1 plus C2 V2 plus C3 V3 upon C1 plus C2 plus C3. No. It is C1, it is V1 by R1 plus V2 by R2 plus V3 by R3 upon 1 by R1, 1 by R2, 1 by R3. V1 is the potential of this. R1 is the potential of resistance of this. V2 potential of this and resistance of this similarly. Now, this is the question over here in this particular case, which you are supposed to solve. In this case also, you'll have to use the same expression. Okay. So you'll be assuming the potential at this point as 0. You'll be assuming the potential at this point as 0 volts. This is lead. Okay. Now guys, let's take a break. Let's take a break. This is a break. Okay. This is a break. Just a second. Okay. Break is till. This is a dinner break. Okay. We'll have to break the fast and we'll have to eat something. So I'll be taking the break till 7 p.m. So this is the dinner break. 7 p.m. Okay. So see you after 7. Okay. Take care and bye-bye. See you after 7. Okay, guys, let's get back to business. Now, guys, take a look. Take a look at this particular question over here. We are supposed to find, in this particular case, current in this resistance. Before finding the current in this resistance, my dear NEET aspirants, what you are supposed to do is you find the potential of every single point over here. So for that, we are assuming potential of this point as 0. Okay, this is the technique that we use. It will not create any difference. So what I'm going to do in this particular case, that is, let's assume potential of this point as 0. If potential of this point is 0, what is going to be the potential of this point? Guys, listen to me very carefully. So you'll simply say, sir, this point has potential, let's suppose VA, higher potential minus lower potential is 0, is equal to delta V, that is 20. So this will be plus 20. If this is plus 20, potential of this point is also going to be plus 20 volts. If this is 0, this is 10, this will be simply plus 10 volts. So potential of this is going to be plus 10 volts. As simple as that. As simple as that. Now, my dear NEET aspirants, in this particular case, what I want you guys to understand over here is, that is, now, you can redraw this. When you redraw this, now you'll be making this resistance over here, and this resistance over here. This one, and this one. Because you got the potential of this point. Now you have to find the potential of this point only, common point. So this is 20 volts over here, and this is how much? I would say 10 ohms. This is 20 ohms over here, and this is how much? 10 volts. This is 5 ohms over here, and this is how much? I would say 0 volts. If I say you have to find the potential of this point, that is Vm, midpoint, what are you going to say? Use the midpoint potential formula. That is V1 by R1, V2 by R2, V3 by R3, 1 by R1, 1 by R2, 1 by R3. So V1 by R1, consider this V1, consider this R1. This is going to be 20 divided by 10 plus V2 by R2, 10 divided by 20. Okay. Then V3 by R3, that is going to be 0 divided by 5 upon 1 by R1, 1 divided by 10 plus 1 by R2, 1 divided by 5, then plus 1 by R3, 1 divided by 20. Then, my dear NEET aspirants, 1 by R1, 1 by R2, 1 divided by 1 by R1, 1 by R2, 1 by R3. Okay, yes. Now, this is going to be 50 divided by 7. This will be 50 by 7. So, you got the potential of this as 50 by 7. Now, you have to find the current. Very simple. Consider this. Take a look, guys. Consider this resistance. So, this is 20 ohm resistance. Potential of this is 10 volts. And potential of this is 50 divided by 7. Because this point we got 50 by 7. Now, we know that V is equal to I into R. So, I will be simply, that is delta V divided by R. It is actually delta V. V is potential difference. We actually write it delta V. So, delta V means potential difference, higher potential minus lower. So, that will be higher potential is 10 minus lower is 50 by 7 divided by R. R is 20. Okay. Now, this is going to be 70. Guys, see, 70 minus 50, that is 20 divided by 7 into 20. Okay, this is 70 minus 50, that is 20, 20 by 7. So 20 will cancel, so it will be 1 divided by 7 ampere. So current in this resistance is 1 by 7 ampere. Let's find, my dear NEET aspirants, the current in this resistance. So you will have to consider this resistance only. So this resistance is going to be 20 volts over here. This resistance is going to be 50 divided by 7. And we have to find, this is 10 ohm resistance. So I can say I is equal to delta V divided by R. Delta V again is, that is 20 minus 50 divided by 7 upon R is 10 over here. Now guys, this is 7 into 20, that is 140 minus 50. So this is going to be 140 minus 50. Okay, that will be 90. 90 divided by 7 into 10. Okay, because this is 70. 7 into, this is 140 minus 50. That is going to be 90. This and this will cancel. So this is going to be 9 divided by 7 ampere. So basically what I'm trying to say, my dear NEET aspirants, in this particular case is simply, if you got the potential of every single point, you can find the current by using delta V divided by R. Delta V by R. Let's take a look at this point. Find the potential difference between A and B. Find the potential difference between A and B. This is a question from JEE Mains 2019. You have to tell me potential difference between A and B. Listen carefully, guys. If we assume potential at this point as 0 volts. 0 volts. Okay, we say let. If this is 0, okay. Let's first redraw this. We need to redraw this. Guys, see. This resistance and this resistance, this battery and this resistance, you can consider them in series. You can consider these three in series. There is no problem in that. Because if you cut it over here, if you make it straight, it will be in series. So this 10 plus 10 is 20. So you can make it like this. This will be 20 ohms. 10 plus 10 is 20 and this is 2 volts. Okay. Then this will be 20 ohms. This will be 4 volts. Okay. Guys, when resistors are connected in series, their equivalent resistance is R1 plus R2. That's what I did. R1 plus R2, that is 20, 10 plus 10 is 20 and this is 2 ohms. Here also this is 20 and this is 4 volts. And then, my dear NEET aspirants, this 10 plus this and this will be considered as series. So this 20 plus 10 is 30. So I'll be mentioning over here, this will be 30 ohms and this will be over here 4 volts. This will be over here 4 volts. And in this particular case, I would say this is 0 volts let. If this is 0 volts, what will be the potential of this and 4? 4 minus 0 is 4. Here also it is going to be 0 because straight. So what is the potential of this? That is 2. If this is 0, this will be also 0. What is the potential of this? This will be 4. This will be 4. Now guys, you can apply the midpoint potential formula. See, now you need to find the potential of this point. Okay. So you can apply the midpoint potential formula. Consider this portion only. Guys, see, V1 by R1 plus V2 by R2 plus V3 by R3. Done. Then you will get the potential of this common point because this is common to all the three. This is V mid. So you can apply V mid over here. V1 by R1, that is 2 divided by 20 plus V2 by R2. V2 is 4 divided by 20 plus V3 by R3, that is 4 divided by 30. Then upon 1 by R1, 1 divided by R1, 1 divided by 20 plus 1 by R2, 20 plus 1 by R3, this is 30. This is going to be the potential of this midpoint. This is going to be the potential of this midpoint. Okay. Okay. I hope I am not confusing you over here. Basically, I said this and this will be in the series. So 10 plus 10 is 20. This you keep as it is. Then I said this and this is also in series. So 10 plus 20 is 30. So I can write 30 over here. Then this battery, this battery, this battery. If you assume 0 volt here, here also will be 0. Here also will be 0. If this is 0, this will be 4. Because 4 minus 0 is this 4. If this is 0, this will be 4. Because this is 4. If this is 0, this will be 2. Now assume this one. You apply midpoint potential formula. This will come out to be 3.12. So potential of this came out to be 3.12. So this is Vm, or this is Va actually. Va, can I say minus 0 will come out to be 3.12, because this is Va na, actually a point. Va minus 0 is 3.12. So this is Va minus, what is the value of 0? 0 is actually Vb. You assumed Vb to be 0. This is 3.12 volts. So this is the answer. You were supposed to find the potential difference between A and B. Okay. Let's talk about this question. This is a good question actually. See guys, in this particular case, what I want you guys to understand over here is, that is interchange, take this, redraw it. We can redraw it something like this. Okay. Guys, these two were actually in series. Okay. These two were actually in series. I took it over here. Okay. So now, my dear NEET aspirants, what I'm trying to say is that this is 20 volts. This is 10 volts. This is 8 volts. You have to find the current in this 5 ohm resistance. This is 4 ohm. Can you find the current in this 5 ohm resistance? Tell me, guys. Do one thing, assume 0 volt potential at a point. I am assuming 0 at this point. If this is 0, what will be the potential of this? It will be 0. If this is 0, what will be the potential of this? Minus 8 volts. Okay. If this is minus 8, what will be here? Minus 8 volts. Sir, how is it is going to be minus 8? See, I'll tell you. We say this will be at higher potential because this is connected to higher. So higher potential is, we say Va minus Vb is equal to delta V. What is the Va over here? That is 0. Minus, what is Vb over here? That is what we are supposed to calculate, is equal to delta V is 8. Take this minus over here. Vb come out to be minus 8. That's what I said. Okay. If this is minus 8, what will be the potential of this? This is going to be minus 8. Now, if this is 0, this is going to be 0 volt. If this is 0, what will be the potential of this? This will be minus 20 volts. If this is 0, what will be the potential of this? This is going to be 10 volts. I hope you are able to figure out what I'm trying to do. If this is 0, this is higher. So this side has to be lower. Na? So if this is negative terminal, that's why I'm mentioning minus 8. If this is 0, from this side, it has to be lower. Na? So that's why I'm mentioning minus 8. Okay. Now you have to find the current in this one. So current is going to be, see, take this resistance. This is 5 ohm. From this side, it is minus 20 volt. From this side, it is minus 8 volt. Okay. So in this particular case, I would say I is going to be delta V divided by R. So you will say higher, that is minus 8, minus lower, that is minus 20. Minus 20 is less than minus 8, divided by R is 5. So minus into minus is plus. So plus 20 minus 8, that will be 12. Plus 12 divided by 5 ampere. Array, amazing. Amazing. I hope this question is crystalline clear. Okay. Is this clear, guys? Is this clear? Tell me. Even you can find the current in this one also. In this one, this 4 ohm resistance. Here it is 10 volt. Here it is minus 8 volt. So what will you say? I is equal to delta V by R. Delta V is higher potential minus lower potential is minus 8 divided by R is 4. So this will be 18 divided by 4. So that is going to be 9 by 2 ampere. Are it done, sir? Okay. This one I'm giving you as homework. Find the potential difference between A and B. This one I'm giving you as homework. Please do this from your end. Now take a look. Series and parallel combination of cells. Series combination of cells. First of all, sir, tell me what is the cell? Cell means battery. If I say this is a battery over here, this is what we call cell. This cell has got its own EMF, that is E. Okay. And it has got its internal resistance. This is the internal resistance of the cell. This cell has got EMF. EMF means 20 volt, 30 volt. Okay. So this is the EMF. If I say, sir, 20 volt battery is there, like here. This is 2 volt battery. Its EMF is 2 volt. Similarly, cell has got EMF as well as its internal resistance. So in this particular case, my dear NEET aspirants, we say there are a lot of cells connected in series over here. This has E1 EMF, internal resistance R1. E2 EMF, internal resistance R2. E3 EMF, internal resistance R3. So my dear NEET aspirants, you have to find the net EMF in this particular case. In case of series combination, if you have to find the resultant EMF of all the cells, say E1 plus E2 plus E3 plus E4 and so on. And these internal resistances, sir, what is their internal resistance? Net resistance. R1 plus R2 plus R3 up to R. Up to R. Okay. And if you have N cells, if you have N identical cells, okay, for N identical cells, you simply say net EMF is going to be, that is N times of E. N identical cells means if this is E and up to N, so that will be N times of E. And we say R equivalent. So R net is going to be N times of R. N times of R. Okay, R net is going to be N times of R. Then if you have the cells connected in parallel, like this is cell 1, this is cell 2. Its internal resistance, In this particular case, my dear NEET aspirants, if I say what is the net EMF, this is going to be the net EMF in this particular case. This is going to be the net EMF in this particular case. This is going to be the net EMF in this particular case. So when it comes to the net EMF, this is going to be the net EMF in this particular case. E1 by R1, EMF of first divided by resistance of first, plus E2 by R2 upon 1 by R1, 1 by R2. This is going to be the net EMF. Okay. And if I say what is the net internal resistance? Guys, internal resistance in parallel combination, we find it like this. 1 by R1 plus 1 by R2. In parallel, this is how we find the internal resistance. In series, we say R1 plus R2 and so on. Do the cross. 1 by R equivalent will be simply R1 plus R2 upon R1 into R2. Do the reciprocal. So when you do the reciprocal, it will become like this. R equivalent will be R1 R2 upon R1 plus R2. So this is the net EMF in parallel. This is the net internal resistance in parallel. Like in series, this is the net EMF in series. This is the net internal resistance in series. Now guys, for N identical cells in parallel, if you have N identical cells in parallel, this is E, R. So their equivalent resistance is going to be, equivalent EMF is going to be E only. Here I have mentioned. So it will be simply E by R. So this will be N times. This will be also N times. N times R will cancel. It will be E. So if you have N identical cells connected in parallel, their net EMF in that particular case, my dear NEET aspirants, is going to be, that is E only. That is E only. And my dear NEET aspirants, if I say equivalent resistance, that is R divided by N. Okay. If you have N identical cells connected in parallel, What is the net EMF? E only. That is the EMF of one cell. That will be net. What is the net internal resistance? R divided by N. Okay. R divided by N. If there are 4, then R by 4. If there are 3, then R by 3. Take a look, guys. Directly. If N, this is called mixed grouping. If N cells are in series and M times in parallel, N cells, 1, 2, 3, 4, how many times? N times, N cells in parallel, in series. And how many times? M times in parallel, M times in parallel. Now guys, if I say what is the net EMF in this case? See. Could you please tell me what is the net EMF of all these? You say N times of E. Okay. Now for these N times of E. For these N times of E. Okay. Then my dear NEET aspirants, recently I told you, if identical cells are connected in parallel, their EMF equivalent will be the EMF of one cell. Here also, if I say, I can make it like this. Okay, like this. This is E, R. This is E, this is R. This is E, this is R. Now, in this particular case, my dear NEET aspirant, this is N times of E, N times of E, N times of E. So, if I say what is going to be the net EMF? N times of E, because in parallel combination, it remains the same. But we say R equivalent here will be NR divided by M, because they are M times in parallel. Please remember this directly. If you have N number of cells in series, M times in parallel, their equivalent EMF is going to be N times of E. Directly remember this. And R equivalent is going to be NR divided by NR divided by M. There is a question over here. Find the current through the ammeter. What is the current passing through the ammeter? See. This is 120 volt battery and this is 60 ohm resistors. If I say, what is the current in this resistance? You say, sir, current will be I is equal to V divided by R. This is directly connected to this. So value of V is 120, R is 60. 61s are, 62s are. So this is 2. Okay. Through this current flowing is 2 ampere. Even through this also current flowing will be 2 ampere because this is also directly connected to this. Even I would say through this also current will be 2 ampere. Even I would say this is 2 ampere. Through this also current is 2 ampere. Now current always flow in a loop. So this will flow something like this. This will flow something like this. This will flow something like this. This will come and it will pass through ammeter. This will also pass through ammeter. This will also pass through ammeter. So that current which passes through the ammeter, that will be the reading of ammeter. That is the current passing through ammeter. So 2 plus 2 plus 2. So that will be 6 ampere. 6 ampere. 6 ampere is the current passing through the ammeter. 6 ampere is the current passing through the ammeter. Okay. Simple. Because see. This battery is connected to this resistance in parallel. So what I'm trying to say in this particular case, whatever is the current sent by the battery to the same will be here. So total current will be 6 ampere. Find V net. See guys, these three are in series. When cells are in series, how do we find the net EMF? E1 plus E2 plus E3. 6 plus 6 is 12. 12 plus 2 is 14. So this is 14 EMF, 14 volt. Then 4 plus 3 is 7. This is 7 ohm. Then 6 plus 1 is 7. This is 7 volt. And then 3 plus 2 is 5. 5 plus 3 is 8. This is going to be 8 ohms. Okay. This is basically over here. Now you have to find V net. How do we find V net in this particular case? Guys, these are in parallel. How do we find? E1 by R1 plus E2 by R2. We'll be saying E1, that is 14 divided by 7 plus 7 divided by 8. E1 by R1, E2 by R2 upon 1 by R1, 1 by R2. 1 divided by 7 plus 1 divided by 8. This is the net EMF in this particular case. I hope this is crystal and clear. Guys, give me the signal in the chat if this is clear. Come on, quick, 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 quick. Yes, tomorrow I'll take the class in Phoenix. Now guys, take a look. Bulb. What is this bulb? Bulb is actually the pure resistance. Bulb is actually the pure resistance. Okay. What does that mean? Guys, see. Bulb is the bulb that we use in our rooms, okay? That is the bulb. Now, my dear NEET aspirants, if you go to the market, if you see the bulb, let's suppose you are buying a 100-watt bulb. It would be mentioned 220 volts on it. What does it mean? This 220 volt means rated voltage. Okay? And this 100 watt means rated power. A rated voltage and a rated power. What does that mean? That means if we give a supply of 220 volts to the bulb, it will give us a power of 100 watts. Sometimes you see you are getting, you brought the good bulb from the market. High watt bulb. But still it is not giving you the enough brightness in the room. Why? It may be because you are not supplying it the sufficient voltage. You are not supplying it 220 voltage. If you supply it 220 voltage, it will give you confirm 100 watt. But if you supply less than that, then in that particular case, we say you will not get 100 watts. That is, what does it mean? So if this much voltage is supplied to this bulb, then only it will give you the 100 watts of power. So this is called rated voltage and rated power. Okay. How much voltage you are supposed to give, how much power it will give from there. Now guys, we say one important formula I just want to mention over here. What is that? See, remember this, my dear NEET aspirants. We said this power is equal to V square divided by R. This is the formula of power. Voltage upon resistance. Power is voltage upon resistance. This is the formula. Or power is also equals to I square into R. I square into R. Or power is also equal to V into I. These three formulas you guys are supposed to remember. Let's suppose if you have a resistance. In this resistance is R. Okay, resistance of this resistor is R. Okay. And you are basically sending a current I to this. You are sending a current I to this. Okay. See guys, I'll make you understand here. See. Let's suppose you have a resistance over here and there is a battery. This battery has got potential difference V. This is the resistance R. And this is the current sent by the battery. This is the current sent by the battery. If I say how much is the current sent by the battery, you say, sir, I am saying how much is the power supplied by the battery? Because battery sending current means battery sending energy. Energy means power. Energy per second. How much energy it is sending every second, that is what we call power. Like this bulb is giving me the power right now. What does that mean? It is giving me the energy right now. So we say how much power it will give? Power is equal to V into I. So this power will go here in this resistance. So we can say in case of resistance, V is equal to I into R. This power, this energy, we can write it P is equal to, instead of V, I can write I into R. Okay. So then we say this I into I becomes I square into R, I square into R. Or we can say it like this also. Power is equal to I is V by R. So it will be V square divided by R square into I would say R. Square and this will cancel. So power will be equals to V square divided by R. So these are the three formulas of power you need to remember. These are the three formulas of power you need to remember. Now come here. We say power is V square by R. Now here I would say, take this R there. Can I say resistance will be equals to V square divided by P? So what is this resistance? This is the resistance of the bulb. This is the voltage rated square. This is the power rated. So my dear NEET aspirants, if I say you have got a bulb, it is 100 watt or it is 110 watt. Okay. And then we say 220 volts. This is the power rated. This is the voltage rated. What does that mean? That means if you give a 220 volt supply to this, it will give you 100 watt power. And it is in India, it is mentioned on every single bulb that it will be 220 volt will be rated voltage, because government supplies us the voltage at 220 volts. If I say what is the resistance of the bulb? Resistance of the bulb is voltage rated square divided by power rated. Voltage rated square is 220 square divided by power rated is 110. Solve it, you will get the resistance of the bulb. So basically resistance of the bulb, this voltage rated and power rated also help you to find the resistance of the bulb. Okay. Now, if let's suppose you are multiple bulbs connected in series and you have to find their net power consumption. Okay. Directly remember, net power consumption here is going to be like this. 1 divided by P net. It is going to be 1 by P1 plus 1 by P2 plus 1 divided by P3 and so on. This is how we find the net power consumption in series combination, Okay. And one more important thing, my dear NEET aspirants, which is very important in this case, Since I told you bulb has got a rated voltage and rated power. How much power is mentioned, how much power it has the capability to give, and at how much voltage. Yes, sir. Yes, sir. Now the second thing I just want to mention over here, apart from this rated voltage, we say power consumed power. Power supplied, I would write. See guys, when it comes to power supplied, listen to me very carefully. When it comes to power supplied will be equals to voltage supplied square divided by resistance of the bulb. When it comes to the power rated, please don't get confused here. Power rated means voltage rated square divided by resistance of the bulb. See guys, power rated tells you how much capability the bulb has. Okay, like if the 100 watt bulb is there, it has the 100 watt capability. That is power rated. Power supplied means how much bulb is supplying the power. If this is a bulb, it has 100 watts, this is power rated, and this is voltage rated is 220. What does it mean? It has the capability of 100 watts if you give supply of 220 volts. If you don't give 220 volts, if you give only 110 volts, in that case, let's suppose it will give you a power of, I would say 150 watts, 30 watts. So means if you give this much of voltage, it will give you this much of power. This is supplied power. This is supplied voltage. So in front of the supplied power, you have supplied voltage. In front of the rated power, you have rated voltage. I hope you got the difference between the two. You got the difference between the two. So power consumed means how much it is giving you, or power supplied. Supplied and consumed is one and the same thing. And in series combination, guys, see, if you have multiple bulbs connected in series, their equivalent will be 1 by P1, 1 by P2, 1 by P3. And my dear NEET aspirants, in this particular case, we say power consumed will be inversely proportional to the power rated in series. In series. What does that mean? What does that mean? That means the one which has got more power rated will consume, will supply less power, will give less brightness, like 25 watt, 50 watt, 100 watt. Compare the brightness of the three. This is in series. We said this has got more power rated as compared to 50, as compared to 25. So I would say in this particular case, power supplied by 100 watt is greater than, less than, or I would say power supplied by 25 watt is greater than power supplied by 50 watt is greater than power supplied by 100 watt. Why, sir? Because in series combination, power supplied is inversely proportional to the power rated. So I would say brightness of 25 is greater than brightness of 50 watts is greater than brightness of 100 watts. So my dear NEET aspirants, if you want 100 watt to glow more, then in that case, you have to connect the bulbs in parallel, not in series. Is this clear? Is this clear, guys? Is this clear? Then we say parallel combination. In parallel combination, when it comes to the net power consumption, it is the power rated first, power rated of second, plus power rated of third. This is how we find the net power consumption in parallel combination. Okay. As simple as that. As simple as that. Okay. Yes. Yes. Now, guys, see, in this particular case, in parallel combination, we say power consumed is directly proportional to the power rated. What does that mean? That means the one which has got more power rated will give more power, will supply more power. 25, 50, 100. Which one has got more power rated? Which one has got more power rated? Sir, this one. So here brightness of 100 will be greater than brightness of 50, will be greater than brightness of 25. You can say it like this. Let's take a look at this question. There is a question. 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and zero internal resistance. The ratio of power consumption by the bulbs when all are glowing, and second, when 2 from section A and 1 from section B are glowing. When 2 from section A and 1 from section B are glowing. Okay. Now, my dear NEET aspirants. What I want you guys to understand in this particular case, this is the bulb, 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 this is the bulb. And in this particular case, it says, first, when all are glowing, you have to tell me when all the bulbs in this case are glowing, what will be the net power consumption? Guys, see, this is P, this is P, this is P, this is P, because they are identical. This is P, this is P. What will be the equivalent power consumption when all are glowing, when all are working? Section A, P. This will be 3P. So this is going to be 3P. Section B, this is going to be 3P. This is 3P. This is 3P. Okay. So what is the power net first? This is P1. So that will be, tell me guys, when two bulbs are in parallel or in series, how do you find the net power consumption? 1 by P1, 1 by P2. Okay. So I can write it like this. In parallel, 1 by P net is going to be 1 divided by P1 plus 1 divided by P2. Do the cross multiply. This will be P2 plus P1 upon P1 into P2. So do the rest. This is 1 divided by P net. So do the reciprocal. P net will be simply P1 P2 upon P1 plus P2. So P1 P2, that is 3P into 3P upon 3P plus 3P, that is 6P. So this will be 9P square divided by 6P. P and square will cancel. 2 3s are 6, 3 2s are 6, 3 3s are 9. So 3P divided by 2. So when all the 6 bulbs are glowing, in that case, net power consumption is 3P by 2. Then it says, when 2 from section A, 2 from section A, 1 from section B is glowing. So P plus P is 2P. Second one will be, this will be 2P and this will be P. Okay. In this particular case, I would say P2 will be, that is this and this in series, that is 2P into P upon 2P plus P, that is 3P. So this will be 2P square divided by 3P. P and square will cancel. So 2P divided by 3. We have to find the ratio. We have to find the ratio. We have to find the ratio. How do we find ratio? We say P1 divided by P2. P1 is 3P divided by 2. P2 is 2P divided by 3. This and this will cancel. 3 into 3 is 9. 2 into 2 is 4. So it is 9 by 4. Ratio is 9 by 4. So we were supposed to find the ratio of the power consumption when all are glowing and when 2 from section A, 1 from section B is glowing. I hope you got the crystal clear feel of the bulbs, guys. So basically, when 3 bulbs are in series, their net power consumption will be this. And one more important thing, power supplied will be inversely proportional to the power rated. The one which has got more power rated will supply less power. Similarly, this is in case of parallel combination. Okay. This I am giving you as homework. This I am giving you as homework. Okay. Let's move on to the galvanometer. Let's move on to the galvanometer. Okay, let's move on to the galvanometer. See guys, what is a galvanometer actually? What is a galvanometer actually? We say galvanometer is a device. Galvanometer is a device. Okay. Which is used to detect the current. Which detects the current. And it can also measure the small range of currents. It can also measure the small range of currents. Okay. But the problem with the galvanometer is, first is its range is small range. Second problem with the galvanometer is its range is small. Second, it measures, it produces large error. It produces large error. Okay. Now, my dear NEET aspirants, what I'm trying to say in this particular case is I want you to understand here. So we convert galvanometer into an ammeter. Conversion of galvanometer into an ammeter. Sir, why is it like that? So that we get less error and we can measure large currents. Otherwise, galvanometer was fine. Now, how do we convert? See guys. Let me just show you over here. This is a galvanometer. G is the resistance of the galvanometer. Okay. And Ig is the maximum current which can flow through the galvanometer. Ig has some value. If you send more than this current, it is going to burn the galvanometer. This is the maximum current, so its range is less. So what we do is that we connect a resistance in parallel. This is what we call shunt resistance. This is what we call shunt resistance in parallel. Now, if you send a current, let's suppose I, it is very large. It will send only Ig through the galvanometer. Rest of the current will flow through this I minus Ig. It will flow through the shunt. Okay. It will flow through the shunt. So this is now what we call then ammeter. Ammeter is also a galvanometer, but good galvanometer. It produces less error and measure large currents. Now, if somebody says, what is the value of this shunt? Shunt is simply Ig into G, this current into this galvanometer resistance upon I minus Ig. This is what we call this is the value of shunt resistance. This is the value of shunt resistance. This is the value of shunt resistance. That's it. Like, let's take a look. A galvanometer of resistance 100 ohms. There is a galvanometer. It has got the resistance of value of G is 100 ohms. Okay. Measures 10 ampere current. It can only measure 10 ampere current. That means value of Ig is 10. Find the value of shunt resistance connected in parallel. We connected a shunt resistance in parallel. Okay. So that its range becomes 50 ampere means it must measure, I must be 50 ampere. You have to tell me the value of shunt. You'll say, sir, shunt is Ig into G upon I minus Ig. Ig is 10, G is 100 upon I minus Ig. That is 10, 50 minus 10, that is 40. This and this will cancel. 100 by 40. That is 25 ohms. So 25 ohms must be the shunt resistance over here. One more important question from AIPMT 2015. Now guys, take a look. In an ammeter, 0.2% of main current passes through the galvanometer. This is an ammeter. If I current is coming, only 0.2%, 0.2 I is passing through the galvanometer. So if out of 100%, 0.2% is passing through the galvanometer, we say 99.8% will be passing through the shunt. Obviously, sir. This is the value of I minus Ig. If the resistance of the galvanometer is G, resistance of the ammeter will be, means we have to find the resistance of the entire ammeter, not just shunt. First we'll find shunt, then we'll find the resistance of the ammeter. See guys, in this particular case, I want you to understand one thing over here. First, let's find shunt. Shunt is Ig into G upon I minus Ig. Ig, what is the value of Ig? That is 0.2 I, okay, into G upon I minus Ig. That is 99.8 I. Now, my dear NEET aspirants, S is equal to 0.2 I means, I and I will cancel. 0.2 means 2 divided by 10 into G upon 99.8 means 998 divided by 10. 10 and 10 will cancel. 2 ones are 2, 499s are. So this comes out to be G divided by 499. This is the value of shunt. Now listen to me very carefully. If you have got this resistance, this is the resistance of galvanometer, this is G. And this is shunt, its value is G by 499. You have to tell me the equivalent resistance of this ammeter, resistance of ammeter. That will be simply, guys, if you have two resistors in series, R1 and R2, simply remember R equivalent will be R1 plus R2. If you have a resistance something like this, another resistance something like this, this is R1, this is R2. Their equivalent resistance is going to be simply, directly remember, R1 R2 upon R1 plus R2. Okay, this is the equivalent resistance in parallel. Now here in this case, this resistance and this resistance are in parallel. Their equivalent resistance is going to be R1 R2, that is G into G divided by 499 upon R1 plus R2, G plus G divided by 499. So G into G becomes G square divided by 499 upon, this is 499G plus G, that will be 500G divided by 499. So G and this square, 499, 499. So this will be G divided by 500. This is the resistance of ammeter. This is the resistance of ammeter. Tell me guys, is this clear? Give me the signal guys, is this clear? Okay. Then conversion of galvanometer into voltmeter. Since ammeter is a device which measures the current, but voltmeter is a device which measures the potential difference. It measures the potential difference. Measures potential difference. Sir, what about galvanometer? Can that also measure the potential difference? Yes, but that produces the large error. That is the problem. That's why we are converting this into the voltmeter. To convert this into an ammeter, we connect the shunt resistance in parallel. But to convert this into a voltmeter, we connect shunt resistance in series. This is the galvanometer, shunt resistance in series. And if somebody says, what is the value of shunt here? V divided by Ig. V is the voltage across the galvanometer. Let me tell you how this comes. V is equal to I into R. Galvanometer resistance, shunt resistance. Total potential difference across the two is V. I is the current. So I, then we say R. R is G plus S, net resistance. From here, you can find the value of S. S is V by Ig minus G. Now, let's move on to this question. This question will clear the confusions out. A galvanometer has a coil of resistance 1 ohms. Okay. This G, it is 100 ohms. And gives a full scale deflection of 30 milliampere. Okay. So, basically, how much current can flow through it? That is what it is trying to say. That is 30 milliampere. If it is to work as voltmeter of 30 volt range, in order to use as a voltmeter, we need to connect a shunt resistance in series. And it says how much should be the range of this voltmeter. So it must be 30 volt. It is 30 volts. The resistance required added will be, means it is asking the value of shunt. So shunt resistance is simply V divided by Ig minus, I would say, G. V divided by Ig minus, I would say, G. Now guys, this shunt resistance will be V divided by Ig. V is 30 divided by Ig is 30 milliampere. So that will be 30 into 10 raised power minus 3. Okay. Then we say minus G. G is 100. So this and this will cancel. Take this in the numerator. S will be equals to 10 raised power 3 minus, we say, 100. 10 raised power 3 is 100. 100 minus 100 is 900 ohms. Okay. Because this is in milliampere. Milli means 10 raised power minus 3. You have to convert this into amperes. Then comes the last topic of this chapter. That is what we call meter bridge. So basically we converted galvanometer into ammeter as well as voltmeter. So galvanometer measures both potential difference and current, but it produces error. So to make a good device which can measure the current efficiently, we converted it to the ammeter. Then to make a good device which can measure the potential difference efficiently, we converted it into a voltmeter. Now meter bridge. We say meter bridge is an instrument used to measure the unknown resistance. And it is the concept based upon the concept of Wheatstone bridge. It is based upon the concept of Wheatstone bridge. See Wheatstone bridge. Wheatstone bridge. See the concept of Wheatstone bridge. See, my dear NEET aspirants, when it comes to the Wheatstone bridge, you have a resistance over here. You have one resistance over here. You have one more resistance over here. You have one more resistance over here. And there is a resistance in between also. Okay. So, my dear NEET aspirants, this is R1, this is R2. This is R3, this is R4. Okay. In this concept of Wheatstone bridge says us, and this is R5. This concept of Wheatstone bridge says us, if R1 divided by R2 this divided by this comes out to be equal to R3 divided by R4. This resistance by this resistance. Ratio of these two is equal to ratio of these two. Then no current flows through, then no current flows through R5. If no current flows through R5 means potential difference across R5 is same. So we can remove it. So remove R5. Or you can say it's reverse also. If no current flows through this, if no current flows through this R5, if no current flows through this R5, then R1 by R2 is equal to R3 by R4. Then R1 by R2 is equal to R3 by R4. If current through this middle resistance is 0, then you can say R1 by R2 will be equals to R3 by R4. This is the concept of Wheatstone bridge. Now, this is a device which is used to measure unknown resistance, value of the resistance. Like, you will be given a known resistance over here. You will be given an unknown resistance over here. This you guys are supposed to find out its value. Okay. Now, my dear NEET aspirants, there is a galvanometer connected to this. This is a galvanometer. And there is this meter wire. Meter wire means 100 centimeter long. And there is this jockey connected. Now, my dear NEET aspirants, listen to me very carefully. What we are supposed to do over here. And this wire has got resistance R and its length is L. Okay. If I say what is the resistance of its unit length? At total resistance is R, total length is L. What is the resistance of unit length? You say, sir, resistance of the unit length will be total resistance divided by total length. This is called resistance per unit length. Resistance per unit length. So this R will be equals to actually lambda into L. R will be equals to lambda into L. R will be actually equal to lambda into L. Okay. Now guys, you have this jockey. Now in this particular case, we keep on sliding this jockey. Sir, why do we keep on sliding this jockey? Until we get the balance point. What is the balance point? We keep on sliding the jockey until we get the balance point. Balance point is that point. We say if you achieve the balance point at this point, then we say in that case, current through the galvanometer will be 0. Because on this point, there will be some point when current through the galvanometer will be 0. You will have to find that. And then, my dear NEET aspirants, that will be considered a balance point. And my dear NEET aspirant, let's suppose the balance point is at L1. It is at L1. So could you please tell me how much this from here to here it is L1 distance. This will be how much? 100 minus L1. Now let's find the resistance of this. Let's find the resistance of this L1. I would say resistance of this L1. Resistance of L1. So a resistance is simply going to be that is lambda into L. So that is going to be lambda into L1 and lambda into length. Multiply the length of that and resistance of 100 minus L1. So that is going to be lambda into 100 minus L1. Lambda into 100 minus L1. Okay. Sir, you look handsome without specs. Thank you. Okay. Thank you. So this is the resistance of this one. That is lambda into L1. Resistance of this will be lambda into 100 minus L1. Okay. So now, my dear NEET aspirants, why did we actually get the balance point? The logic says you are getting the balance point only when this resistance divided by this resistance is equal to this resistance by this resistance. Because at some point, this resistance ratio by this resistance will be equal to this by this. Then only you are getting balance point. And at that point, we say current through this will be zero. Now it will behave like a Wheatstone bridge. Now it will behave like a Wheatstone bridge. First resistance, second resistance, third resistance, fourth resistance. See, this P, this Q, this lambda into L1, this lambda into 100 minus L1. And it says current in the middle resistance in this galvanometer is zero. So if current through the middle resistance is zero, can I not say P divided by lambda into L1 will be equals to Q divided by lambda into L1? Lambda into 100 minus L1. This lambda and lambda will be cancelled out. So P by L1 is equal to Q by 100 minus L1. This is the equation of meter bridge. Now see, by using this equation, we'll find this X. It says you have a meter bridge over here. Balance point is at 20 centimeters. You have to find the value of this resistance. You'll be simply saying 5 divided by, guys, P divided by L1 upon Q divided by 100 minus L1. 5 divided by L1, that is 20, is equal to Q is X divided by 100 minus L1. 100 minus 20 is 80. This and this will cancel. 2 1s are 2 4s are 8. 5 into 4, X is 20 ohms. That's what I said. This helps us to find the unknown resistance. With this, we are done with the chapter second. Tell me, guys, is this clear? Let's start with magnetism. These are the big chapters, guys. It took us a lot of time, actually. Do smash the like button if you're not liked the session yet. Shall we move on to the next? Shall we start? Okay. Let's go, guys. Let's finish this chapter. Let's finish this chapter. Magnetic effects of current. Now, guys, first and the foremost topic that we have in this one is Biot-Savart's law. What does Biot-Savart's law actually say? If you have a current carrying wire, guys, see, directly remember, if there is a wire in which current is flowing, it produces the magnetic field around it. A wire in which current is flowing produces the magnetic field around it. Now, my dear NEET aspirants, if I say consider a small element over here, small element means IDL, small current carrying element, small element of the wire. Find the magnetic field due to this small current carrying element at r distance, which is at an angle theta. Okay. So magnetic field due to the, I'll write over here, magnetic field due to a small current carrying element at r distance. It is not the magnetic field due to the entire wire. Keep that thing in your mind. Magnetic field due to a small current carrying element. Small element. That will be dB. Like you have a magnet. Guys, if I say you have a magnet creates magnetic field around it, in which if you place a coin, it will be attracted. Similarly, a current carrying wire also produces the magnetic field around it. So right now, I would say what is the magnetic field due to this current carrying element? So that is dB is equal to mu naught. dB is equal to mu naught divided by 4 pi. Then I would say IDL sine of theta divided by r square. This is the magnetic field due to a current carrying element. This is the magnetic field due to a current carrying element. Its vector form will be dB is equal to mu naught divided by 4 pi. Mu naught divided by 4 pi. Then we say IDL vector cross R vector divided by R cube. This was asked in NEET 2020. This was asked in NEET 2020. Okay. So this is the vector form of magnetic field due to a current carrying element at r distance. Okay. Direction of magnetic field. Okay. First of all, let me just tell you this. Magnetic field due to finite wire. Guys, if you have to find the magnetic field due to the entire wire, Biot-Savart's law only tells us magnetic field due to a small element. If you have to find the magnetic field due to the entire wire, you say, sir, magnetic field we represent with B. It is mu naught I divided by 4 pi R. Then I can say sine of I is the current, R is the distance at which you have to find the magnetic field. Then I would say sine of theta 1 plus I would say sine of theta 2. This sine of theta 1 plus sine of theta 2. This is the magnetic field. This is the magnetic field This is the magnetic field due to the entire wire. And how do you find the direction? See guys, how do you find the direction? Place your thumb along the direction of current, curl your fingers at that point. And curling my fingers gives you the direction of inward. So inward we represent with this cross. This is called inward. How do you find the direction of the magnetic field? Place your thumb along the direction of current. Then curl your fingers. That will give you the direction of magnetic field. Like place your thumb along direction of current. From this side, magnetic field is outward. Outward we represent with dot. It is outward. And from this side, place your thumb along direction of current, curl your fingers. From this side, it is inwards. Inwards we represent with cross. Inwards we represent with cross. Magnetic field due to an infinite wire. Guys, in case of infinite wire, it is going till infinity. How do you define theta 1 and theta 2? How do you define theta 1 and theta 2? You join this point with one end of the wire. This is going to be theta 1. You join this point with another end of the wire. This is going to be theta 2. So what I can say in this particular case, my dear NEET aspirants, we can say in this particular case, theta 1 is 90 and theta 2 is 90. Theta 2 is 90. Because you are joining this point. You are not joining this point over here. Its end is at infinity. So theta 1 will be infinite, 90. Okay, theta 2 will be 90. So my dear NEET aspirants, magnetic field will be mu naught I divided by 4 pi r. Then we say sine of theta 1, that is sine of 90 plus sine of 90. So this is sine 90 plus sine 90. 1 plus 1 is 2. This is mu naught I divided by 2 pi r. Because that 2 will be cancelled with this 2, na? So 2 pi r. And magnetic field is inversely proportional to r. So graph is going to be rectangular hyperbola. In case of a finite wire here, theta 1 is 0 degrees. Why? Because this is r, this is r. If you join this with one end, that is here. Semi-infinite means in which one end is known. Another end is at infinity. So join this with one end of the wire. So theta 1 will be 0 and theta 2 in this case, or we say theta 1 will be 90. Theta 2 in this particular case will be 0. What is going to be the magnetic field? That is mu naught I divided by 4 pi r. Then I would say sine of 90 minus sine of 0. Sine 0 is 0, sine 90 is 1. So magnetic field will come out to be mu naught I divided by 4 pi r. Mu naught I divided by 4 pi r. Find the magnetic field in this case. You are supposed to find the magnetic field in this case. One end is at infinity. Okay, another point is here. This is r. R is always the perpendicular distance. But with another end, it is making the angle theta 2. This is also considered as semi-infinite. Because in this case, theta 2 is not 0. It is theta 2. So I would say magnetic field here will be mu naught I divided by 4 pi r. Then I would say sine of 90, because theta 1 is 90, plus sine of theta 2. This angle is given as theta 2. So this will be simply mu naught I divided by 4 pi r 1 plus sine of theta 2. Find the magnetic field at the center. You are supposed to tell me what is the magnetic field at the center in this particular case. Okay? At this point, center. Due to the square loop. See guys, you do one thing. You find magnetic field due to one wire. Then multiply with 4. Because whatever is the magnetic field due to this wire, same will be the magnetic field due to this, due to this, due to this. Even direction would be also same. Place your thumb along direction of current, curl your fingers inward. Place your thumb along direction of current, curl your fingers inward. Inward. Due to all the wires, magnetic field is same. So magnetic field due to one wire. Magnetic field due to one wire. So I can say, let's consider this wire, this one. So this is going to be the perpendicular distance r, and this will be L by 2. R is L by 2. And join this with one end, join this with another end. Everybody knows this total angle is 90. So this is theta 1, this is theta 2. So we say theta 1 is 90, sorry, 45, and we say theta 2 is also 45. And R in this case will be L divided by 2. R in this case will be L divided by 2. So when it comes to the magnetic field, it is mu naught I divided by 4 pi R. R will be L by 2. Then I would say sine of theta 1 is 45, sine of 45. Then plus sine of theta 2, that is also 45. Now tell me guys, sine 45 is 1, sine 45 is 1. So this will be 2 1s are 2 2s are 4. So magnetic field will be mu naught I divided by 2 pi L. This is 1 plus 1, that is 2. So this 2, sine 45 is 1 by root 2 plus 1 divided by root 2. Sorry. So magnetic field in this case will be mu naught I divided by 2 pi into L. So this will be 2 divided by root 2. This 2 and this 2 will cancel. So magnetic field will be mu naught I divided by root 2 pi into L. Root 2 pi into L. This is magnetic field due to one wire. We have 4. So magnetic field due to 4 wires. B net. That will be 4 times magnetic field due to one wire. Mu naught I divided by root 2 pi into L. Now multiply with root 2 and divide with root 2. Okay. So root 2 into root 2 becomes 2. So that 2, 2s are 4. This is 2. 2 1s are 2 2s are 4. So it comes out to be 2 root 2 mu naught I divided by pi into L. This is the net magnetic field. Is this clear? Let's move on to the next one. Okay. Magnetic field due to a ring on its axis. This is a ring in which current is flowing. Guys, from now onwards, you will remember one thing only. If there is a current carrying wire, if it is straight, if it is curved, If it is circular, it will create magnetic field. Since this is a circular current carrying loop which has radius r, current is flowing I, it will create magnetic field. Okay. So how much magnetic field it is going to create? It is mu naught I into r square upon 2 into r square plus x square whole raised power 3 by 2. R is the radius of this ring, I is the current, x is the distance where you have to find the magnetic field. Okay. And we say at center, what is the value of x? If you move towards the center, value of x is 0. Put x is equal to 0 over here. What is going to be the magnetic field? Magnetic field will be mu naught I into r square divided by 2 into r square plus x square. X will be 0, so r square whole raised power 3 by 2. 2 and 2 will cancel. This is r cube. So this will be mu naught I into r square divided by 2 into r cube. R square and cube will cancel, so it will be mu naught I divided by 2r. So this is the magnetic field at the center of the ring. This is the magnetic field at the center of the ring. This is the magnetic field at the center of the ring. Okay. Mu naught I divided by 2r. Mu naught I by 2r. This is the magnetic field at the center of the ring. Okay. Now guys, one more important thing over here. This was the magnetic field at the center of the ring over here. Okay, magnetic field due to a segment of ring. Segment of ring means, I told you, if this is a complete ring, this is a semicircular ring, this is what we call chord. If I say you cut some portion of the ring over here, some portion of the ring, this is what we call segment. Segment simply means some portion of the ring. Segment simply means some portion of the ring. Okay. So what I can say, magnetic field due to this segment of the ring will be B is equal to mu naught I by 2r theta by 2 pi. Mu naught I by 2r theta divided by 2 pi. Okay. Theta is the angle over here between this r and r. So join this point with one end of the ring, this will be radius r. Join this point with another end of the ring, this will be r. So angle between r and r will be theta. Okay. Now in case of semicircular ring, we say what is the value of theta? That is 180. Theta is 180. So what is the magnetic field? Use this general formula only. Mu naught I by 2r theta by 2 pi. Mu naught I divided by 2r theta by 2 pi, that is pi divided by 2 pi. Pi and pi will cancel, so magnetic field will come out to be mu naught I divided by 8r. Now, in case of a straight wire, I have already told you how do you find the direction. Place your thumb along direction of current, curl your fingers. But here, curl your fingers along the direction of current. This is how you find the current. Curl your fingers along current. Thumb gives the direction of magnetic field. Thumb gives the direction of magnetic. Curl your fingers along the direction of current. Thumb is pointing outward. So magnetic field due to this will be outward. Outward is dot. If you have a chord, what is the value of theta over here? Theta is pi by 2. What will be the magnetic field? That is mu naught I divided by 2r theta by 2 pi. Theta is pi by 2 divided by 2 pi. So pi and pi will cancel. 2 into 2 is 4. 4 into 2 is 8. 4. Okay, 4. Okay. So 2 into 2 is 4, 4 into 2 is 8. So magnetic field due to this will be mu naught I, this divided by 8r. And if you find the direction, curl your fingers along direction of current, thumb is pointing outward. So it is outward. Is this clear? Give me the signal in the chats. Come on. Quick. Quick. Find the magnetic field at the center. This is a structure. You are supposed to tell me what is the magnetic field at this point, at the center. Okay. See, guys, this is a semicircular. This structure is made up of one, two, I would say 3 and 4. Guys, always remember this particular point. Let's suppose there's a wire. If I say what is the magnetic field due to this wire, if the point is along the axis of the wire, we say magnetic field will be 0. If the point is along the axis of the wire, magnetic field will be 0. So this is 3 and 4. Can I not say this point is along the axis of this wire and this wire? So magnetic field due to 3 will be equals to magnetic field due to 4, and that will be 0. Without a shadow of doubt. Without a shadow of doubt. Okay. Now magnetic field will be due to this. Let's find the direction of magnetic field. Curl your fingers, thumb is pointing inwards. Magnetic field is inward. Okay. Magnetic field due to this. Curl your fingers along direction of current, thumb is pointing inwards. So both magnetic fields are inwards. So I would say net magnetic field will be B1 plus B2. Because due to both, magnetic field is inward. So since both are semicircular rings, so due to this, it will be mu naught I divided by, what is the magnetic field due to a semicircular ring? Mu naught I by 4R. So mu naught I divided by 4. Okay. I'll write due to 1. What is the radius of this? Mu naught I by 4 into 2R. Because its radius is not R, it is 2R. Then plus mu naught I divided by 4 into R. Radius of this one is R. That's it. Take this mu naught I divided by R common. Divided by 4R common. What remains here? 1 by 2 plus 1. 2 into 1 is 2 plus. This will be 3 divided by 2. So this will be 3 by 8. Mu naught I divided by 4R. And what is the direction? Inwards. Because direction of both is inwards, so direction of net will be also inwards. Okay, what is the net magnetic field at the center in this particular case? Guys, tell me, what is the magnetic field due to this at the center? Tell me, quick. Just a second, guys. Tell me, guys. Now guys, magnetic field at point O. What is the net magnetic field at point O? This is a semicircular wire. Due to this semicircular wire, place your thumb along direction of current, curl your fingers. It will be inward. So magnetic field due to this is going to be inward. Okay. And my dear NEET aspirants, in this particular case, what I can say, due to this magnetic field will be inwards. Okay, what about this? Place your thumb along direction of current, it will be inwards. Curl your fingers, it will be also inwards. So magnetic field due to all the three is inwards. I can say net magnetic field is B1 plus B2, I would say plus B3. This is going to be the net magnetic field. Now, due to a semi-infinite wire, I have told you recently, due to a semi-infinite wire, what is the magnetic field? Mu naught I by 4 pi r. And due to a semicircular wire, it is mu naught I by 4 r. So it is mu naught I divided by 4 pi into r. This r. And this is also semicircular wire. So plus, sorry, this is a semi-infinite wire. This is semicircular wire. Mu naught I divided by 4r. Plus, due to this, mu naught I divided by 4 pi into r. Now do the calculation further from your end. Take this mu naught I by 4r common. Rest you can do it from your end. Ampere circuital law. Ampere circuital law. What does Ampere circuital law actually mean? Guys, Ampere circuital law simply helps us to find the magnetic field. It helps us to find the magnetic field. But here I'll show you how do we apply the Ampere circuital law. Here I'll show you how do we apply the Ampere circuital law. See guys, this is a wire. If you have to find the magnetic field at this point, r distance, point P. At r distance at point P, if you have to find the magnetic field. Now, my dear NEET aspirants, what I'm trying to say in this particular case is, if you want to find the magnetic field at point P, what I would recommend you over here is, you do one thing, you consider a small element over here, that is dl. Okay. If you have to find the magnetic field due to this wire at r distance, first of all, draw a loop. This is called Amperian loop, which is passing through that point. You need to draw the loop in such a way that should pass through that point. It must pass through that point. Okay. And assume magnetic field at this point is B. Assume magnetic field at this point is B. Okay. Assume magnetic field at this point is B. Now, my dear NEET aspirants, we say, if you have to find a magnetic field due to this wire at r distance at this point P, you draw an Amperian loop, the imaginary loop such that it passes through the point. Take a small element of the loop as dl and imagine magnetic field at this point is B. Then take close line integral of B and dl, make it equal to mu naught times of I enclosed. This is what we call Ampere circuital law. Ampere circuital law simply says that if you have to find the magnetic field at a point, you draw a loop at that point which will pass through that point. Then assume magnetic field at that point is B. Then consider a small element dl of that loop. Do the integration of B and dl. Make that equal to mu naught times of I enclosed. I enclosed means that current which is enclosed in the loop, which is present in the loop. This one. Okay. And by the way, value of mu naught by 4 pi is 10 raised power minus 7. So mu naught will be equals to 4 pi into 10 raised power minus 7. Okay. Then it says if B and DL are in the same direction, then take the current as positive. And if B and DL are in the opposite direction, then take current as negative. Let me show you what he is trying to say. Apply the Ampere's law. What does Ampere's law say? Closed line integral B dl will be equals to mu naught times of I enclosed. Okay, I enclosed. Okay. So then we can say closed line integral B dl will be equals to mu naught times of enclosed current. First and the foremost thing you guys are supposed to tell me in this particular case, what is the enclosed current? Is this I3 enclosed? Not at all, sir. Because it's out of the loop, this one and this one. So I would say this is I1 and I would say this is I2. Now the point here is, if you take a look, this is the direction of DL given in the question. This is the direction of DL given in the question. If I say, what is the direction of magnetic field due to this wire? Place your thumb along direction of current, curl your fingers. So direction of magnetic field due to this wire will be something like this. This is B1. This is the magnetic field due to I1. This is the magnetic field due to I1. Now see, if B1 and DL are in the same direction, yes, consider the current as positive. Now what is the direction of the magnetic field due to this wire I2? Place your thumb along direction of current, curl your fingers. So it will be opposite to this. So magnetic field due to wire 2 is opposite to DL. DL direction will be given in the question. So consider this current as negative. Okay. Like if I say, question is, apply Ampere's law. This is I1 is cross, I2 is dot, and this is the direction of DL, and this is I3. First of all, you tell me what is the enclosed current over here, I1 and I2. So if I use the Ampere circuit law, that is BDL, it will be mu naught times of I enclosed. Okay, so it will be mu naught times of I enclosed. Enclosed current is simply I1 and I2. I1 and I2. Now you have to consider which one is positive, which one is negative. Place your thumb along direction of current I1. Curl your fingers. So this is the direction of magnetic field due to I1. B and DL are opposite, so this current will be negative. Then place your thumb along the direction of current I2. Curl your fingers. So I would say in this particular case, this is B2. Now B2 and DL are in the same direction, so this will be positive. I hope this is crystal and clear. How do we apply the Ampere's law? Then, my dear NEET aspirants, you have over here a concept that is magnetic field due to a hollow cylinder. If this is a hollow cylinder, always remember, in case of hollow cylinder, current flows through the surface. Current flows through the surface. Because it is hollow from inner side, so current cannot flow from the inner side. So current inside will be zero because it is hollow. So matter is present on the surface only, so current flows through the matter only, na? Okay. Now, my dear NEET aspirants, magnetic field inside will be zero. Why? Because there is no current inside, so magnetic field inside is zero. Magnetic field outside will be mu naught I by 2 pi r. Because outside at what distance? Outside at, I would say, small r distance. And this is going to be the radius capital R. And even I would say in this particular case, at surface, what is the value of small r? That is capital R. So magnetic field on the surface will be mu naught I divided by 2 pi into capital R. Guys, this is the same as infinite wire because this is also infinitely long. Okay. So from a very large distance outside, we consider a hollow cylinder as a wire. Like we considered sphere as a point charge. Similarly, we'll be considering this as a wire. And this is the graph. Guys, inside magnetic field is 0 till surface. And then outside magnetic field is inversely proportional to R. Here, this is R is equal to 0. From surface from center to surface, this is the magnetic field. From center to surface, this is the magnetic field. And this is the magnetic field outside. B is inversely proportional to R. This is inside. This was asked in NEET 2021. Then magnetic field due to a solid cylinder. Solid cylinder is filled from inner side. So in this particular case, current will be flowing through the cross section. This is the current flowing through the cross section. And my dear NEET aspirants, you have to tell me what is the magnetic field outside. You have to tell me what is the magnetic field on the surface. You have to tell me what is the magnetic field inside. Magnetic field outside, magnetic field on the surface, magnetic field inside. So when I say magnetic field inside, guys, inside magnetic field right now, it will not be zero. It will be equals to mu naught I into R. R is the distance inside where you have to find the magnetic field. Okay. Okay. And divide by 2 pi into capital R square. Capital R is the radius. So outside it will be same mu naught I by 2 pi R. And when it comes to the surface, at surface, what is the value of small r? That is capital R. Put it over here. Magnetic field is going to be mu naught I divided by 2 pi into capital R. 2 pi into capital R. Now see, magnetic field inside you can clearly see is directly proportional to small r. This is magnetic field inside is directly proportional to small r. Magnetic field outside is inversely proportional to small r. So magnetic field inside, this is inside, is directly proportional to small r. This is outside. It is inversely proportional to small r. Inside it is directly proportional. Outside it is inversely proportional. Okay. I hope this is clear. This graph is also very important. This graph is also very important. Okay. Now, magnetic force. Magnetic force. See guys, if a charge is placed in a magnetic field and is given some velocity, magnetic force acts on it. Like you said previously, if there is an electric field in which a charge is placed, it experiences force, that is Q times of E. This is electric force. So even if you place the charge at rest in the electric field or if it is moving, force will act in both the cases. Okay. But in this case, my dear NEET aspirants, this is the magnetic field. Cross magnetic field means inward. And this is the charge. It is moving in the upward direction. Whenever a charge moves inside a magnetic field with certain velocity, with some velocity, it experiences force. It experiences force. How much is that force? Q into V cross B. Q is the charge. Q is the charge. Q is the charge. Hey, wait, now I'm making you understand. Wait. So now this charge is placed inside a magnetic field. It is moving with velocity V. So how much is the force acting on this charge? Q into V cross B, or you say QVB sine theta. Theta is the angle between velocity and magnetic field. So what I'm trying to say is that if a charge is placed in a magnetic field and is given some velocity V, it experiences magnetic force. FB is the magnetic force. That magnetic force is QVB sine theta, or Q into V cross B. Like over here, this is the magnetic field in the forward direction. This is the charge. It is having the velocity in the same direction. What is the angle between velocity and magnetic field here? That is 0. Now, how much will be the magnetic force? QVB sine of 0. So that is 0. Means if velocity and magnetic field are parallel, no force will act. Yes, no force will act. If theta is 180, This is the charged particle. It is moving in the forward direction. Magnetic field is backward. In this particular case, what we can say, magnetic force will be Q VB sine of 180. Sine 180 is also 0. So magnetic force is 0. Now, this is the question that we have over here. This is the question that we have over here. A charged particle of specific charge per unit mass. So Q divided by M is given as 0.2 Coulomb per kg. Has a velocity in this particular case is given as, that is 2I cap minus 3J cap. Okay. At some instant in a uniform magnetic field. So magnetic field in this case is given as, I would say 5I cap plus 2J cap. Okay. Find the acceleration of the particle at this time. Find the acceleration of the particle at this time. You have to tell me acceleration of the particle. Guys, see, when it comes to the acceleration is force upon mass. So first you need to find force. Then you can find this. What is the force acting on the charge? That is Q into V cross B. Find V cross B, velocity cross B. So V cross B, let's find V cross B. That is cross product of two vectors. How do you find the cross product of two vectors? Listen carefully. You say, sir, you write I cap over here, J cap over here, K cap over here. Then coefficients, you have to find V cross B. First, you'll be writing the coefficients of V. What is the coefficient of I in the V? That is 2. Coefficient of J is minus 3 and this is 0. K is not given, it is 0. Here it is 5 and 2. So it is 5 and 2 and this is 0. Now you have to solve it. Solve this for I cap. First, you'll be mentioning I cap over here. Now hide that column in which I is present, hide that row in which I is present. First column, first row. Now this 3 into 0 is 0, minus 2 into 0 is 0. So hide that column in which I is present, hide that row in which I is present. Rest of the figures you need to cross. Then minus J cap. In front of J you need to put minus. Hide that column in which J is present, hide that row in which J is present. So rest of the elements you need to cross. So 2 into 0 is 0, minus 5 into 0 is 0, then plus K cap. Hide that column in which, hide that row in which K is present, hide that column in which K is present. So 2 into 2 is 4, minus 5 into minus 3 is minus 15. Minus 15. Now guys, this is minus into minus is plus, 15 plus 4 is 19. So this will be 19 K cap. This will be 19 K cap. That is V cross B. That is V cross B. Now guys, when it comes to the acceleration is force upon mass. And how much is force? How much is force? That is Q into V cross B divided by mass. So acceleration will be, what is Q by M guys? Q by M is 0.2. Okay. And V cross B is 19 K cap. Okay. So this acceleration will come out to be, 19 into 0.2, that is 3.8 meter per second square K cap. This is the acceleration. This was a good question actually. Tell me, is this clear? Okay. Okay. Now guys, take a look in this particular case. Listen to me very carefully. Case 3. Case 3. Guys, let's take a break, huh? Break of 10 minutes. Break, it is 9:01. 9:12 I'll be back. Okay. Break is till 9:12 only. Now guys, take a look. Let's suppose this is a charged particle. Okay. It is moving with the velocity v. Okay. At an angle of 90 degrees. Listen to me very carefully. Angle between velocity and magnetic field is 90. Magnetic field is inward, velocity is forward. How much is the angle? 90. Whenever the charged particle enters the magnetic field perpendicularly, okay, I would say here Q enters magnetic field perpendicularly. In that particular case, it follows the circular path. And if somebody says, what is the radius of this circular path? What will be the radius of this circular path? This radius will be mv. M is the mass of this charged particle. Okay. V is the velocity. Q is the charge. B is the magnetic field. mv divided by qb. And if somebody says the radius in terms of kinetic energy, you can say under root of 2 mke divided by qb in terms of kinetic energy. Okay. And my dear NEET aspirants, if somebody says what is the velocity? Velocity will be qbr divided by m. With what velocity it is revolving. And if somebody says what is the time period? That is 2 pi m divided by qb. Time period means in how much time it will complete one cycle. This is the time period. This is the radius in terms of kinetic energy. This is the radius in terms of momentum, mass into velocity. This is the velocity of the charged particle. Okay. And one more expression we also define over here. Radius in terms of, I would say, potential difference. That is 2m q delta v. Delta v is the potential difference divided by qb. This is the radius in terms of potential difference. Remember this one also. And this is the radius in terms of kinetic energy. Okay. Before this, let me show you this particular question. See the question. A proton and an alpha particle is accelerated through same potential difference. Okay. In a region of uniform magnetic field. Guys, see. It says a proton and an alpha particle is accelerated through same potential difference in a region of uniform magnetic field with their velocities perpendicular to this. So they are entering this magnetic field. Let's suppose this is the velocity, this is the velocity perpendicular to the magnetic field. Compare the radii. We have to check the radii. Guys, which expression of radii you will pick over here? Which expression? Sir, obviously the potential energy one. So potential difference one. R is equal to 2m q delta v divided by qb. So I would say R is equal to under root of 2m q delta v divided by qb. Because potential difference is given. Now, my dear NEET aspirants, whatever is the same for both, remove that. Proton and alpha particle. Guys, when it comes to the proton, when it comes to the alpha particle, you say charge is E, you say charge is 2E. You say mass is M, you say mass is 4M. 4 times mass of proton. Charge is different, mass is different. Both are placed in the same magnetic field. Magnetic field is constant. Both have got same potential difference. Potential difference is constant. Now only M and this remains. So R is proportional to under root of MQ divided by this Q. Now do one thing, rationalize it. So root Q and root Q. So root Q into root Q becomes Q. This Q will be cancelled with this Q. So R will be proportional to under root of M remains over here divided by this root Q. This is the expression that we got for radius. Now what I can say in this particular case is a radius of proton divided by radius of alpha particle. That is mass divided by charge. Mass of this is E, charge is M upon radius of alpha particle is mass of charge of this is, okay, mass by radius we are supposed to. Under root of M divided by E upon under root of 4M by 2E. 4m divided by 2e. 4m divided by 2e. Radius of proton divided by radius of alpha particle. It will be simply, guys, this will be under root of m divided by e into under root of 2e divided by 4m. Okay. Now this m, this e. So it is going to be, that is 1 divided by, or we say root 2 divided by 2. Because root 4 is 2, this is root 2 divided by 2. This will be the radius. Find the instantaneous direction of the force in the following cases. Find the instantaneous direction of the force in the following cases. See guys, how do we find the direction of magnetic force? Do one thing. What is the value of force? F is equal to Q into V cross B. Q into V cross B. What you are supposed to do in this particular case, my dear NEET aspirants, in this case, it is V cross B. Okay. Place your thumb along the direction of V. Place your thumb along the direction of V. Okay. Place your thumb along the direction of V. It is V cross B, na? Okay. Place your thumb along the direction of V. Here V is downwards. So I am placing my thumb along the direction of V. Okay, ignore this as of now. Wait. Because charge is negative. Let's talk about this. Place your thumb along the direction of V. This is V. Right hand. This is right hand palm rule. Right hand palm rule. And then fingers along the direction of magnetic field. Thumb along the direction of velocity. Fingers along the direction of magnetic field. This is what we call palm. Palm is facing inwards. So force on this charge will be inwards. Cross means inward. If the charge would have been negative over here, then I would have said the force will be outward, just opposite the direction. See guys, here charge is negative. Consider it positive as of now. Place your thumb along the direction of velocity downward and fingers along the direction of magnetic field. Magnetic field is outward. This palm is facing towards the right. But in this particular case, my dear NEET aspirants, since the charge is negative, so consider the force in the opposite direction. Towards the right. This is facing left. So force will be left towards the right. I hope you are getting me. Guys, you have to find the force according to the positive charge. So we say place your fingers along the direction of velocity. Place your thumb along direction of velocity. Fingers along magnetic field. Palm is facing towards left. So force will be right. Why force will be right? Because charge is negative. Okay, in this one. Place your thumb along the direction of velocity. Velocity is inward. Fingers along the direction of magnetic field. Magnetic field is forward. Palm is downward. Force in this case is downward. This is magnetic force. Let's talk about this one. Place your thumb along the direction of velocity inward. Fingers along the direction of magnetic field upward. Palm is facing towards the right. But since the charge is negative, I'll say force will be towards left. I hope you are getting me. This is right hand palm rule. This is what we call right hand palm rule. Force on a wire placed in a magnetic field. Guys, see. This is a magnetic field over here, B, in which you have placed a wire which is having the length L, current I. We say whenever you place a current carrying wire in the external magnetic field, it experiences force. And that force will be equals to I into L cross B. I is the current flowing in the wire. L is the length of the wire. B is the magnetic field. And L cross B is LB sine theta. Because A cross B is AB sine theta. L cross B is LB sine theta. So this will be ILB sine theta, where theta is the angle between L and B. Where theta is the angle between L and B. So this is a wire, my dear NEET aspirants. If you place it in the external magnetic field, force on this wire will be I into L cross B. Okay. And the direction of that force will be, guys, again, place your thumb along the Place your thumb along the direction of this length, okay, or along the direction of current, and fingers along magnetic field. Place your thumb along the direction of current and fingers along magnetic field. Palm is facing towards left. Palm is facing towards left. Place your thumb along the direction of current. Place your thumb along the direction of current. Fingers along magnetic field. Palm is facing towards left. That is the direction of magnetic force. That is the direction of magnetic force. Let's suppose a rod is placed something like this. What is the angle between length and magnetic field? That is 0. Length and magnetic field are parallel. So ILB sine 0, 0. So force in this case will be 0. Force in this case will be 0. Okay, let's talk about this question, guys. Let's talk about this question. In the figure, this is the figure, my dear NEET aspirants here. You have to tell me what is the force on this one. See, this is a loop. So force on the upper portion of the wire, force on the lower portion of the wire. Directly remember. In this particular case, force will act on this one also and force will act on this one also. Now, if I say what is the force acting on the upper portion? What is the value of force? F is equal to ILB sine of theta. Now, what is the length you are supposed to consider for this? Consider its effective length. Its effective length will be join one end with another end. This is the effective length. That is, this is R. This is R. R plus R is 2R. So force in this case will be, that is I into 2R. Then we say B. 2R into B. Sine of, what is the angle between this effective length? This is L effective. And magnetic field, that is 90. Sine 90 is 1. So F will be equals to, that is 2IBR. This will be force on this one, F1. Let's find the direction. This is the direction of current. Here also in the effective length, direction of current will be same. Place your thumb along the direction of current. Fingers along magnetic field. Palm is facing upwards. So on this, force will be upward. That is F1. This is F1. Now let's find the force on this F2. On this wire. So it will be I, L, L. What is the length of this? This is R plus R, 2R. This is 2R. Then we say sine of. Guys, what is the angle between this L and B? That is 90 again. So this will be I, 2R into B. Okay. Now tell me what is the direction of force over here. Guys, place your thumb along the direction of current. Current is this. Fingers along magnetic field, palm is downwards. So on this force, F2 is downwards. This is F2. Now, don't you think that F1 and F2 are same, equal? But direction is opposite. So direction is opposite. So what is going to be the net force in this case? Net force is 0. Let me just tell you the trick from now onwards. If you ever see the direction is in the loop, like CCC, direction is clockwise, here clockwise only, or if it would have been anti-clockwise only, not like this, clockwise, this is anti-clockwise. So it is clockwise only, direction in loop. In that case, net force will be 0. Always remember, in that case, net force will be 0. What about here? Here, force on this will be F1. And F1 you recently got. That is 2IBR. Force will be same. But on this portion also, force will be in the upward direction, F2. Check. Place your thumb along direction of current. See, this is the current. Fingers along magnetic field, palm is upwards. So here, if I say net force, guys, net force in this case will be, I would say, F1 plus F2. So that will be F1 plus F2. F1 and F2 are same in magnitude wise, but direction is opposite. In that case, here direction is same. So 2 times of 2IBR. So that is 4IB into R. So 4. What is the value of current? Current is 2 ampere. Radius is 1. Magnetic field is 1. This is 2. This is 1. This is 1. So this will be 8 Newton. So force on this loop will be 8 Newton. Force on this loop will be 0. Force on this loop will be 0. Okay. Now guys, one more important thing. There is an infinitely long wire, it is having the current I. There is a finite wire, it is having the length L, it is having the current I2. They are placed at R distance. Sir, will these two, okay, let me tell you, force on wire I2 due to wire I1. What is the force on this wire I2 due to wire I1? This will be the force. Mu naught I1 I2 divided by 2 pi R into L. This is the total force on the wire I2. Mu naught I1 I2 is the current in first, current in second. L is the length of second, 2 pi R is the distance between the two. If I say force per unit length, that means force on the unit length of this wire, force on its unit length. That will be total force divided by total length. How much is total force? Mu naught I1 I2 divided by 2 pi R into L divided by total length is L. L and L will cancel. So it will come out to be mu naught I1 I2 divided by 2 pi R. Mu naught I1 I2 divided by 2 pi R. Now take a look at the question which was asked. An arrangement of 3 parallel straight wires perpendicular to the plane. This wire, so it is like this. This wire is B. This wire is C. This wire is A. This is distance D. This is distance D. In this particular case, my dear NEET aspirants, I would say current in this is I. Current in this is I. Current in this is I. You are supposed to tell me what is the net force on this. See. Always remember, if you have two parallel wires, this wire and this wire. Okay, this is the current I1. This is the current I2. If the two wires are there placed at certain distance, current is flowing in the same direction. In that particular case, the two will attract each other. With a force. Always remember this. We say they will apply force on each other, that will be attractive. Now see here, we have to find in this particular case, magnitude of force per unit length on the middle wire will be. What is the force per unit length on this middle wire? On this middle wire, this is going to attract with the force F. This wire is going to attract with the force F. Now this is F. What will be the resultant force on this one? This is going to be a root 2 of F. Now what will be the force per unit length? Force per unit length is mu naught I1 I2 divided by 2 pi R. So you can say simply over here, this will be a root 2 mu naught I1. I1 is I, I2 is I. Here also I1. So that is I square divided by 2 pi. What is the distance here? That is D. This is the net force. Guys, these two wires will apply same force. That's why I'm writing F. So F will be force between these two or between these two. That is mu naught I1 I2. I into I is I square divided by 2 pi D. D is the distance between the two. Which option is matching? Root 2 mu naught I square divided by. Do one thing. Rationalize this. Multiply with root 2 and divide with root 2. This root 2 into root 2 becomes 2. That will cancel with this 2. So answer is mu naught I square divided by root 2 pi into D. Divided by root 2 pi into D. This will be the net force. This will be the net force. Magnetic field due to a solenoid. Take a look, guys. This is a solenoid. There is a wire which is basically wind on some. This is a solenoid. Heater coil you can consider a solenoid. Okay. These are the ends of the solenoid. And my dear NEET aspirants, when it comes to the magnetic field due to a solenoid, listen to me very carefully. Listen to me very carefully. I'll make you understand this. Magnetic field due to a solenoid. I'll make you understand this. See, guys, when it comes to the magnetic field due to a solenoid, it will be mu naught n into I. N is what we call the number of turns per unit length. N means number of turns per unit length. Number of turns per unit length. Okay. Yes. And you can write this N also as capital N divided by L. Total number of turns divided by total length. So this magnetic field due to a solenoid will come out to be, this is mu naught, that is N into I divided by, I would say, okay, divided by, I would say. Okay. So N is what we call number of turns per unit length. So magnetic field you can also write mu naught N into I divided by L. This is the magnetic field at the center of the solenoid. And always remember, magnetic field in case of a solenoid is along the axis of the solenoid. Something like this, along the axis of a solenoid. Okay. And at the ends of the solenoid, magnetic field is mu naught n 1 by 2 mu naught n into I. That is, magnetic field at the ends will be half of the magnetic field inside. And when I say magnetic field outside the magnetic field outside the solenoid is 0. This is the graph. This is the graph. See, magnetic field here will be inside. Guys, this is the center. So from center to the close point, it will be constant. Magnetic field is constant. And at the ends of the solenoid, we say magnetic field becomes half. See here. It becomes B by 2, half of the half as compared to the magnetic field inside. Okay. Magnetic field due to a toroid. Okay. What is toroid? Toroid is a cylindrical shaped solenoid. If let's suppose you have a solenoid. Okay. Now you make it of the cylindrical shape. You make its shape as a cylindrical shape. It will become toroid like this. This is a toroid. Okay. And in this particular case, if I say magnetic field, you say, sir, mu naught n into I divided by L. What is the L of this length? That is the circumference. That will be 2 pi into R. Whatever is the magnetic field of solenoid, same will be for this now. So that is 2 pi R. Magnetic field will be 2 pi R. Okay. So magnetic field is mu naught n into I divided by 2 pi R. And number of turns per unit length will be n divided by L. L is 2 pi R. Okay. And here we define, in this particular case, one more important thing that we define is, guys, Guys, when we make a toroid, this is the outer inner radius of the toroid, that is R1. This is the outer radius of the toroid, that is R2. So we say here magnetic field will be, that is mu naught n into I, 2 pi into R1. And when I say here, and this is what we call the maximum magnetic field, because if R is less, magnetic field is maximum. Here field is maximum. So when I say minimum magnetic field, that will be mu naught n into I divided by 2 pi into R2. Here magnetic field is maximum because if R is more, field will be less. Field will be less. Let's talk about this. This is a question from NEET 2020. A long solenoid of 50 centimeter. There is a solenoid, its length is 50 centimeter. So 50 centimeter means 50 into 10 raised power minus 2 meters. Of 100 turns means total number of turns is given as 100. Otherwise, it would have mentioned number of turns per unit length. Carries a current of 2.5 ampere. Current is 2.5 ampere. The magnetic field at the center of the solenoid is, we are supposed to find what is the magnetic field at the center of the solenoid. That is mu naught n into I divided by L. So magnetic field is going to be mu naught is 4 pi into 10 raised power minus 7. N is 100, so that means 10 raised power 2. And I, current is 2.5 divided by length of the solenoid is given as 50 into 10 raised power minus 2. You can find the answer from your end. Okay. Okay, we are done with the magnetism and this magnetic effects of current. What else do you have in the magnetic effects of current? Okay, this is the magnetism and matter portion. This is the magnetism and matter portion. Now guys, take a look. Take a look. See guys, magnetic dipole is there. My dear NEET aspirants, let's suppose you have a minus Q charge over here, you have a plus Q charge over here. Separation between the two is D. So we say they have got a they have got an electric dipole moment. This is electric dipole. Electric dipole moment is Q into D. Similarly, in magnetism, you have a magnetic dipole. And here magnetic dipole is considered as a bar magnet. A bar magnet which you buy from the market, no? Bar magnet. Bar magnet means magnetic dipole. Magnetic dipole. Bar magnet means magnetic dipole. Now, my dear NEET aspirants, we say if you buy a bar magnet from the market, it has south pole, it has north pole. It has south pole, it has north pole. Okay. So, my dear NEET aspirants, it has south pole and it has north pole. So, this is going to be, south pole has got a dipole moment of minus m, north pole has got a dipole moment of plus m. And this is what we call the pole strength. This is what we call the pole, not the dipole moment. This is called the pole strength. This has got the pole strength minus m, this has got the pole strength plus m. Okay? Yes. Now, my dear NEET aspirants, this is the length of this dipole. So this dipole will also have dipole moment that is represented by capital M. So that is M into L. So where M is what we call, this M is what we call the pole strength. Okay. This M is what we call pole strength. and L is the separation between the two poles. Like you have over here dipole moment, similarly you have over here dipole moment, and this dipole moment M is from minus M to plus M, south pole to north pole. Okay, so this magnetic dipole moment is from south pole to north pole, and here bar magnet is considered as magnetic dipole. Now see, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. Do you remember I told you previously, guys, see, if this is an electric dipole, at this general point, what is the electric field? Sir, electric field at this general point is Kp divided by x cube. This is x. Then we say under root of 3 cos square theta plus 1. Sir, at this actual point, electric field is 2 Kp divided by x cube. Sir, at this point, equatorial point, electric field is, that is Kp divided by x cube. This is what we studied previously. Exactly replica over here. Instead of electric dipole, you have over here magnetic dipole. Instead of electric dipole over here, you have got magnetic dipole. Okay. See. So this is the magnetic dipole that you have got, M. So this will be minus M. This will be plus M. Now guys, first and the foremost point, at an angle theta, you have to tell me the magnetic field. Guys, what is the constant? What is the constant in electrostatics? That is K. What is the constant in magnetism? Mu naught by 4 pi. Here it is 1 by 4 pi epsilon naught. Here it is mu naught by 4 pi. Okay. Here dipole moment is P. Here dipole moment is M. Here it is x cube. If you are saying this is R, you can say x also. Here it is x cube or R cube. Then you say 1 plus 3 cos square theta. 1 plus 3 cos square theta. Sir, exactly similar. Yes. So here constant is 1 by 4 pi epsilon naught. Here constant is mu naught by 4 pi. Here dipole moment is M. Here dipole moment is P. Rest everything is same. At actual point, magnet electric field is 2 Kp by x cube. Here it is 2. Instead of K, mu naught by 4 pi. Instead of P, you have got M, and this is R cube. Okay. Oh, I am seeing. I know the stream will end at 12. Before 12 hours, I'll have to end the stream. Don't worry about that. I know I'm a techie guy, okay? I've done engineering in my computer science. Not like you guys, bio guys. Don't tell me. Don't teach your teacher. Now guys, at this particular point, this is the equatorial point. Okay, this is the equatorial point. At equatorial point, electric field is due to the dipole is Kp by x cube. So here it is going to be mu naught by 4 pi M divided by R. So if you remember these three, you can remember these easily. This is the magnetic field due to the magnetic dipole. Similarly, do you guys remember torque on an electric dipole placed in the external magnetic field? Electric field. If this was the external electric field in which dipole was there, so torque was produced, that is PE sine theta. Here it will be MB sine theta. Magnetic dipole moment, magnetic field sine theta. Whenever this dipole is placed in the external magnetic field, this is the magnetic pole strength plus M, this is the pole strength minus M. Force on this will be backward, force on this will be forward. Due to this force and this force, this dipole will rotate. So when this dipole rotates, torque will be created MB sine theta. And that MB sine theta will be M cross B. Okay. Okay. M cross B. Then my dear NEET aspirants, if I say if the value of theta is 0, what will be torque? That is MB sine 0. Sine 0 is 0. Theta means 0. The dipole is placed something like this. Angle between dipole moment and magnetic field is 0. If I say angle between dipole moment, this dipole moment is backward and magnetic field is opposite, sine 180. Sine 180 is also 0. If I say magnetic dipole is something like this, what is the angle over here? 90. So theta is 90. MB sine of 90. Here will be MB. This is the maximum torque. This is the maximum torque. Okay. Potential energy of a magnetic dipole. If a magnetic dipole is placed in the external magnetic field. Now guys, if I say you displace this magnetic dipole at an angle theta, you'll have to do the work. And due to that work done, I can say its potential energy will be changed. Again, the same thing I am repeating. And work done by conservative force, that is magnetic force, will be negative of change in potential energy. Exactly, sir. This is the fifth time I am repeating the same thing. In work power energy, in gravitation, in electrostatics, and in magnetism. In magnetism. Okay. And if I say, how much is the potential energy stored at an angle theta? That is minus m dot b. Or you say minus mb cos theta. Minus mb cos theta. Okay. That is minus mb cos theta. There is a question over here. See guys. A bar magnet is hung by a thin cotton thread in a uniform horizontal magnetic field and is in the equilibrium state. The energy required to rotate it by 60 degrees is W. See guys. There is a bar magnet inside. Okay. It is at an angle of, I would say, 60 degrees. This is 60 degrees. It is at an angle of 60 degrees. This is the magnetic field. Bar magnet is at an angle of 60 degrees. The energy required to rotate it by this is W. Okay. Now the torque required to keep this in the new position will be, guys, see. Let's suppose if you displace this dipole, you placed it at an angle of 60 degrees. Okay. So my dear NEET aspirants, what I'm trying to say is that, first of all, you tell me how much is the torque acting over here at this angle. That is MB sine of 60. So you say torque will be sine 60 is root 3 by 2. That is root 3 divided by 2 into MB. Okay. Now, my dear NEET aspirants, see, you are supposed to tell me how much torque is required to keep this in this position. There is a bar magnet. You have displaced it by this much. Now, this is the plus M. This is minus M. On plus M, force will act in the forward direction due to magnetic field. On this, force will act in the backward direction in the magnetic field. It will try to bring the dipole back. Now, if you want to keep this hold at this position only, how much torque you need to apply? That is this much. But sir, this is not the option. See, if I say, my dear NEET aspirants, how much work? We say the energy required to rotate it by is W. How much work has been done? So work done is equal to change in potential energy. Work done is equal to final potential energy minus initial potential energy. So work done, that means energy, how much work has been done, how much energy has been given by rotating it this much, that is W. So final potential energy is minus MB sine of 60 minus, what is initial potential energy? Minus MB, not sine, it is cos, minus MB cos of 60 minus MB cos of 0. Now this will be minus MB cos 60 is 1 by 2. MB divided by 2. Minus into minus is plus. Cos 0 is 1. That is MB. MB minus MB divided by 2. MB minus MB divided by 2. That is MB by 2. Okay. So MB by 2, this is the work done in rotating the dipole by 60 degrees. So now put it over here. So you will be like, so this torque will be, instead of MB by 2, you can write W. This will be W root 3. W root 3. Okay. Okay. Now, my dear NEET aspirants, in this particular case, a current carrying loop behaves as a current carrying loop behaves as a magnetic dipole. See guys, whenever there is a current carrying loop in which current is flowing, this is a current carrying loop, and in this current carrying loop we say current is flowing in this one. Okay. And my dear NEET aspirants, we know this current carrying loop produces the magnetic field at the center. So if this produces the magnetic field at the center, we assume that it is behaving like a magnetic dipole. Because see, bar magnet creates the magnetic field. So if this current carrying loop also creates the magnetic field, we say this also behaves like a magnetic dipole. And its dipole moment will be, guys, I into A, current into area. I is the current, A is the area of the loop. Like a bar magnet behaves like a magnetic dipole because it has magnetic field around it. Similarly, my dear NEET aspirants, what I can say, this current carrying loop also behaves like a magnetic dipole. Its dipole moment is I into A. I is the current, A is the area of the loop. And direction of the magnetic dipole moment is along the area vector. Like, see, curl your fingers along the direction of current. So this will be the area direction of magnetic moment, perpendicular to the area, perpendicular to this, perpendicular to this. So simply remember, a current carrying loop behaves like a magnetic. We consider it magnetic dipole. Its magnetic moment is I into A. Even my dear NEET aspirants, when an electron revolves around the circle, orbital magnetic moment of an electron, when an electron revolves around the nucleus, electron revolves means charge is revolving. Charge flows means current is being produced. So current is being produced in the opposite direction. If this moves like this, in the opposite direction, the loop. So when charge is moving in an orbit, current is being produced in the loop. So it also behaves like a magnetic dipole. So its magnetic dipole is, my dear NEET aspirant, that is EVR divided by 2. EVR divided by 2. This is the magnetic moment of a revolving electron. Now, my dear NEET aspirants, there is only one topic left in this, that is moving coil and galvanometer. What I would recommend you over here is, rest I have completed everything. What I would recommend you over here is, there is a lecture on YouTube, Game of NEET 2.0, Magnetism, complete chapter. Over there, you'll go like here. From here onwards, you'll have to watch, because this will be the complete theoretical portion. It is just the wastage of time here. Complete theoretical portion. You watch it from this point to this point. So in this, you will be covering the moving coil galvanometer also. You cover this moving coil galvanometer also. And further, there are 2 to 3 topics only, or not 2 to 3, just 1 or 2 topics. I would say that paramagnetic materials, ferromagnetic materials, okay, types of magnetic materials, that you will be completing over here. So we are done with this chapter also, okay. So rest you will be completing here, because it is very easy. You would be able to do it just in I would say 30 minutes. Then we have chapter 5, that is EMI. This I will show you in the next stream, because right now the time is, we say the stream maximum length of the stream is 12 hours only. So 12 hours, we are about to reach the maximum time limit. So take care and bye-bye. Thank you so much. In the next session, I'll be starting the electromagnetic induction only. Now only 2 chapters are pending, electromagnetic induction and AC. These are the small chapters. So take care and bye-bye. Do let me know in the comments afterwards how was the session when I end the live stream. Okay. So rest of the magnetism, like types of magnetic materials, that will be completing from this one. Even moving coil galvanometer also. Otherwise, we have completed 98% magnetism we have completed. Take care and bye-bye. Thank you so much. I'll write. Thank you guys, okay? Take care. Huh?